What is
pressure and analyze the word pressure for a second?
Sure, yeah, that's
So-
fine with me.
So it has the word press in it. You know, kind of like I'm pressing my finger against the wall right now. My finger presses against the wall.
Yeah.
That causes pressure against the wall. So what I'm saying is, do you understand how, in the definition of gas press,
Yeah,
sure.
No, I understand.
That
but
when it says that it's defined as the force exerted on the walls of the container by the gas inside of it, and gas is omnidirectional. Gas goes up, down, left, right, forward, backwards. So if gas is omnidirectional, which you and I both know it damn well is, and the definition of gas pressure is the force exerted on the walls of the container by the gas inside of it, and air pressure is gas pressure. What does that mean?
I want to make an argument.
Are we inside a container? Or are we not inside a container in order to have the gas pressure we breathe?
So I want to drive down into what pressure is, because I agree that's very important. Pressure is just a model for the actions of a lot of gas particles. That's all pressure is. Pressure is just a number we can assign, a number that we can
it's not.
give to the action of a lot of gas molecules.
It's not a model. It's objective reality, right? When we pump butane into a tank, right, then we observe that the butane is being pressurized in the tank. It's not a model, bro.
But if you zoom in, if you zoom in to the wall of the butane tank, right? If you zoom in to a microscopic level, what actually is happening at the wall of the tank?
The gases are colliding with the walls of its containing, creating the pressure.
That's right.
Without the walls, you will have no gas pressure.
But pressure isn't actually like a property of the space.
One step back. No, not but.
What you observe is just the molecules bouncing against the wall.
One step back. Without the walls, you will not have pressure, right?
Sure.
Okay.
What I'm saying is,
there you go. Well, there you go.
At the microscopic level, pressure doesn't exist. All we're seeing is just molecules bouncing off of each other and bouncing off of this wall.
Creating pressure. Pressure
doesn't exist at this scale. Pressure doesn't exist at the microscopic scale. Pressure is just a way of labeling
without the walls.
All of these pressure is just a way of talking about and calculating all of these bouncing interactions at a large scale.
It's not talking about or calculating.
It's a very accurate way of talking about and calculating, but it's not. But it's just a shorthand. If we were able to be super accurate, what we would do is we would just take a computer and calculate all of the trajectories of all of the gas particles within this butane tank, right? And that would give us the perfectly accurate, but we can't do that. Turns out that there's this model we can use to describe the behavior of all of these gas particles, and pressure is that model.
It's not a model, bro.
It is.
No, it is observable, testable reality. When you put that butane in that tank, it will cause the butane to pressurize.
What's the pressure? If you have a single butane molecule in a tank, what's the pressure of it?
So go ahead. Do that for me. Who's done that?
What would the pressure be?
No, we're not going to
it depends
Narnia.
On the tank.
Who has done that? Who has done and put one butane molecule in a tank and measured
Never been done.
That's not the question though. I'm asking you a hypothetical.
So we are going into Narnia, right?
What would it be?
Reality.
What would it be?
What would it? That's not my problem. That is you conjuring up Narnia and saying,
we're allowed to talk about Narnia.
It doesn't matter. The answer to your question doesn't fucking matter.
But we're outlining concepts here. We're
now
we're in concept land, so we're already in Narnia.
No, Ed Monk, no.
Why are you getting so worked up? If it's clearly speculation, hypothetical speculation.
Why is gas pressure speculation now? That's observable, testable reality. That is what he can do. He can put butane.
if he's clearly speculating like a hypothetical.
I know, but he wants an out.
Well that it's a speculative
hypothetical. He wants an out. He wants to go into Narnia and then conjure up a story with one molecule, and then we'll look at what if we have one. That's never been done. Never. He cannot show it. He cannot show gas pressure without containment.
Hypothetically, and Monk, the answer is it depends on the size, the volume of the tank.
Well, how would we even measure the pressure of a single molecule of gas? Like, how would we measure the pressure?
That's a you problem.
How do you know you have a single molecule to begin with?
Can you just accept reality, how it is presented to you, that you need a containment for any pressure to exist? Can you just accept that fact, or do you need to wander off into what if we look at things that we can't really prove because you need things that you don't have in order to actually show that my theory might be true thingies, like they always do in the heliocentric model. Everything in the heliocentric model is most of the time things that you yourself cannot prove because either they're hypothetical or they are things that you're not capable of because you don't have the machinery to do so, or they're just very far away or too big or whatnot. It's always
so like this stuff, all this gas related stuff. This is stuff that is used in engineering every day. Like these definitions of what gas is and what pressure is, and like all the stuff I'm saying. This is just like a standard.
Engineers still need a containment for anything they want to pressurize, man.
Right.
Show me someone on this earth who doesn't.
But these definitions, these conceptual definitions of like what a gas is, this is like standard what engineers use to make all the motors in our world go.
I would love you to accept the reality of what these engineers are bound to, which is, for example, the second law of thermodynamics. Just accept the fact how reality is, and then you would understand and move on that your heliocentric model is impossible. Okay,
these engineers accept that gas is just that these engineers that you're saying I should accept their what thermodynamics is. They're also saying that gas, that pressure is just a model. If you go to an engineering school and you take a thermodynamic class, they're going to tell you that pressure is just a model to describe gas at a large scale.
Pressure
Okay, so
I have an engineering degree. That's what they told me.
What about
pressure
other forms
is the
of pressure?
same thing that comes out of my containment sometimes at the day, man. I know what pressure is.
What about the pressure of a physical object, like applying a force onto you?
Yeah, so this is all great and all, but as long as those engineers or you or anybody else, as long as nobody has any demonstration of gas pressure being caused by gravity, then this whole conversation is pointless. Like, there's no such thing as gas pressure existing without containment until you can demonstrate gas pressure without containment.
We can show gas pressure being caused by gravity because we can measure different gas pressures at different altitudes.
Hold on, bro. Relax. Okay, so did you manipulate gravity to show that it was the cause?
We manipulated the altitude, and the altitude affects the amount of gas above us.
Hold on there, bro. Is gravity the cause or is altitude the cause?
Altitude is a way to measure the effect of gravity. That's how the experiment works.
No,
how do I know you're not just making a baseless assertion, right?
Yeah, you're linking the two without evidence.
You got to show me the evidence, right? You manipulate gravity and show me it manipulating the gas pressure, and then we can talk about that.
So if we manipulate the altitude at which we make the measurement, we're manipulating the amount of gas above the place that we're manipulating. And if we make it higher, then the pressure is going to be, if we make it the altitude higher, the pressure is going to be lower because there's less gas above us. And if we make the pressure lower, then the amount of gas above us is lower.
Yeah, it doesn't need.
So what does that have to do with gravity?
Gravity is the force that actually transfers this.
Whoa, bro!
Gravity's
not a force. Gravity's not a force.
Gravity can be very accurately modeled as a force.
But Enmark, everything you said, like these density layers, they don't necessarily require gravity. this force pulling down. It might just be that these gases have a certain weight to them, and in the medium that they're in, they're more dense, and that's why they go down and they stratify in layers. You haven't shown any sort of like mass attracting mass type of necessity.
Okay. There are other ways. Like we could get into Cavendish and all this stuff. These like ways of demonstrating mass attracting mass.
Yeah. Let's get into Cavendish.
There are really good reasons.
What's the independent variable of Cavendish?
The independent variable of the Cavendish is the distance that the small balls are from the large weights.
So the small balls cause what?
Or another independent variable. There's another independent variable that we could have, which is the size of the small weights. That's another independent variable.
Okay. So we got two independent variables. One of them is the distance of the balls.
There's lots of different ways we could run this experiment. So there could be multiple different independent variables.
Okay. What was Cavendish setting out to prove to begin with?
He's setting out to prove that the acceleration we observe between masses is an effect of, or it's a function of the mass of the objects. So the larger the mass.
Are you sure?
No, he wasn't. He actually accidentally discovered this because he was setting out on just doing something else.
Oh, then okay. In that case, yeah, I see what you're saying. Like maybe Cavendish himself was doing something else. But if we're running the Cavendish experiment like today, we can the way that you could set up the experiment, you could say
your hypothesis would be.
Yeah. The hypothesis would be that if you have that the movement of an object is influenced by the mass of the objects around it.
All right. So what did you manipulate? What was the independent variable you manipulated?
So there's two different variables that we can manipulate to do this experiment. We can manipulate.
How is there two different independent variables? So the independent variable means it's independent. Hold on. Independent variable means it's independent from all the other variables that you're manipulating. So when you say there's two independent variables, I don't know what the fuck you're talking about.
Experiments can have multiple independent variables.
Versions of the experiment, basically.
Yeah, and experiments can have multiple independent variables. Like if you're doing a medical experiment, you could change you could change how much medicine people are getting. You could also change
two separate experiments. Then, if you have more than one independent variable, then you have two separate experiments.
Yeah.
Why couldn't you run a single experiment where you change the amount of medicine you give someone and the time of day you give it to them, and you just give it to you set up an Excel spreadsheet where you give it to 10 people at this time, 10 people at this time, and then you have a cross, the columns of the Excel spreadsheet.
You
could do that. Technically, it would be like two mini experiments for a larger experiment.
Okay, this is a side issue. So I agree.
Hold on. Yeah, let's focus on one experiment, one independent variable at a time.
Let's say we're just going to change the distance that, let's see, well, how do we, we're going to change the mass. Let's just change the mass of the large weight. That's all we're going to change. That's our independent variable.
Okay. So when you change the mass of a large weight, that causes what?
That is going to cause a change in the acceleration of the small object, the small weight.
Okay, so let me get this straight. You change the weight of an object, it changes the acceleration of another object.
That's the hypothesis.
Therefore, gravity. Therefore, space-time.
Therefore, mass can be shown to attract mass if it's the kind of acceleration that we predict.
So, special relativity and how it's a force-space time continuum, right? You haven't heard of the hot newness?
That's general.
Listen, I know that's
not special.
Yeah, see, here's the thing.
Relativity is just another way to work out the math, basically. The Cavendish can work under relativity or Newtonian.
Do you know the difference between 3 space and 4 space?
I mean, I know the thing you're getting at, which is just that relativity is a different view of gravity than Newtonian gravity. But both of them are going to make the same predictions at the scale of the Cavendish experiment. So it doesn't matter.
Do you know the definition? Do you know the definition of mass, right? Because it's really important that we understand that resistance to acceleration attracts resistance to acceleration. Is that what you're claiming?
That's one definition of mass. That's like the Newtonian definition of mass. But this whole relativity thing, I don't think it's on the question. I think we can use relativity to analyze the Cavendish experiment, and we'd get the same. We would make the same decisions about like our hypothesis test, or we could use Newtonian mechanics to analyze the Cavendish experiment. We're going to reach the same result.
Larry, what's your contention with how he laid out the experiment? Like, is it a valid experiment in your eyes?
First of all, he said there's multiple independent variables for one experiment, which is impossible. That's why it's independent.
I stuck to one.
Okay. Right. Okay, so you're sticking to one. But then you're saying we can make it work out, mathematically when we're doing a Cavendish experiment for either Newtonian or Einsteinian. But the thing about it is, one has a space-time continuum, right? And then the other one is a free space, which are completely contradicting models. So you're saying that you can make it work out mathematically for both of them. I want to see it worked out scientifically. Get some space-time, manipulate that. Hold on. You asked the question. I want to see somebody get some space-time, right? Put that in a jar, paint it yellow, manipulate that, and then when we see that it has effects, then we can say, okay, Einstein space-time, it's a real thing. You can directly observe people manipulating it, and it has a cause-effect relationship between mass and particles and Newtonian particles, right? But until then, it's a just so story. It's a mathematical concept to explain, right, all sorts of things that we see in the sky, right?
To be fair, Larry, you're kind of diverting from what you were testing him on the validity of his science, the scientific method, on how valid Cavendish was, and then you kind of just diverted away from it. And I thought it was really interesting, and I'd like to get back to that, if possible.
Go ahead, I'll be quiet.
I mean, sure, if you want me to do it, but my thing with Cavendish is I have no flaws. I see no flaws with his theoretical explanation, his hypothesis, his test. It would show, if that's the case, it would show for some reason the mass of this ball is attracting or causing acceleration in the mass of the other ball. And for me, theoretically, that would be whether it's due to electromagnetism or due to supposed gravity. I don't think you can extricate the two from each other, so it doesn't matter. There would be mass attracting mass.
Okay.
My thing is, I just want to see.
I think we can isolate the electromagnetic effects from.
I don't think you can
from the experiment. Yeah, we can. What would prevent us from saying?
Because
we know we can predict what the electromagnetic effects of this object would be, and then subtract it from whatever acceleration we see. And if we still see acceleration, then it's something else.
Yeah, because electromagnetism is
zero-point energy
to matter. It's inherent to matter. Even if you cover everything with some copper foil, or put it in a Faraday cage, or whatever you do, there's still inherent an effect on the magnetic field as a result of that matter itself, the mass itself, the object itself. So who's to say how exactly, what you need to do to absolutely eliminate it? I don't know. We don't have a control to say what eliminating it is. So I don't think we can ever extricate the electromagnetism that's inherent to matter from the matter itself. It sounds like a fool's errand.
So in medical experiments, they have methods to reduce the bias of the genetics of the people in the experiment, right? They can never fully get rid of it, but they can get rid of it enough to where they can measure a difference if it appears. And I think that's the same. A Faraday cage or foil or whatever, copper, the different ways we can get rid of electromagnetic radiation, electromagnetic effects. We can get rid of it enough to where we can measure if something else happens.
You could get rid of electrostatic effects with Faraday cage and with copper foil and stuff like that. But I don't think you get rid of the electromagnetic field, which is ubiquitous. It's everywhere. I don't think you can
But it's not like it's something. It's not like it's totally.
Cage, inside, you still have electromagnetism inherent to the gas inside. You still have electromagnetism. You can't get rid of it.
But it's not totally chaotic. We can predict the effect that it has. We understand electromagnetism. We use electromagnetism all the time. We have a very accurate model for what electromagnetism is.
there's no control for this latent amount of electromagnetism. We've never once had like a vacuum chamber void of electromagnetism. We can't block it. It's everywhere. It's inherent to the matter. We can't block it. That exists everywhere. So
we can't block it. But for different materials, we know that what the force is, what the interaction that different materials have with the electromagnetic field, right? You can take some object, like a lead block and a steel block, and a magnetized steel block, and you can bring them up against a magnetic field, and you can see what effect the field has on the acceleration of that object, right?
What do you mean bringing it up against a magnetic field?
You can introduce you can just like bring a magnet close to...
Oh, like have a strong magnet, okay.
Yeah.
But you realize that the magnetic field is everywhere. It's just you may be introducing a strong magnet to make it more pronounced, more observable or something like that, but it's always existing. You don't have a control, you're just introducing more.
But we can measure it. We can have a measurement of the magnetic field to see what the acceleration should be. And if it's very low, if the magnetic field in our experiment is very low, then we can disregard its effect. Like if you're trying to predict the...
Let's say you have a chamber, okay? It has air in it. Just the chamber, you haven't turned on the vacuum or anything. How are you going to measure the latent electromagnetism inside that chamber?
Oh, you could use like a compass or something, right? Like how aligned does or like just like a magnet.
What if it's incoherent?
What do you mean?
First off, a compass isn't really, qualitatively accurate. It's not very precise.
We can make an accurate one where we measure the angle very specifically, right?
Are you speculating?
I'm sure people have done this kind of thing where you make a very accurate compass that can, if you're, there are ways to measure the strength of a magnetic field at a certain point. Like we use it like an MRI, they have to, when they're making an MRI, they have to, make super specific measurements of how strong the field is at different points. So this exists in the world, like ways of measuring how strong the field is.
That's not really addressing what we're talking about. You're talking about it's like observing its alignment to the magnetic field of the Earth. I'm saying every single thing of matter has its own electromagnetism. It's inherent to it. So
I see. But there's one continuous...
to actually extricate it from the matter itself. Just like you can't take away Earth's magnetic field from the Earth.
But all of these objects that influence the magnetic field, they each contribute something to the magnetic field. But you can...
Do you think that there's just one magnetic field and all these objects contribute to it? Or
that's the definition of a field.
No, I would say everything has its own field and affects each other.
Everything has a contribution to the magnetic field. But if you bring two magnets together, right? Think about like a ray gun where they have, or like a mag ray gun where they have a line of magnets and and they have another line of magnets and they put a ball in between and it shoots the ball forward. Do you think it'd be stronger with one of the line of magnets or with two?
Sorry, I kind of are you saying that there's two serial sets of serial magnets?
I'm saying each row of magnets contributes to the same magnetic field.
I disagree with you. Because what you're basically saying is that Earth does not have a magnetic field. Earth just contributes to this, I don't know how you would even term it, this totality of a magnetic field of everything that exists everywhere.
That is what I'm saying.
I don't think that's accurate, man, because what about
that's nonsense.
What about all the magnetism of all the things, of all the other so-called planets and all the things in the sky and the sun and all of that?
Under the definition of a field, the way we use it, the way scientists use it, they do have contributions. They're just so small that they wouldn't make any difference to our calculations.
So if we were to have some, what is it called when they have the little pieces of iron and they light it up and you can see the magnetic lines on it? Ferrous, there's a word for it. You guys know what I'm talking about?
Non-ferrous, liquid or whatever.
Yeah, ferrofluid or whatever.
Yeah.
You have ferrofluid, and you have these magnets that you mentioned. One row of them, and then 2 rows of them. You don't think those lines would be coming out and like around these magnets?
It is, but
well, then when you have a source, field, then if it's centered, if the focal point is the magnet, then it's a field around that magnet. It's not contributing to a larger field that's around something else.
So when an object contributes to the magnetic field, its contribution to the field is relative to the distance from that object. So if you have a magnet on the table, its contribution to the total magnetic field is going to get weaker and weaker the further you get from that magnet. So that's why we can, when we look at this ferrous fluid or whatever, it looks like it's the magnet that it's closest to is the focal point, because magnetism, the power of a magnet decreases the further you get away from it. And so that's why it looks like that's
what you were saying was true, where there's this one total magnetic field, then when we have a ferrofluid or what have you, you're not going to see this magnetic field around the ferrofluid. What you're going to see is, if let's say we had a super large ferrofluid that covered the entire Earth, you're going to see these really big and like long magnetic lines, which is the ones that our compasses align to, and you'll just see that this row of magnets just barely, maybe even negligibly moved that larger line. That's not the case. We have everything that has a magnetism has its own magnetic field, and sure, it might all like coalesce, just like you have different vectors that, when added together, have give you one vector, but there's the local.
That's exactly what I'm saying. That's exactly what I'm saying. All of these fields. So that's another way of looking at it that I think arrives at the same result. Each of these objects is going to contribute one vector to whatever object's interacting with its field, and we can just add those up. It's the same result as if we just consider each object as contributing to a single field. It's the same result.
Okay, but they do have their own individual vectors or fields.
We can think of it either way. It's going to be the same result. We can think of each object as having its own field, and just each object has it. You can say, okay, what is the contribution that this object's field is giving to some smaller object, and add all of the fields
my point
up.
is that theoretically, I agree. If this actually happens, where you introduce a mass, and I would want to see it in the vertical axis. I wouldn't want to see it in the horizontal classical Cavendish apparatus. I'd like to see a vertical Cavendish type thing where they introduce a mass and then the acceleration actually changes. Like if you have a gravimeter or something like that, and then you introduce a large mass over or underneath, and it changes. Then
they've done that.
I can't deny the evidence.
I've
never seen that.
They've done that where what they do is they like have just a large object hanging, and then they take basically the weight that's on the line that it's hanging on, and then they bring a big metal or whatever sandbag underneath that object, and the weight that's on the line increases by a very small amount.
Do you have like a video for this? An idea?
I could try to find it. I could try to find it real quick.
Where the temperature and pressure is modulated so that
we
know definitely
it's unlikely that I'm going to find a video with the exact prescriptions that you're saying, but I'm saying that they've done things like that.
Yeah, I've heard the claim. I've searched for it myself. I've seen there's like a GIF where they show this scale basically with this triangle weight, this like pyramidal weight that's hanging.
That's the one I'm talking about.
Yeah,
that's one
I've seen the GIF. I haven't seen the actual video though. Easily just doctored in terms of the GIF. So I'd like to see
I'm not going to be able to give you the most I'll be able to find you is like the same YouTube video that the GIF came from, but
No, I haven't seen the YouTube. I haven't seen the video. I've only seen the GIF. I've been looking for the video. I think maybe I've seen the video and there's a cut, but
it's not going to change. It's not going to change. Like if I give you the YouTube video could still be doctored.
No,
it's not going to achieve your standards.
One cut, one like raw footage, one cut. I'm definitely more likely to believe it. It increases the confidence.
It's probably not. A lot. In all honesty, it's like a science documentary. They just like cut a bunch of experiments together because it's it's just like to teach kids science. It's not going to be what you want.
Well, I was hoping that, this is something I researched maybe a year and a half ago. I was hoping that since then someone would just, like someone that had a gravimeter for work, I don't know what work actually uses gravimeter, but that they would have just used it and then put a weight above or underneath and used it again and shown that this little ball inside this gravimeter is actually accelerating at a different rate. But as far as I know, it hasn't been done yet.
That'd be cool. But we never kind of resolved the like magnetism thing. Like, do you think that if we could accurately measure the magnetic field around an object, that we could account for it, like control for it in a Cavendish experiment?
I don't see how. How would you... To control for it means to either keep it the same, always, right? And how are you going to do that when you have different objects that have their own things that are going to be affecting it? Or to somehow delete it, like eliminate it. And I don't see how you doing that on account of it being a function of the matter.
So think of it this way. So like, if there's a rocket, that's and we want to see how much of the rocket's speed has to do with its own with its own like fuel, and how much of it has to do with the push that somebody is giving to it, right? Or like if you're like biking, if you're biking and your brother is pushing you on the bike, and you want to see how much contribution are you giving to your speed, and how much contribution is your brother's push giving your speed. We could do the same thing with the Cavendish experiment, where we say we know that the magnetic field in this environment is this much, so we should expect the contribution due to the magnetic field to be X. We would just subtract that from the total speed, the total acceleration that we see, and we would get this other contribution that we don't have an explanation for yet.
See, I think it's dicey because you're presupposing that what you're trying to prove. It's a little bit circular logic.
What are we presupposing?
You don't know for a fact that there is this, gravity that is separate from electromagnetism causing this mass attracting mass. That's adding. You don't know that there's a brother pushing you.
Right. Okay. But if we do see this other contribution, and we don't know what it is, and then when we do lots of experiments, we manipulate the mass of the objects.
I'm with you.
And we see that this X factor contribution correlates with the mass of the object that we're using. I think it's fair to say that the mass of the object is correlated to this extra contribution.
Yeah, it's logically consistent, but you made another assumption right there. You made the assumption that you can definitely, and I have never seen this, that you can accurately and quantitatively control for the inherent magnetism of an object, such that you have X, and know, like you can subtract that and then come up with X. And so I've never seen that.
If you measure,
I don't even think it
magnetic field.
I really don't think it matters, because as long as there's attraction and movement, then you're in the clear. That will debunk the flat Earth idea that there is no downward bias on account of mass. It doesn't need to be from gravity or from electromagnetism. It doesn't matter. As long as there is this movement, then you're good.
Then why isn't the Cavendish convincing to you?
Because I haven't, like I said, I would need it in the vertical axis to show that this actually happens, and I've never seen a video of it. Theoretically, I'm fine with it. I'm waiting for the evidence. I've been waiting for a while, but I haven't seen it.
Can you see, like,
when you got it, we'll check it out.
Can you see why the vertical axis, why it would be more difficult to isolate the gravitational effect in the vertical axis as opposed to the horizontal?
No, I don't think it would. I think it's easier now, especially considering that we have gravimeters. You literally just need to use a gravimeter.
What is a gravimeter? I've never heard of this.
They're those little machines that have basically a vacuum chamber inside, and then it drops like this set mass, a specific distance, to test the gravitational kind of like acceleration in a given area. I think they use it for like maybe mining and geology and different things to know kind of the density layers of the ground underneath and stuff.
Yeah, I'll have to look into that. I don't know.
It basically is a vertical Cavendish type machine. You know, so this is an experiment that I came up with like a few months back when I was thinking of like what steel manning the globe basically, and this is the sort of thing that I would think would be it would definitively prove beyond reasonable doubt that there is this acceleration, mass to mass acceleration, if they had this experiment, because it's the only thing that you would change is introducing the mass either above or below and finding that there is a difference. Again, if it was modulated in a chamber for temperature and pressure, that would be even better.
Yeah, it would be cool to make that experiment. I guess I still don't understand why does it being vertical, why is that more convincing than horizontal?
Because this whole thing is about whether or not there's gravity causing a downward bias, a downward acceleration to objects. It's in the up down what's the word I'm looking for? Up down what?
The model of gravity that the Globers are advocating for doesn't matter which direction. It's just that they're claiming that the Earth is just an object. They're just claiming that the Earth is an object. So like I don't see why it being up down matters
to the claim.
I don't see that. Do you see why the thing I'm missing?
Well, because we never observed mass attracting mass in the natural setting whatsoever, except for if you say the Earth is attracting things by dropping things. That's just that's a reification fallacy. You can't have the Earth as the only example of this in a natural setting. You'd think we'd see mass attracting mass in all kinds of ways if it was vertical, right? I mean, it was horizontal.
Back in 2012, man. Back in 2012, this guy was standing outside my shop and he goes, "Hey, man, if gravity was real, why doesn't the fucking butterfly just fucking is stuck to my car?"
If the gravitational effect is real,
good question.
Then it could be weaker than other forces. Like what would prevent it from just being weaker?
Maybe, possibly, maybe.
Yeah, then you have to say it's not electrostatics, and you can't divide the two. You can't even say, even if you try to get rid of electrostatics with the Cavendish, you're just grounding it, and in a way that completes a circuit. You could say it's still electromagnetism that's causing it. That's a very weak, but yet present force of some sort. And you can't isolate gravity. That's the problem. You can isolate electrostatics though. So
if you can isolate electrostatics, then you could subtract it from whatever force you see, and if you still see acceleration, then it's got to be something else.
Yeah, but you can't rid electrostatics from a Cavendish or even a vacuum.
Right, but we can control for it. We can account for the difference that it makes.
You would think, yeah. You would think, but you can't say it's gravity though, because gravity, I mean, obviously, it very, very easily seems to be outed as reverse engineered and baked into everything. If we're on a flat Earth, that's the way it would have to be, right?
I hate to leave now that my friend New Perspective has gotten here, but
What's up, Ed Monk? Nice to see you, bro.
Yeah, good to see you.
I knew you were in here.
All right, Monk.
Hey, I just wanted to say, Ed Monk, before you go, don't leave. I was going to try to give you a roll. Dang it, I hate this phone. Can a mod give this guy a roll? Maybe like valued, seems sincere, or something like that.
Yeah, sure.
I really enjoy.
He's definitely sincere. I exchanged like many words with this guy in DMs from the first time he came out here. We went through
his roles.
Yeah, he's cool. This guy's cool. He's one of the cooler Glovers.
The rules aren't for you, Monk. It's for other flat earthers.
I've earned these roles.
No, we're not taking them away. We're adding to your roles.
That's fine.
They're gonna give you valued and be the combo breaker.
Well, no
roles you have.
Perfect.
We kind of like you a little bit, Monk.
Thank you very much. All right, I got it. I'm waking people up in my house. I gotta go. All right, thank you. It was a nice.
Take care, man.
Nice talking. See you later.
I'm back.
I was gonna ask him and you guys, what's the charge of light?
Charge of light.
Yeah.
I can see it That's about it.
What are you talking about?
See, my
Something
point
I
is
missed.
that there's a difference between electrostatics, which is like, electric currents, electricity, and electromagnetism, which is like everywhere, light and non-visible light.
Right.
It's not necessarily. You could kind of control for electrostatics and for running electric charges and or electric currents and stuff, but not necessarily for the inherent electromagnetism of everything.
Right. Yeah, I wonder how. I was looking at the strong and weak nuclear forces, and the four main forces. Gravity is in there. So if gravity is not what they're telling us, what are the other things that are also kind of reverse engineered with the strong and weak nuclear force, and possibly even the electromagnetism and how that really works? Maybe because they've also got this. That there's a video I'll repost right now that talks about the way that they reverse engineered a lot of the things with the spinning Earth, and it has to do with the Michelson-Morley thing, and that there was an equation that they added onto it, which it was talking about it on here earlier, but that they got that baked into everything. I saw when I was looking up the four major forces. That equation, that caveat equation was totally baked into that. So who knows? Who knows how much of this has been, even on the other three forces, might have been kind of worked into favor of what they want us to believe.
Well, they want us to believe all kinds of shit. Like gas pressure without a container. Yeah, it's totally possible. Just believe it. It'll be fine.
Yeah, you just need another Earth, right?
Yeah, if I could have another Earth, I could totally show you guys that it definitely can happen. Yeah, exactly. But it has to be the size of Earth. It can't be any smaller. Yeah. The moon won't do, man. Sorry. It needs to be bigger than the moon. And then I can show you all the gas pressure without a container you can handle.
But you went through it all, right? New perspective about how Cavendish isn't an experiment, and
I think he's trying to upload a link or something. He's looking for something. New perspective. He's there. Maybe he got a phone call. I don't know.
Yeah, I was just looking through that video real quick, and it muted me on here. What were you trying to say?
Roger asked you a question about.
Yeah,
what's up, Roger?
Yeah, what's up, man? So you've been with him in DMs, right? And you've probably went through it all, right?
I threw everything I had at him.
Yeah, he knows then the arguments. What baffles me is that he then comes here and then tries it all again.
Well,
yeah, he's really stuck on, he thinks that he's the Cavendish must do what they say. He's an engineer, so he's like, he's got some stock in believing it as far as like, his identity and stuff. But at the same time, he does know the model's in trouble, and he admits that. And he also talks about how the gravity, the explanation for gravity is in trouble with quantum physics threatening the explanation for that. So he's open to the idea of it possibly not being what we're told, but doesn't have enough, or hasn't. I think he's here because maybe he would take that step over the ledge.
Hey, Dave, he's like what, 22, 3, 5, something like that?
No, I'd say he's close to 30, maybe 28, 29.
I think he's way younger, but
really, maybe he is. I don't know.
I think he's
25, maybe.
Early 20s.
I think he's at least 25.
Mm-hmm. And you went through all the curvature things, so this is the only thing that remains then, right? So curvature cannot be proven, and we see too far, and then Earth is a ball because of gravity, not because of curvature, but because of gravity.
Right.
Yeah, that's usually the thing that hill is the one they want to die on, right? So never mind curvature or spin. I want to die on the gas pressure because that's the thing. I can say, well, look at Earth, and then
can I chirp in for a minute?
Sorry,
gravity. I'm dying on the gravity.
Can I chirp in for a minute?
Go for it.
Sure, go ahead.
Yeah,
I've been in here a few times.
Do it, man.
Where's what's his face? No, I was just gonna say, like, man, I'm fucking rolling hard right now.
You're what hard, right? What?
I'm rolling.
Nice.
Rolling.
Nice.
Rolling.
How you feeling, brah?
No, I'm feeling good. I'm just saying I'm rolling.
Right on. Get the flat earth truth.
Yeah, I know about it.
Right on.
Sweet, man.
Yeah, I've seen you before. What's up, Slug?
Hey, what's up, man?
Cool, man.
So how'd you find this server? How'd you find this server, man?
I found it a long time ago.
He didn't find the server. The server found him.
Or something like that, yeah.
It happens like that too, man. Yeah,
Yep.
Cool, man. What's your what part of the world are you on, man?
It seems like you jumped in to say something, but you just wanted to let us know you're rolling pretty hard, huh?
Yeah. Well, I just took like little 2 ecstasy pills.
All right, man. Well, the x-axis is crossing the z-axis.
But I supplement it. X-axis.
Is it some good Molly? Some good Molly or what?
Don't be crossing those axes, man.
Nice.
Of course, man. You gotta take care of yourself too.
Mm-hmm.
Yeah, not to make this the topic, okay? I mean,
the topic is about flat Earth. My bad. So basically, what got me into flat Earth? Listen,
dude, today was like an epic day out here, man. By the way, sorry, Slug. Go ahead.
I was just saying, like, because you think about it, only in your head, like, let's say you're buzzing off a few beers, you feel like you're spinning, right? But you're really not. Everything's stable.
Right.
Right.
I was saying that early this morning, man. Like,
some good lady explained it.
Drunk people feel the spin, man.
Right. I'm drunk too, a little bit.
You sound all right. You're not completely wrecked, yeah, man. You're good.
Yeah, because I take care of myself and I supplement. You can't, you know.
Water,
Drink some water, all that Gatorade, electrolytes, all that.
No, don't drink the Gatorade, man. Drink,
zero sugar, bro.
No, that's full of like chemicals and shit. Don't drink that crap.
It's a kid with I know what you mean, though.
Drink, water's good.
Yeah.
Little bit.
Anyways, bro. What's the whole group? What was the group talking about before I came in here?
We were talking about
gravity. Sorry. Yeah, I went and looked at that video because I was trying to think of what that equation was that they baked into everything, and it's the Lorentz equation. Right. And it has to do with the Lorentz contraction that they used as a way of explaining that the Michelson-Morley might have been, allowed for the spinning of the Earth when it actually showed it wasn't spinning, and that any kind of result, which they actually found 1/6 of the result expected, would be damning. So the only way to negate that was to say that there was some kind of like contraction, Lorentz contraction, that was causing this. So and then I was looking at the 4 forces, strong and weak nuclear force, as well as the others, and Lorentz equations right in all of that too. So.
Hey, I got gas pressure with a container. Check it out. There you go. I am here for
nice.
For science, man. I'm here for science. Natural science, mostly. Computer science. I'm not so sure about that. It's really good engineering. Hey, if it wasn't for computers, we wouldn't be talking right now. So
talking through the air, right? Talking through the middle of the air, right?
Shout out to you, computer.
You can hear each other's voices through the air, all the way on the other side of the world.
Through the ether, man. Damn.
Crazy when you think about it.
Yeah.
Talk to somebody through the air.
It's crazy, man.
So what I find,
just going back in time, that's all.
What I find weird, Dave, new perspective, is that when they talk about the Cavendish, they say, well, actually he was busy measuring the density of Earth, but yeah, they also found this and that. But when they are talking about Mixon-Morley, they say, well, he was just measuring ether and it wasn't there, so he just proved it wasn't ether, right?
Right. Yeah, exactly.
Great point, Roger.
Whoever's at the top, whoever's got the media backing them, or the powers that be backing them, gets the loudest voice. They just get to say it.
It's whatever gets to push through the universities, man. Yep, that gets approved. This doesn't get approved. Yep.
Right.
So it wasn't about Earth spin; it was about ether then, and Michelson-Morley. But
right.
But with Cavendish, it wasn't about density of Earth. It was about gravity.
Gravity.
Just like okay.
Which one is it, people? Come on. Yeah, they buried Sagnac and Michelson-Morley in the colleges, man. They don't teach that shit in there. No.
Hey, Roger, if you haven't seen that one I just posted, that's a good one. He does a really good job of explaining how it was done and how many times the Michelson-Morley has been repeated and found the same results. And, how there was like a hitman basically put out to, not like actual hitman, but like a press hitman that was, sent after the people that were trying to, claim that this is like ridiculous. That you can see the evidence right there. And they totally reinterpreted it, and Einstein used it as a way of, forming special relativity, and that saved the globe.
Hey, Dave, man, did you catch Matthew and Witsit going at it?
Yeah, I did. I went back and listened to that after I heard the end of it. That was good.
That was great, man.
Yeah, Witsit reading those quotes. I mean, it's great because you could say what those people are saying, but then it's just, a flat earther saying what they say. The direct, very effective.
Oh, I think, they were both worn out by the end, but Matthew was fucking racked.
Right? Does somebody, I have to ask, because does somebody have like, does Creation Bear have the, like little dub of Matthew saying the earth is flat? Because he kept saying the earth is flat. And then I figured, okay, so they're using his voice while he's on air. That's a little mean. That's a little bit mean, I have to say, but funny.
It was a little
I was like, why does he keep saying the earth is flat?
Well, they did that, just to keep it light a little bit. Because that shit was super heavy today, bro. I mean, that was as heavy.
It was like a long pause, and all of a sudden Matthew goes, the earth is flat. And I'm like, what? Did he just say the earth is flat? And then he said it again later. I'm like, oh, it's got to be a dub. There's no way he's saying that in the middle of nowhere.
There's.
But it sounds like it's him while he's actually on air saying it, because he's.
Yep.
That's a little bit devious, I have to say, but I love it.
Well, that was a little lighthearted or just a little pokey.
Yeah.
Fun. Yeah, I get it.
Yeah.
But at the same time,
I mean, if it wasn't Matthew, other people would be so pissed.
Oh yeah, yeah, he would have been. But Matthew,
he's a good sport. Yeah, you have to say Matthew's a very good sport.
I loved that he answered every question today with the most cement shoed, vigor. The globies. This is what they would say. He was so on point with his globe shit. It was just. I know he's here to help us. I know.
It seems like, it almost, you'd almost have to think he's a deep fake. Like, it's like, although if we didn't have that bouncing board, somebody that knows the globe model well enough to be on the other side, it wouldn't come off as effective. You're right.
No, it wouldn't, because he would get pissed or call you guys a bunch of retards or something. No. Matthew doesn't do that, man. That's not his style. He's somehow.
I think someone even said that to him earlier. Someone asked him, it seems like, you must be a secret flat earther. And then they had a dub of him saying, "You're right." Because I know he didn't say that. They had him saying, "You're right." So it's like, and I think Witsit was even responding to the dub as if Matthew was saying it.
Right. Oh, shit. Yeah, it was epic, man. I was listening. I was working today. I was listening. And I was on the call. I was just muted the whole time, pretty much. Yes, it was just great to hear those two going at it with all these. Well, I think Matthew would be like, well, I think he was thinking that maybe possibly could have been, it's like, whoa, dude, man, maybe he could have been interpreting it this way. And I was like, fuck, oh my. Yeah, well, he could have been interpreting, he needed another roll of fucking toilet paper too. I don't know, man. I mean, it gets at some point.
Yeah, they were getting pretty harsh. They were really, putting them on the chopping block there. He was taking all the, yeah. Yep.
If you guys haven't heard it, man, you got to go back and listen to today's or yesterday's Matthew.
Yeah, I have to say, Witsit's killing it. There was another one that you actually should go back and listen to from Earth Awakening's channel. That was pretty epic. Just yesterday, with Witsit, and it was about Cavendish and some of the stuff I was just kind of repeating for what he said about the electrostatics and how that could be isolated. And somebody else on the Globe side, I think his name is Extremistus, was being intellectually honest enough to make it very effective in the whole back and forth that was going on yesterday. Definitely. The electrostatic thing's interesting. The incoherent dielectric acceleration might be the thing that it could be the answer to this, gravity supplement thing that we're using for this acceleration. That it seems like that could be testable and provable, and Witsit's on it, so that's a good thing. Seems like we're getting somewhere.
No, we're getting somewhere. Today was a great. It was a great day at school, man. I mean, even Witsit's like, dude, let's school this shit, and it was like, oh,
right?
Yeah, let's do it. He schooled.
Yeah, that quote train is pretty effective, man. It's like, okay, here's what the guys that were the guys are saying about it, right?
Modern guys, old guys,
Einstein, and some of the guys that are respected Glober, quote unquote, people,
right,
are putting out caveats that are totally exposing themselves.
Yeah, it was beautiful, man. Yeah, I was smiling all day, man. I was like, oh fuck me, man.
I got to go back. I downloaded all those.
I'm interested in listening to this. When did it happen? What's the timestamp?
Timestamp.
I'll DM it to you.
All right, man.
DM it. Thanks, Dave. What was that, Larry? You said something, brother.
I think they all have to tell the truth. Like the people that are like high up, I think they know that they can't just outright lie, right? So that's why Neil deGrasse Tyson always says stuff like, "Imagine, if you will."
Imagine. I'll be right back.
Well, just like the Ant Monk dude. If we had this, if we did that, imagine we had this.
Yeah, those are magical words that don't belong in the scientific community, especially coming out of the mouth of a so-called, expert. But the thing about it is that when they're doing the little disclaimers, they don't say, "Imagine if gravity didn't work and it was off by the 110 to the 120th," right? Like they're outright saying it. Like, it's not off by a little, not off by margin of error. It's off by like the biggest number you've ever fucking heard of. Anyway, peace out.
Man.
All right, I'm back. Sorry, man. I had to run to my car. All right. Where were we? Oh, Matthew and the scientists.
Cool.
The scientists that Witsit was quoting today, man. These are the physicists of yesterday and today. And it was just epic. I mean, you know, I'm a simple guy, simpleton. But even I was like, whoa, really? Did they say that? Yeah, but, you know, Matthew had an interpretation for every one of these mongos. Every one of them. He had, maybe they were thinking this, or maybe they were thinking that. Or, you know, maybe he was thinking of the universe is small because it's only you know, it's only a billion light years away or something. It's only 1 billion years old. Or it was just epic to see the back and forth. But yeah, there was a lot of, maybe they were thinking this and maybe they were thinking that. But I wish they would come on here and straighten us out on some of the thinking, because a lot of the quotes that Witsit today brought up were from modern day physicists. And I would love to have them in here to pick apart and ask them, what were you thinking? What do you mean by that? But then, no, there was probably 20 different things Witsit read today from different physicists that explaining where the fuck we live. And it was epic, man. So go back, clip it, rock it, take notes. Dude, there's no way I could debate all that shit. No, there's no fucking way. Witsit can. Obviously Matthew can. But Matthew was stumbling along with maybe they were thinking this or maybe they were thinking that. So a lot of maybes, a lot of potential, possibly, sometimes. I don't know. There's a lot to it. I mean, it was probably a complete full semester of physics today, of the globe Earth, in maybe whatever it was, 4 hours. I think it was close to 4 hours. And that covered a complete semester in college. So welcome to 24/7 live stream. Damn. Flat Earth, man. It's where it's at. If you want to learn about where you live, this is where it's at. And I've learned more about where I live here than anywhere else. I'll tell you that. If you got a better place to more, you know. But it's fascinating, amazing place we live. And people think we're shooting around some giant nuclear bomb at millions of miles an hour. Yeah, that works out. How's that working out for you? Yep. We're shooting through space at tremendous, incredible speeds. And we don't feel a fuck all, nothing. We don't feel shit. Thanks. That's going to work out real well, man. Wait a minute. What? I'm supposed to just suspend my belief. Yes, suspend it. Suspend your reality and just believe us. Okay, I'm going to go through your school and I'm going to pay you $100,000 to learn whatever you tell me. That's totally goes against everything I've experienced in life. Oh, that's a good idea. Well, if I was a diabolical cuck, that's the way I would set up the system. I mean, yeah, let's get them to pay for their misinformation education. Yeah, that's a good idea. Let's do that. Let's send these guys through here and they'll pay us, and we still get to.
We have
Roger.
Python. Yeah, we have Python. He says he's a Glober. Maybe he has a question or two. Mm-hmm. We're not going to relay. Okay.
Python.
Yeah, he doesn't. He just wants to listen.
Oh, okay.
It's not.
Yes. That's fine.
I'm not gonna relay the chat into the voice chat. I mean.
Hey man, he's just listening, vibing. Cool, man. Well, listening to Witsit today, Matthew, going back and forth. It was.
Anyone can play it. That'd be cool.
It was a good exchange, man. I'm gonna play 3 hours.
I DM'd it to you.
Yeah, no, I appreciate that.
With a timestamp. Yeah. The one I was talking about from Earth Awakenings, live stream's not available for some reason.
No worries. I'm sure this will tide me over.
It goes down.
Yeah.
Is that from Jen?
You can also go back and just user search Witsit for all the quote tags he was placing in the live stream, and just read through those. I'm going to go back and probably read through all those. I downloaded all those.
You could just read them yourself, but there was a lot of biblical, a lot of physics. There's a lot of quotes and things. So, it was pretty cool, man. It was a good
those quotes. Wasn't it Jeranism that made a whole video like an hour and a half long with all these quotes?
Oh, is that where I'm not sure they all came from there, but
I think you're right, Roger. I think you're right. Yep.
Yeah, if Jeranism was the first one to do that, then credit due to credit earned.
Yeah. Shout out to Jeranism.
Give credit where credit is due.
Give credit where credit.
Absolutely, man.
But Witsit made all those memes though.
Oh, you did? Okay. Yeah, Witsit. I think that I don't know if they're all from Jaren's, but the idea maybe or whatever. But yeah, when you quotes in a meme isn't necessarily Jaren's idea, but
I just posted in the live stream
about the globe. So the one I posted goes through quotes as well, and zooms in on the book where it was written, and zooms back out from the book that the quotes were coming from. On that Michael Samorley stuff, and that guy, it's a channel I didn't even know about, but that was posted a year ago, and he kills it with that Michael Samorley explanation and how it's so definitive that this is what really it said, and that their interpretation of it is just fucking so wrong. And Einstein, man, it just makes him out to be the criminal of all criminals in this video I posted.
Yeah, I just posted it in the live stream for people who want to check it out. Quotes that tell us we've been lied to, Jeranism.
Oh, cool.
Well, there's so many, man. Jeranism, Witsit, Globebusters. The list goes on, man. ODD. I can keep going. I'd probably keep going for an hour, but I'd have to look at my list. But yeah, thank you all, man. Thank you guys for putting in the time, the effort, sticking with it. This is a 10-year physics class that you guys are going through. And hang in there, man. We're 7 years into this shit, man. 7 years. We got 3 more. We'll have it all figured out, man. Come on. Don't quit now. And it costs nothing. Oh, shit. Did I tell you guys that? It costs nothing. It's free. Mm-hmm.
It costs the most important thing in the world. Time.
It is. My friend, my dear best man, rest in peace, brother. It's like, dude, man, you can have all the money in the world, man. You can't buy any more time. It's like, oh, shit. Smoke that one for a couple days. Yeah. All the money in the world ain't going to buy you another second.
Yep.
So enjoy your time. Spend it wisely.
Well, it could buy a little bit of time. You could waste less time doing things that without money you had to do. you know. So that's what it kind of saves you on.
I agree with that.
You can buy all the time you want. Just move to a black hole, right? Time works differently there.
Black holes and dark matter. That was one of the subjects today. Was dark matter. They got to make up all this shit to make all this shit work, man. No. It's dark matter and it has gravity. What? Fuck off. That's my response. Dark matter. Come on. Really? You got any dark matter? Hey man, you got any dark matter? I'm a little short, man. I need a little dark matter, man, to get through the weekend, man. Can you help me out? Anybody? No. Okay. Well,
what are you doing this weekend? What are you doing for the 4th, Kenny?
I think I'm supposed to go to the wife's mother's house, mother-in-law.
Oh, okay.
I think. They got some big fireworks show over there.
Right on.
Check it out. Maybe. They got some barbecue thing going. But, man, the weather's been great. So, happy about that. It's not too hot. So, yeah, here in America, man, we blow shit up this weekend. And that's for some reason, I don't know where that came from, but it's a thing. Lots of fireworks, man. So if you're out there enjoying if you enjoy blowing shit up, I don't, but you know, there is pretty lights in the sky. Pretty lights in the sky that make fire and shoot in different directions. It's pretty cool, but
it's like you're like explaining what fireworks are to someone that has a very basic level of English and also has never seen them before. Yeah, lights in the sky, different directions.
In the sky, man. It's just like the stars, baby, but they blow up and kind of move around real quick. Lights in the sky with diamonds. Lights in the sky with diamonds, man. Damn. It's a poetic song.
Lucy in the Sky.
Is Lucy in the Sky with that? Well, I changed it. Come on, man.
You flat earthified it.
I'm just the Cavendish. I'm the
4th of July.
Modern day Cavendish. I'm gonna change up, or the modern day Neil deGrasse Tyson. One of those. Not sure. Somewhere in between. Oh man, what a cuck show, bro. Percentage. I loved what you did with Monk. I was listening for like.
Yeah, I'm tempted to go back and listen to that whole thing. How long was he on here for?
Like an hour at least.
Was that long?
Yeah. That was beautiful, man.
I heard you say percentages. I'm about you're down with Cavendish if it actually shows what it's trying to show. Like what are you saying there? Like that would prove gravity if it could be shown to you.
Yeah, if there's this attraction, I mean, again, you can't really extricate it from electromagnetism or what. But if you have this effect, then you can't, and if we have like a verifiable way of doing it, it's repeatable and stuff like that. You can't deny it. That's a fact that it happens if it does.
But it would be bending space-time still. It's still, there is no mass attracting mass, even on their side. They have to explain it as the Cavendish is showing that torsion beam is bending space-time to cause whatever the other object is to move towards it. That's the only way they can technically explain it. There is no attraction.
Their
there is no pull. No, but there is no pull. You know about that, right?
No, there could be an attraction, like brought about by, related to the mass, without this bending of space-time bullshit. That's all.
But that's not even. They don't even claim attraction anymore. Newtonian is dead. There is no more Newtonian.
That's fine. I mean,
so it wouldn't prove gravity, is what I'm saying. Even if it was, the explanation of it as mass attracting mass doesn't even fly in their and on their side, in their paradigm at this point.
Yeah,
so they would have to say it's bending space-time.
There's still the
regardless.
internal. There's the inconsistency, like internally within the model with regards to mass tracking mass versus bending of space-time. I still hold bending of space-time is just absolute bonkers, because you can't have
that's completely bonkers
thing,
right, but they still right. So but they gave up, and they, not that they gave it up, but they had to. I guess the way it worked out is they can only really say it's this bending of this conceptual space-time, which is even more bonkers than the idea of mass attracting mass, which they don't even claim anymore. So the whole thing doesn't prove gravity, even if it did work the way they say it works.
Different types of gravity, I would say. I think they
different types.
Yeah. I think they kind of like invoked this bending of space-time thing to explain the lights in the sky and to make it work with their model, but that might not be the case. Like, it's possible that there is this, downward attraction as a result of whether it's electromagnetism or gravity or whatever, right? And as a result of that, it's a globe. It's possible, but the globe doesn't spin, and the globe is still, all the lights in the sky are still moving around the globe, and there's no, bending of space-time bullshit. So that's still a possibility too. Like a geocentric globe, Earth, is still a possibility. I'm just like at the point where I would like to see, instead of just assuming that it's true, I want to hold them to account, hold their feet to the fire, and see actual evidence of their claim.
But the interpretation is the thing they're relying on, and there is no attraction between masses, because that's not even what they're claiming anymore. So it wouldn't prove anything, because we would see mass attracting mass in nature somewhere. It can't just be the Earth that attracts it, and that's their proof. We have to see a mass attracting mass beyond this Cavendish, little get set up. But even then, mass doesn't attract mass according to their paradigm officially. So and that's what I've heard of. Even the Glovers. Well, I'm not worried about them. They're done. They're obsolete. They're not even worried about even considering any longer.
I hear you, but let me say this. So if we, in like a laboratory setting, experiment, and we see that there is an additional amount of acceleration, we put this large mass below this gravimeter or something like that, right? And we test it again and again. The only independent variable, the only variable we're changing is just making this, putting this big mass near, underneath it, and then moving it away. And we, repeat it, and it shows consistent results. Then I don't think you can argue against the mass, or the electromagnetism that's inherent in the matter affecting this thing. And then you have to,
sure, then call it electromagnetism.
Understand. Oh, hold on. So, and then you scale that to the larger, all of the matter that we have, and it makes sense to me that if that's the case, then you would expect the mass to come together to attract towards, a central focal point. It wouldn't make sense on a flat Earth in that regard, if that actually is happening.
Well, then it would be magnetism, though, because the only thing that we see that works that way is magnetism. And even in magnetism, there's no attraction.
Yeah.
Even in magnetism, though, there's no attraction. It's the warping. It's the field that pushes it towards each other. Ultimately and technically, there is no pulling. You've gone through the whole thing. There is no pull. There's only.
Let's say it's a toroidal magnetism type thing that's causing it. I still don't see it, envision it working on a flat Earth if that's the case.
Why?
How would you have, the magnetism of matter, of an object, attracting another object, and it not, forming eventually a sphere from all of this? Because it doesn't work in a specific axis or specific degrees. It's 360 degrees around it's in every zenith or azimuth, I should say. It's happening, right? So I would expect it to happen above, below, left, right, and eventually you would expect that this thing would form a sphere.
Well, a toroidal field sphere around a dielectric plane, maybe.
No, I'm not talking about the magnetism, like the magnetic field. I'm talking about the actual matter itself. If it's literally being attracted, if it's literally being forced. Again, this is all just hypothetical because we haven't seen the actual experiment.
But electrostatics, right? Electrostatic could be the reason for the acceleration, right?
I wouldn't say electrostatics. Again, I would say electromagnetism because, electrostatics denotes electric current, electricity, which can be grounded.
So what's wrong with electromagnetism working on a flat Earth? That seems very, very relatable.
No, it definitely could be Let's say that this is actually happening. You have a gravimeter. You bring about introduce this large mass underneath, and it's affecting the gravimeter such that it's giving this result of more acceleration. Okay. That to me, and you do it again and again. You could even do it with different gravimeters. You could do it with a vertical Cavendish. That's like an actual scale.
Why would it have to be a ball then? Is what I'm saying.
Yeah, that's what I'm thinking. It would have to be a ball if that's the case.
Why?
Why? Because you have this large mass that is now increasing in acceleration, and you would not expect that. It only happens in one direction, like up and down vector only. If the electromagnetism of an object is attracting another object, then or like just increasing the acceleration of objects towards it, then you would expect that happens in every direction. Because electromagnetism doesn't work only up down.
I don't know. I don't know why that necessarily makes it a ball.
I think it's possible.
Know. You're actually assuming that the surface area is something we can actually quantify. Like, what if it's an infinite plane?
It could be. Yeah, I mean that's an option too. The
electric motor.
I guess, personally, I view it maybe like I'm kind of I have it in my imagination as not being infinite.
Well, whatever that force is,
if it is a ball and we're not spinning. The only infinite for me is, I was going to say the only infinite for me is God. Everything else is finite.
Well, when I say infinite, I mean in quotes infinite, just because it's as far as we can see until there's what if there was a stopping point, what would that look like, and what would be on the other side? Because we can't imagine what would be on the other side, then it's infinite for all intents and purposes. Is what I'm saying, but. Why does it have to be a ball in your mind? And if it was a ball without spinning and all the, the pseudo forces that they've baked into that whole idea, then you'd think that force would be very noticeable because it would be sticking us upside down and right side up from each other without even spinning. Then it wouldn't just be a very weak force that would be doing that. It would rule out the ball right there. It would feel like suction cups.
You think that spinning is necessary for gravity?
Well, that's the only way that it makes sense as far as the way they have it worked out. It doesn't make any sense at all. Don't get me wrong. But if it was a ball that was stationary somehow in space and we're walking all around it, you would think that there would be a very noticeable force that keeps us up, right side up, but seeming like, the same no matter where you go, upside down, right side up, no matter how you are throughout wherever you go. That force would be very noticeable because it would have to, it wouldn't involve any movement that keeps you on it. It would just be that force that's keeping you stuck in a very real way, upside down, relative to people that are right side up.
But maybe this force,
keeping your feet up with suction cups.
Yeah, maybe this force is the thing that like governs density. The density gradient and the natural, like the equilibrium densities of different objects. Like how an apple will fall in air and float in water, and then it'll keep on, like if there's a big hole, it'll keep on falling down. Like maybe that is as a result of this, this inherent electromagnetic attraction between matter. Who knows?
But doesn't that seem like a little bit of a stretch when you try to like literalize it in your mind, and how that could be like such an easy thing to defy, but then so strong to keep everything around a ball without
we don't really defy it, right? We're constantly falling. Like you're constantly falling right now. You're just being physically impeded by your chair or your bed or whatever you're on right now. But if there was a hole, you'd be constantly falling until
that was one of the discussions.
Who knows
today.
Where the density that you would start kind of like floating due to buoyancy or what have you is.
I guess, yeah, but it would be. Yeah, go ahead, Kenny.
That was one of the discussions today with Austin and Matthew, was if that apple is sitting on the ground, does it have force upon it? You know, like, really? Right. Am I sitting in the chair talking to you guys? There's force on my ass that's pulling me down to the ground. Well, yeah. Is it a force? It's just density, man. It's just completely fucking density, man, in my mind. But,
Well, Austin brought up a good point a while back that I found out he got from Tesla that pointed out that Tesla proposed that the reason, or that gravity can't be called a force, even if it wasn't considered a pseudo force. It doesn't follow the laws of forces, which is if it really did follow the law, the actual laws of real forces, then it would have to follow the equal and opposite reaction law. And if it did that, then it wouldn't bend space-time. Space-time would straighten out.
Well, my ass definitely feels that I'm sitting in the chair, right? You guys down with that?
Sure.
I mean, I'm going to call that a force. Okay.
Pressure, yeah.
Pressure.
Weight, because your body has weight, because your body has mass, and it has an orientation, an equilibrium that it's trying to find.
Yep.
That's really all you need, except for the acceleration part of it, which could just be like a universal number of some sort, like Fibonacci sequence or something that just works. That's the number, that's the average that things seem to fall at, and that's just an agreed upon average, I guess. It's not like
nothing falls unless it's lifted up to a higher elevation and let go, which they call that potential energy, man. You lifted up the energy and you let it go. Oh my God. That means I've let energy released from this object and now it's accelerating towards down. Right? Help me out, Roger. Yeah, I know. He loves this part of shit. Potential.
Well, it's not like you're really giving energy to it by picking it up. I've heard this explanation before, and I'm not sure it jives completely because, if the rock's just on a ledge and the ledge crumbles and it falls, it was never picked up. It was just falling from where it was. So everything is constantly falling, like Percentage was just saying, as far as like, there's something denser underneath you, then you're not going to, there's nowhere to go. So
I would reject that everything is constantly falling, because it isn't. If something is laying still on the floor, it's not falling.
Is my ass in my chair right now constantly falling?
It's bullshit. No. It's bullshit.
Yeah, it's just being physically impeded by the chair.
It's bullshit Narnia story time, right? It isn't falling objectively.
Constantly seeking equilibrium. How about that?
No.
I would just say it's just if a rock is laying on the floor, it's laying still on the floor. It's not falling. When suddenly the floor disappears, then it would be falling. But the cause would be the floor disappearing, not that it is always constantly falling.
Pressure being created by the weight of the rock on the ground, and if the ground wasn't there, it would fall, right? So
yeah, but it's all what if then, right? It's just the rock is laying on the floor, and magically the floor is disappearing, so the rock falls now to where
that's wrong.
Stops.
I'll tell you why that's wrong.
Equilibrium.
Let's say you have an apple in the water floating, right? And underneath the apple is this plastic board, right? It's very light. It's not pushing the apple out of the water, but it's like a floor for the apple. If you remove this board, the apple's still gonna float. You understand?
Dude, I don't know if I tracked that one, man. That was.
Why? Because the apple isn't constantly falling at that point because it's reached its equilibrium. It's it's in a neutrally buoyant state.
Well, what about the anvil inside of the mercury bed of water? Bed of mercury.
Yeah, what's the density of the anvil? What's the density of mercury?
That's it, man. That's where I'm at. I mean, the fucking anvil floats, weighs 200 pounds. Doesn't matter. It just floats.
Yeah, because it's less dense than the mercury.
Exactly. Density is everything, man. I don't know. You can go out.
But my
in the
point
water
is, the anvil isn't constantly falling in
thing.
that regard. If the anvil was on ground, it would be constantly falling, because it hasn't.
I don't think it's in a medium.
It's in a medium that's less dense. It's in the air.
Wait, how can it be constantly falling if it's on the ground, bro? Like,
it's just being physically impeded. It's being physically impeded, but it's trying to fall. And as soon as you move the way the ground, it will fall. But the anvil in Mercury, it's actually buoyant. It's not trying to fall.
My ass on the chair
not in air, it's in Mercury.
Down. Yeah.
Yeah, your ass is being physically impeded by your chair.
Yeah. I think it's the way you're
it'll be falling. You just resume the natural state, which is it's seeking equilibrium.
No doubt.
Well, it's just that when you say it's trying to fall or that it's falling, it's just the way you word it, that it's saying the same thing that we're agreeing to, that because it has weight, it would go further if it could, but it's not going anywhere, so it's not trying to do anything. It's just sitting.
So if you put the mercury pool and the antler next to each other, like left to right or whatever, next to each other, will the antler be attracted to the mercury pool or
anvil?
To the anvil, yeah. Will the anvil be attracted to the mercury pool, or why isn't? So if I go to the store and I see the fat lady, why I don't feel attracted to her, bro?
I love that. Because
you like them big booties, huh?
I mean, she's massive.
Okay. Percentage.
You know what?
If I'm attracted,
you can't spell massive without ass.
Is that gravity? That's what he's saying.
Yep. The only point I was making is that it sounds to me like word magic when saying it's constantly falling while you objectively and observe it not falling. It's just laying still on the ground. So it's not constantly falling. That's just word magic in my opinion.
You just have to get my language. It's basically like it's striving for equilibrium. It's constantly striving to find its state of equal density, and in that regard, it's constantly falling. It's just being physically prevented from actually falling.
Right. So it is not when it's at the floor, the rock. It is at equilibrium. It's not then searching its equilibrium. To me, it's observably on the floor, laying, not doing anything, and then
that's not equilibrium. It's not equilibrium for a rock.
For the rock, it is, right?
It's not. No, because there's a difference between it being like at neutral buoyancy and then it being physically impeded, and that's what I was talking about with this apple that has a little bit of a plastic board underneath. You take away that plastic board, and it's still not being physically impeded because it's at neutral buoyant state. It's not moving. Like the balloon that has half air, half helium. It's going to be floating exactly where it is.
But it would be falling if you pull out the floor magically. Then it would be falling when it's laying on the floor.
Yeah, then it would be actually falling. But it's constantly trying to fall. It's constantly trying to, it's just being physically impeded.
I feel like that is word magic because I don't observe that. I'm
explaining.
Yeah, it's when you're saying trying. Maybe trying is the wrong word. Because it has weight, it's seeking its equilibrium just because that's what density does. Right? Because the thing below it's dense enough to keep it from going anywhere. It's not trying to do anything. It's at its equilibrium until that equilibrium is disrupted and it would find its new equilibrium.
Yeah, because it's in air, which is less dense. As soon as it's in a medium that has the same density, it won't do that anymore.
I think the word trying is the reason that people are having a problem with it. Like I'm saying, it's not trying to do anything. It's at rest, right? It has weight, it has density, so it would fall, but it's at rest, so it's not trying to do anything.
I mean, it's not doing anything itself because it doesn't have any sentience or anything like that, right? But
yeah, that's the reason the word.
The system is such that it's it's basically I don't know how to explain it better than I did.
I know what you're trying to say, but trying is the wrong word, I think. I don't know a better way to say it though. But I hear what I know what you mean. I think everyone's agreeing. It's just that it's It's the way it's worded, and if it hints at what the Globers are saying whatsoever, people are going to jump all over it. And I know you're not trying to say that.
Yeah.
But the electrostatic thing is interesting. What do you think about the incoherent electrostatic thing, the incoherent dielectric acceleration percentage?
You're gonna have to be more specific. I don't know, like exactly.
That's what they're calling it technically. The incoherent. That there's electrostatics to everything, and that there could be this acceleration that we're observing. This average agreed upon acceleration could be something of a constant because of the electrostatics um, between the ground and any object in the air that's being attracted.
Basically, this inherent electromagnetism within matter that I was talking about.
Yeah, like say we're on a big plate of some sort, like a big lead plate, or a big some kind of it could be inconsistent even different parts of the world where there's more of a an ore type substance in the earth. I don't know.
Have you? Can I inject one thing? Have you seen the Genome Project?
No.
So
what's that?
Let me post it again. It's where they took I don't know if you want to believe it as a quote unquote scientifically calibrated lab scale and a gnome. I said genome. I meant gnome, like a small garden leprechaun, And they took it across Earth, and they measured the gnome at different places, and it didn't comport to what globe Earth is. So there you go. You understand?
Meaning, like I just said, like there could be places where it's inconsistent.
It is inconsistent. So
yeah,
they say, well, on the equator it should weigh this, and then going to the north it should weigh that because of the rotation of Earth, right? But it didn't do that. And these were not just random people measuring it. I think even NASA got because they shipped that suitcase all around across Earth, and labs and people measured the gnome at their location, and it didn't do what they thought it would do.
That means that the test is wrong because it didn't prove the globe. The test is wrong because it failed to prove the globe.
Yeah, and I posted it in the live stream. So go ahead. Sorry for interjecting.
Oh, good.
What do Globers have to say about this? Is there anyone respectable have some kind of excuse? Hand wave denial?
I mean, you know it's wrong because the Earth is a globe. So if the test didn't prove the globe, that means the test is wrong.
Okay. Yeah. Has this been a popular flat Earth topic? I've never even heard of it. Sounds like a good one.
Yeah, I don't think so, because this is really going into the nitty gritty. Usually topics like curvature, spin, and gas pressure come up, and then usually globers don't go in that deep and saying, well, if you're in the north, something would weigh less than you're on the equator or something, right? So.
Huh. Yeah, bad ones. Yeah.
And if I'm not mistaken, they use this gravimeters, right, for ore detection.
Yeah, that would be my guess too.
I think they actually use that, claiming, well, there's ore beneath our feet because the meter does that.
Detection as well.
Sorry?
The aqueduct, like water detection as well. I don't know.
Never mind.
Sorry, guys. Someone's asking me for a jump. So I'll be muted for a minute.
Boost him.
We have Capley joining. He wants to ask a question. We have Arrowway joining, who hasn't got a role. And we have I'm probably butchering Piazza and Chutney. We can unmute Arrowway. Welcome, Arrowway. I've unmuted you, so you have control of your mic. You are unmuted. And we have Chutney. Welcome to the server. Chutney.
Thank you.
So how did you find us?
There was a guy, Flat Earther.
Sorry?
Send me the link. There was this guy, Flat Earther.
Okay. And you've read the rules and agree with them?
Yeah.
Okay. Awesome.
Yeah.
Cool. Well, let me give you a role. You sound like not a troll, so. But do you have any questions?
I don't think so.
Okay. Have you looked into the topic already?
I still don't believe that Earth is flat.
Well, it's not a belief, right? When you measure your foot, you know its dimensions. You don't have to believe the size of your foot if you measure it. So if you measure Earth, then you don't have to believe. It's actually knowledge.
Can you measure Earth? Can you measure 10 miles? I can.
Sure. Then that would be sufficient to know if there is curvature drop over that distance.
There is no curvature drop?
There's none.
I have seen things which show this. The bridges example.
Sorry?
I forgot the name of the bridge.
Pontchartrain.
Right. Pontchartrain. What about?
I mean, he probably is referring to a different. He probably referring to a different bridge. Who knows? You're saying there's a bridge that proves the Earth is curving or something?
Yeah.
So where is this bridge? Like in the U.S. or China?
Just give me 1 second. Just give me 1 second. I'm telling you.
It's in Italy, right? Is that the bridge in Italy?
No, I think it is in U.S. Give me 1 second.
Yeah, it's Pontchartrain. Right. It's the only bridge they ever knew.
So all other bridges, right? All other bridges don't do that, but except Pontchartrain. That's awesome. Cool. Right. So when we go out and measure with the laser, right, Chutney?
Yeah.
And we shoot a laser over a large body of water, let's say 24 miles. It's approximately 40 kilometers. And the laser is at point A, and then the target is at point B. We shoot that laser across the water, and that laser will hit point B at the target. Then we have a problem. Well, no. The globe Earth has a problem.
The globe has a problem.
Yeah. Globe Earth has a problem.
It's actually funny.
Sorry?
I don't know, man.
That you're pretty funny, he said. You're pretty funny.
That's okay. That's okay. That's okay. I mean, you're probably here to learn or taking the arguments. If you scroll down this server, we have tons of channels for you to go and do your research. Or you can ask
Can you tell me one thing? If the Earth is flat, where's the end?
So I have a counter question. I sure want to answer, but what is it you think flat Earth is? When I say the word flat Earth, what does pop up in your mind?
That basic flat Earth map, that I find on Google when I write flat Earth.
Okay, yeah.
That kind of thing.
The why I asked is because usually people come here and ask us, well, where's the edge? Why don't I fall off? Right? And that is a question that comes from the fact that what you think flat Earth is a disc, right, in space with the water falling off.
Yeah.
Is that what you think?
And that is just another just another image that you've been given, just like the globe. You remember when you think about Earth and you think about the globe, that image that was given to you as a illustration you never seen. Same thing is happening when you think flat Earth. You've seen a disc flowing through space. Is because you've been given that imagery.
Yeah.
So what is the reality according to you?
Well, it could be a snow globe. Think about it. If you take a snow globe and you fill it with earth, right? Why couldn't it be that? It can be anything. But what they're saying is they've just given you the images, so that's what you've got.
So when we measure the dimensions of the place we're standing on and the waters, the bodies of water, and we put at least we put the claim of the globe to the test, we find out that globe that it was given to us with specific dimensions, we've falsified that already. Because it doesn't add up when you go to reality and test it. So it's not a globe, then you experience the Earth as a level, motionless, contained ecosystem, dynamic system. But what it is as a whole, I don't know, because I've never been to the we lack the frame of reference to tell you a shape. So flat Earth as two words as a descriptor, that's not what the Earth is. The Earth is not two words on a piece of paper, right? It's not a description. But flat or level, motionless, contained, dynamic system, those are the descriptions of the environment that we're in. But it's not just two words. So when you ask, what is the Earth? I will say it's a lot of things at the same time. But to give you a name or a label for what this place is, it's pretty difficult. But we know it's not a globe because we tested the globe, and the globe doesn't add up to reality. It only works in cartoons and movies and fantasies. Do you get the point?
Not completely, but yeah.
Yeah, not completely, obviously, because I couldn't tell you what Earth is as a whole, right? I didn't make a claim.
Yeah.
Is it okay to sometimes say you don't know something if you don't know it? Is it okay to say you don't know, or is it better to just make a claim, acting like you actually know something that you don't know? Which one is better? If you don't know something, you could say you don't know.
It's always better to pretend to know, because then you seem smart.
Yeah, and to be honest, right, with yourself, Chutney, then you would have to say, well, you don't have to do anything, right? But you could say that you wouldn't know the shape of Earth either, because you have not been outside Earth to actually see it in whole. The only time you've seen or allegedly seen Earth as a ball is on your screen, as on your screen or television. That is the only place Earth is a ball for your day-to-day experience.
Possibly the reason that they would lie to us. Why would they lie to us?
Yo, and don't underestimate Chutney, man. He's been training his chakra. He's
I'm
working on his
underestimating.
Kundalini, and he's unlocked astral projection. He's seen the Earth from out there.
Well, okay. Well,
come on,
probably.
Bro.
Yeah. So, but let me finish my statement, and then I will answer your why would they lie, right? So, yeah, you haven't seen Earth as a whole. I haven't. Nobody has. The only time Earth is a ball is on your screen. Your day-to-day experience of Earth is a flat, non-rotating Earth. That is what we all and everybody ever alive has experienced, flat, non-rotating. And on your television and on your screen, they will tell you, well, disregard your senses. The place you're actually living on is a big giant water ball spinning and flying through this void, infinite void, right? That is what they are telling you. But your senses and your experience are telling you, no, this Earth is flat, non-rotating. So then we come onto the question, why would they lie, right? I would tell you, of course, we can speculate, right? We can tell you all kinds of stories about why would they lie. Point is, I'm not part of that group that is lying / telling what they have been told, because everybody here on Earth has been told they are living on a ball. They are not lying. They are just telling that story to you. Okay? There are people that actually know that it is not a ball and are lying to you. And why would they lie would be speculation. If I go to a liar and ask him, why would you lie to me? Then he could tell me his story and I could believe his story, right? He could tell me another lie why he lied about something. Could be another story. I wouldn't trust his story again, right? So I could give you my speculation about why would they lie about Earth not being, why would they lie about Earth being a ball? And I would say to hide creation, right? That it would be my speculation. And you can ask anybody here in this room and they would bring you their own speculation, but they're not part of that group lying. So we can talk about speculations all day. Wouldn't make it reality, right? Earth is still flat and non-rotating. Would that be?
When you mean that group, you mean Illuminati, right?
No, I wouldn't. No. So again, there are people telling you Earth is a ball because they have been told, right? That's not lying. That's just telling you what they have been told. And there are some people, I would say astronauts, that know that they are not falling around a ball in a tin can, right? So, and who that group is, I couldn't tell you because I'm not part of that group. Okay.
I want to be the part of the group.
Well, if I
sure
may,
you're not part of
yeah,
it. Sure you're not.
if I may speculate a bit more, there are rumors going around, right? If you are part of that group, you have to denounce stuff. You have probably are forced to say, forced to do stuff, or else stuff will happen to you, right? So sure, if you want to be part of that group, probably you would be forced to do stuff, forced to do not do stuff. I mean, if that is what you want.
So tell me one thing, that that every proof that Earth is round on YouTube, on Google, whatever it is, can you counter argument that?
Sure. With ease.
Every single proof.
Yeah, sure.
Can you give me 5 minutes?
Yeah. So don't go to Professor Dave, right?
No. I have seen that man. I hate people with long hair.
Hey, you just asked for 5 minutes, so come back in 5 minutes and make sure you bring the name and the method and the proof for the globe, right? Just try to bring a list of the name of the people and the proof that you say, the ones that we have to counter, okay? Just take your 5 minutes and come back with the names of the people and the proofs, okay?
Man said he hates guys with long hair.
Yeah.
Please don't be that particular about 5 minutes. Maximum 7 to 8 minutes.
Yeah, Chutney, it's all good.
You got 4 minutes.
We're counting now. Remember that you are not the first one coming here and claiming all these globe Earth proofs.
Yeah, I know. I have been. Can you see how long I have been to this server? I've been in this server.
I don't know.
Do you know?
Yeah, sure, I can. And secondly, we've all been where you were, right? We've all had the same education. We've all believed that Earth was a ball. So,
That's why I've remained in this server. Give me just 7 to 8.
Oh, you've been here for you've joined 27th of December 2021. So
isn't it pretty long? Don't you think?
that's pretty. Yeah, sure. Half a year.
I'll come around. Just give me some.
Interesting. Why would they lie, guys? Why?
Hello.
You're right on time.
Am I?
Yeah, I appreciate punctuality. Good job.
Like, I would not try to present any counter argument, but just can you explain me the moment of sun if the earth is flat?
The what?
The moment of the sun?
Like the phenomena of day and night explained in explain in the concept of flat earth.
Okay, so you think you again are mixing two cosmologies, right? So you're thinking we have this space disk floating on Earth, space disk which is Earth floating, and then we have this big giant sun still at 93 million
You
miles
don't agree
away.
with the concept of sun?
Sorry?
You don't agree that there is a sun?
No. Listen to my words.
No, he's asking for the phenomena. What's the explanation?
I know,
that we
I
can,
know.
What,
I know,
yeah,
but I'm explaining his question.
Yeah.
Okay, because this question comes from the fact that people still think Earth is a space disk and the sun is still a giant ball of gas 93 million miles. So
No,
it has to.
don't tell me all that. Just
Okay.
explain me
Okay.
the phenomena of
Yes.
day and night if the earth is flat. Just simple as
If
that.
the Earth is flat, it doesn't really matter. Light doesn't travel forever in the medium. So you will not have light at the bottom of the ocean because light does not travel forever in the medium. So when the sun moves away from you, the sun is too far.
Attenuates.
Sorry?
There's a combination of things. You're talking about light attenuation at the moment.
Right.
That's one of the factors.
Mm-hmm.
Yeah, but there's a combination of those. So yeah, keep going with that one. I like that one.
Yeah, so light doesn't travel forever in the medium. As we see at the bottom of the ocean, there's no light at the bottom of the ocean. So when the sun moves away from you and it is too far away from you, the light will not reach your position. The same as you would have a flashlight in a dark wood, right? That flashlight will not illuminate the whole wood, the whole place where you are. Forest, sorry.
Yeah.
The whole forest. It will not illuminate the whole place, the whole forest, only where you are.
You're saying that the sun moves farther away from me.
Mm-hmm. That is what you see, right? You see the sun moving over your head and then moving away from you. That's what we all see.
Like, it's moving away, not like the distance not increasing or decreasing.
Sorry?
It's just changing its position.
It is moving away. So when you watch an airplane move over your head, right, and it's moving away from you, is it then going lower, or is it perspective making it seem to go lower?
The second one.
Right. So when you see the sun moving away,
I don't see the sun moving away.
You
That's what I'm
don't?
saying.
You know?
No.
So you don't see the
You see
sun
sun
moving?
going away?
Yeah. It is moving away from you.
How?
How? Well, that is
remember when the sun rises in the morning and you don't feel it that warm, and then when it's noon above your head, it's warmer.
Yeah, that's what I'm exactly saying. The sun is changing its position.
Yeah, just like you observe it, your observation with your eyes, the thing that you observe is that the sun is moving across the sky. That's what it is, right? It's moving across the sky. Everybody observes that. Who denies that?
The other guy that was telling things to me.
No.
You saying?
Yeah, what I was saying that the sun moves over your head and moves away when it's dark in your at your position, right? The sunlight doesn't reach your position anymore. It moved away.
Actually, I think I would better understand when you draw a diagram. Can you do that?
I can give you, yeah. So there's this. Are you in a live stream? It's just above this. Yeah. So Tim has posted. Is this for illustrative purposes, right? So
yes.
Awesome.
Okay, that moon. That is the thing.
Yeah, but it is for illustrative purposes. So this is not how it 100% works. This is just to show you that the sun moves over your head, right? It moves away, and then the sunlight, when the sun is away from you, the sunlight will not reach your position. Then it is dark for you. So instead of the sun being this enormous ball of gas floating in a vacuum, right? It is actually close and local.
Yeah, the thing about the luminaries, including the sun, is that it's phenomena that we can observe. Nobody denies the sun or the moon or the luminaries. The thing is that you're missing the variables to indicate how it actually works, because we cannot go past, let's say, the ceiling above and actually determine what are all of the variables. So to make claims about how the sun works and how the luminaries and the moon works, it's could be very dangerous to make claims of how it actually works. And these depictions are trying to show you that, what we observe in a cycle, the sun moving around the earth, it's like a light moving above your head. And
but don't you think in this illustration, the sun only lit up the quarter of the part of Earth, but in reality, half the Earth is lit and half the Earth is night?
That's not true.
You're putting too much into it. The picture is only for illustrative purposes to give you the idea how it works on this, instead of
I don't want the idea. I want the proper illustration. You understand? Why would I accept the flat Earth concept if the concept is vague?
I mean, I guess we should move back to the 3 points, to be honest, because this guy is just spiraling.
No, remember, the place that we're standing on is not a depiction or a concept. It's not a cartoon or an illustration. This illustration is giving you, let's say, the flat map, right? We don't know if that map is correct completely. We don't know if in the middle there's more land, or away there's more land. So this is only as an illustration. So don't take the thing that is being demonstrated, that is being shown to you, as 100% fact. It's just to show you some perspective so you can think about it. But you just don't just throw everything else out with throw the baby with the bathwater. You have to think about it objectively. So the Earth is not these depictions that we're showing you. That's not what this place is. It's not gonna be 100% correct. You can make this place into a picture or a depiction. Can you?
Oh, yeah, I'm agreeing.
Exactly.
But
so he spoke to you about light attenuation, right? So
yeah,
you're asking about day and night. Let me see if I find let me see. Maybe we can find some definitions here that light attenuates. You gotta understand that, so you know that light doesn't travel forever.
There's a really simple example, if you don't mind. It's like if you have a street, right, at night, it's pretty dark. So why can't they light up the entire street, like miles of it, with a single street light? They should be able to do that, right? But they can't because the light does not travel forever.
Light does not travel forever.
Yes, in a medium, it does not. Definitely doesn't.
Yeah,
like
yeah.
water,
You should
air,
mention that.
things
You
like
should
that.
mention that.
No, but this is measurable, right? Light does not travel
Yeah,
forever through water or air or any kind of medium, really.
yeah.
Right. So this is what we have here on Earth, right? We have water and air for the light to travel through. So, like, of course, it's not going to do that forever.
Sure.
So that's one of the variables. Maybe you can. Let me see if I find some links here, and you can maybe read through that, because maybe with the definitions and reading through it, you might get what we actually mean with it. Because you gotta do your own research as well in many of the variables, because the light attenuating is one of the variables, but there's more. I would say, at least that's my opinion. Why you don't see the sun forever and you get day and night.
So there's no concept of house falling flat Earth, right?
No, flat Earth is a description of the place we're standing on. Flat Earth is not the whole thing. Flat Earth is two words that describe the place we're standing on. Like when you measure the bodies of water, they measure level everywhere you go, like on your cup, water cup, on your bathtub, on your pool, the lakes level, sea level. So you and I, where are you? Which country are you at? I'm in America. Where are you at?
What do you think, so by accent?
China.
Oh, bro, come on, it's China, seriously.
Yeah.
India.
India, sure, India, sure. I'm just messing.
Yeah.
So when we go in the level, right? I go to the seashore in, let's say California, and you're standing at a seashore in, I don't know, the one of the coasts in India.
Yeah.
You and I are horizontally. How would you say that, guys? Horizontally parallel, right? You could say that. Level. When you are at the level in India and I'm at
You're at the same elevation.
Yeah, same elevation at the seashore. So it's level all the way from California to India and all the other nations. So it's horizontal. It's a horizontal type of horizontal plane with topographical, because there's hills and valleys, right? You could go up the hill, down the valley, right? But it's at the seashore, everything is level. And if you go to a lake, huge lakes, there's many big lakes everywhere. You go to one side of the lake or the other side of the lake, you're never gonna find curvature. If I'm in one side of the lake and then you go across it and you are at the other side, you're never gonna find any curvature between you and I. It's gonna be horizontal, level. Just like the pool, when you make a really big pool and you are at one side of the pool and I'm at the other side, there's no curvature anywhere. Horizontal, level. Same thing. But yeah, because you were asking about there's no concept of flat Earth. That's what I'm trying to tell you. The Earth is not two words that you're gonna define the whole thing and all the variables into these two terms, flat Earth. Because you're kind of like asking for a whole concept of how everything works specifically, but you're not gonna get that from anybody, I think. There might be something that is more precise from whatever you can Google around, but even if you, let's say, search for the globe or globe model, flat earth model, I don't think you're gonna find something that is gonna satisfy you if you're looking for models, because the place that you're in is not a model. Reality is not a model. So you won't find a model that would satisfy your thirst when you actually can go to the real thing and test that and check that and experience that. Shit. I tagged you, Shutney. See if I find more stuff about light attenuation. This is a good image for that. Can you see that, Shutney? Touch. Can you guys hear me?
Yeah.
Okay. I'm just tagging Shutney about that topic, which is that's a very underrated one. Light attenuation. Because I think a lot of people, we've been given these ideas that we can see the stars for billions and trillions of miles away, so people think they can see that far. So they don't get that light when it's going through the medium. It's gonna attenuate, so you can't see the light forever. Yeah, the idea that the light is being blocked by the curvature of the Earth. It's bunks because there's no curvature to be found. It's been labeled as well as the atmospheric extinction. We know it's air, so not atmospheric, because there's no spherical shape to it. But it is the light being extinct by the medium, the atmos, the air. See, I found a link for that. Let me copy it. Shani, were you ignoring me? Is it because of my accent? Were you busy?
Your mic is also.
My mic is awesome, I know. I can hear you clearly. Can you hear me, Shani?
Not clearly. Your mic is a little bit like disturbing your voice. What is this that you send in the live stream voice text?
Oh, that's Olber's paradox, right? They claim that light travels through a vacuum, right? Stars being trillions and trillions of light years away and still reaching your eyes. So if there's an infinite amount of space and stars, then that light would reach your eye, and then the night sky would be lit instead of dark. You got more questions, Chutney?
I'm confused. I'm thinking of questions, but I come up with an answer to it.
Oh, well, we can show you something. Maybe that would raise a few questions to you. So I just
prove to me that Earth is flat. You prove to me that Earth is flat.
Yeah, I'm busy. It doesn't boost my.
Well, can I just point out that you are now asking us to prove what you already experience, right? Because the globe admits that we experience the Earth is flat and stationary, not moving.
Oh, yeah.
Not moving.
Yeah, we experience. I said we experience the Earth as not moving, right? And the globe admits as much. The same with the horizon being flat. Well, it's too big, right? It's too big to see that it's curved. So we already experience the Earth is flat and stationary, and you're asking us to prove your experience. Why? I mean, it would be like asking someone to prove that the sky is blue when we can all see that the sky is blue.
I was saying this. I come up with questions, but I already know the answer.
Well, we can show you this image. It's in the live stream voice text. So here we have. Do you see the
Hey,
image?
make sure. I'm sorry, Roger. I'm sorry, Roger. Just make sure, because I'm gonna mute myself in a little bit. Make sure you guys bring him to gas pressure, because I think he might get that one really
sure.
well. So
okay.
make sure to bring him there.
Yeah. So let's start with this one, right? So, and this is just one of the examples. There are thousands of these examples, and the beauty of it is you can do this yourself, right? But let's start with this one. We are seeing two oil rigs, right? You see them?
Yeah.
Okay. So there's a modest tolerance. If P, then Q, not Q, therefore not P. If the Earth is a sphere with a radius of 59 miles, P, then every distance to the horizon must be no more than 1.225 times the square root of the observed height in feet, Q. So not Q horizon's distance greater than 9.4 miles, therefore not P. So when we look at this observation of the two oil rigs, and this comes from a video where you see the guy with his high-powered zoom camera. He films the beach, and then he drops down on his belly and he puts the camera on a bunch of rocks, almost 1 foot above the water. It's just below 1 foot, but let's say 1 foot above the water. Then he zooms in on these two oil rigs, and we can then clearly see that the horizon is beyond the most furthest oil rig, right? But they claim that the Earth is a ball with a known radius, 6,371 kilometers. And with that radius, we can calculate where the horizon must be, right? The horizon that they claim blocks boats and buildings from the bottom up, right? So if we are at 1 foot observer height, this horizon must be at 1.225 miles, or approximately at 1.9 kilometers away. But we can see that this horizon in this observation alone is almost 10 times further than what they say it has to be.
Yeah.
So clearly the horizon is not the leading edge of a sphere. It is not blocking boats and buildings.
And I would say that this is like the main point of Flat Earth, is that the globe gives us dimensions and math to predict what we should see in reality. And we go outside to test and measure reality, and it doesn't match up. So that's a problem.
This is so funny.
Now, this is, again, not the only thing we can show you. We can show you the Guinness Book of World Record longest distance photograph. We can show you laser tests over large bodies of water. We can show you Marconi's transmission, which was approximately 10,000 miles, right? So he did a transmission over 10,000 miles. This is all things we can show you, but the most important thing I would like to give you is that you don't have to trust us. You don't have to trust your TV. You don't have to trust people telling you on your screen that the Earth is a ball. You can actually go outside and validate those claims, and you can test it. So now we've touched that there's no curvature, right? Never been measured, can't be found. Then we have, let's skip rotation, because then we have the gas pressure problem. So you have this Coca-Cola bottle, right? And you shake it up, and then you open it. Then the gas inside that bottle comes rushing out. So they claim Earth is a ball with this air sticking onto it and not filling the available volume that's available to it, right? Earth is a ball, they say, shooting through this infinite volume, which they call a vacuum. So here on Earth, when we have a vacuum chamber and we open up the vacuum chamber, the air will rush into the vacuum chamber immediately. Without hesitation, it will instantly start filling the volume that it has to its disposal. So why isn't the air rushing into the infinite vacuum, right? Why isn't gas pressure, where what we on Earth here need containment for gas pressure, or it will fill the available volume?
Because of gravity?
Because of gravity. So how would that work in your mind?
Yeah, can I ask him a question about that?
Sure, go ahead.
Would you say that gravity is stuff falling down? Simply put, right? Gravity would be stuff going towards the Earth. Yeah.
Yeah.
Okay. Do you observe the air doing that anywhere? Is air falling down? Is there wind from above? Is anything like that? Because from what I can see, the air is moving in many directions.
Your voice lagging, bro.
Yeah, you have a sound card problem or internet problem. Yeah, so his point is the air is moving omnidirectional, right? In any and all direction.
No, he was asking that. He was saying that is air moving towards the center of Earth, right?
Yeah.
And I said yes.
No, it isn't.
How?
Because that is not what we observe. We don't observe air falling
Then how
down.
come as we go above the surface of Earth, the pressure is low, and near the surface, the pressure is like comparatively high?
Because Earth is a dynamic system, right? It gets energy from the sun. The air is, when I say produced, right, it's being produced on the surface, being converted. So we have the oceans and the trees and making the oxygen we breathe. That is on the surface. And then energy
They make
gets put in.
oxygen, or they convert any other gas to oxygen.
Right. So so the energy is being put into that system, making the air rise again and then fall down again. But you are missing the point because you are pointing towards a pressure gradient, right? And then say, well, of course, there is a pressure gradient, so that proves that the air is sticking to the Earth, whilst you need containment to produce that gas pressure in the first place.
Yeah.
So without the containment, there can also be no gradient.
Oh, you're referring to that firmament concept.
Well, whatever it is, I couldn't tell you, but the laws that we know on Earth require a physical barrier, right? A physical containment for gas pressure.
You haven't heard about the firmament?
Of course I do, but that would be a biblical reference. I'm not using. I wouldn't
Yeah, but you're
use.
explaining the same thing, bro.
Right, but I wouldn't use the Bible to prove my
Yeah,
point.
that's okay. You religious or what?
Religious,
Spiritual or what?
religious in what way? I mean, I do believe that we are created, but that's just my notion of it, right? You could ask anybody here, and they will have a different notion on it. So the point.
If anyone doesn't believe we are created, then they're retards.
Well, yeah, that's another opinion, but again, that isn't the goal. That wasn't what I was trying to say, because just a little side note: people come here and then tell, well, you're just religious fools. You're all religiotards. That's not.
That's a pretty good accent, actually. That's a pretty good
Yeah, it was.
Well, that's not what
Can I
we
ask
are.
you one thing, bro?
Sure.
Am I the only one who know less about flat Earth in this group of 16
Momently,
people?
yes, because I think that has to do with where you are. I don't know what the time it is. It's like almost 12 o'clock noon here, but in America,
In
it's
California?
no. I'm in the Netherlands.
Sorry, middle?
I'm in the Netherlands.
Netherlands. Oh, bhai.
Yeah. And you are 6 hours later, I guess. You are 6 hours later.
It's 3 o'clock there, noon.
Right. And then we have America, which is 6 hours before me. So they're now entering their morning. So yeah, there's not much activity at the moment.
So when is this server like full-fledged?
Sorry?
When is this server fully active, like people going this and that?
Usually in 10 hours, maybe. When people completed their day in America, something like that.
Oh my God. Am I supposed to wake up till midnight?
I know. But we are still talking about gas pressure, right? So yes, in biblical reference, they call it the firmament. There are a lot of cosmologies where they claim there is some kind of physical barrier above us. So it's not only the Bible that says this. Doesn't even matter. What we know here on Earth is that we need containment for gas pressure, right? So what a book tells you, a religious book tells you, doesn't really prove anything. It's what can be observed and demonstrated and experimented on. But do you get the argument?
Tell me one
Is that
thing.
something you can relate to? What?
Yeah, I got your point. But tell me one thing, that when the bottle was closed, the Coke bottle was closed, the empty space, was the pressure constant at every point?
Wait, so you are talking again about a container having a gradient. Well, yes, we can show you that, right? You can fill up a container with gas and then put
it is
energy.
a dynamic system.
Right.
It is a dynamic system. So heat and cold, and also gases being produced at the ground. It makes it a dynamic system. So pressure will radiate within the system.
There is no barrier in dynamic system?
What?
In system, is there no barrier?
It is a dynamic system. So you're asking about. You're asking if it has to be the same pressure all around, everywhere, right? You're saying it will be the same pressure, but it is a dynamic system.
Can you explain what is a dynamic system?
But hold on, because there are variables that can affect pressure, right? Like, for example, temperature. We know that if you increase or decrease the temperature of a gas, the pressure will also change, right?
Yeah, I guess they're inversely related.
So hold on. So on Earth, we also have a temperature gradient, right?
Temperature, yeah.
It's warmest at the surface, and then it gets colder when you go up. The mountaintops are frozen, right?
Yeah.
Right. So, like, irregardless of gravity or any type of vacuum, there could never be a constant pressure everywhere, because that would require that the temperature is also constant.
Yeah.
Right? I mean, like, I realize we're giving you a lot to process, but what it comes down to is that
No.
they have
I can
stories.
handle it. I have been to these debates many times.
Right. Well, like, all we're trying to point out is that they have stories about how things work and how their reality is supposed to be that don't match up with, like, the reality we experience and that we can test. Like, basically everything is the opposite. We observe the horizon is flat. No, it's actually curved. We observe the earth is motionless. No, it's actually moving. The sun and moon appear to be the same size. No, they're actually different. And it's like, it's all of this, right?
The shadows.
Gas fills the available volume. Oh, no, it doesn't. It just coalesces in on itself or something, because you have gas planets in space, apparently.
Mm,
So,
The
like,
eclipses.
where's the part of this globe that we can observe and test?
Do you know something about eclipses?
Yeah, sure. Like, I mean, I know what the globe story is about the eclipses.
Observable
Issues with that. Yeah.
Yeah, what? What? I didn't hear. Which phenomena?
I'm saying that eclipses are observable phenomena.
Yeah, observable.
Yeah. Yeah, observable.
That doesn't contradict the flat Earth concept
Why? Why would it?
because when an eclipse occurs, I guess the round shape we see.
You're saying that it contradicts the flat Earth, whatever, because the Earth is getting between the sun and the moon, or what is the moon is getting between the sun and the Earth, and you can see the shape of the Earth.
Well, I mean, like while we're talking about observed phenomenon, like both the sun and the moon have what we can see sometimes is an eclipse, as it's called. But just observing that does not really prove that the story that they have about what causes that is true, right? I mean, like, take a solar eclipse, for example. This is supposed to be when the moon is in between the Earth and the sun, and then it blocks the sun perfectly, because they happen to be the same apparent size from different whatever. But the problem is that the solar eclipse happens in the new moon phase, which means that nobody can see the moon like for a couple of days anywhere. So to then say, well, look, the moon is doing this, would be pretty logically fallacious. I mean, I've seen a solar eclipse. All I can see is that looks like a black circle is going in front of the sun. It's like, okay, that's cool, but I've never seen the moon as a black circle. Why would I assume that's the moon? There's no logical reason to think that the story is what I'm actually seeing, right? So we're not like saying eclipses don't happen or they can't happen. Just like there's no way to find out how they happen or like what is even going on, because you can't test anything. All you're doing is observing it. And like if you're talking about, well, but they can be predicted, and it's like, yes, that's correct, but people have been predicting eclipses for thousands of years because they happen in repeating cycle, right? It's based on time intervals, not any kind of
there's a
cosmological model.
They can be post-dicted, right? Because people have been observing them and repeating cycles, so it's something that already happened. It's not
right. It's like I would say, well, the sun is going to rise in the east tomorrow because that's my prediction.
That's a post-diction, right?
Because this happens every day already.
Every morning.
Yeah.
Yeah.
I don't think there's anyone here who would like claim how an eclipse works, because there's just no way to test it. Like it would have to be just a story that you believe in or make up, or someone else made up, right?
We can actually kind of demonstrate similar things that look like an eclipse down here. You can actually demonstrate similar things, but not at the how do you say at the I'm missing the word right now. At the expand or the structural accuracy of the what's happening up above, what's happening above, because that's I would say the designer level, because those cycles repeating themselves, for me, it shows design. Those cycles are no accident, no randomness to the cycles of the luminaries. So for me, it's design. So to that level, I don't think we can demonstrate it as big as the Earth or the heavens above, because that's heaven. That's what's happening on the heavens above. You can kind of demonstrate something similar, but not at that level. how it works and exactly all the variables that is causing the effects and the
Can I ask you guys
phenomena
a
that we
question which is
observe.
not related to flat Earth?
Yeah, real quick. So to make a claim of how the luminaries work exactly, we will need to have all the variables of why and all the things that are happening above in the heavens above, but we don't have that. So to make a claim how it's actually happening, I wouldn't do that. So go ahead with your question.
Can I ask you guys a question which is not related to flat Earth?
Go ahead.
What do you guys think the end goal is? Like the universal end goal?
The universal angle of what? Who? Like my goal? Just want to wake up, be productive, provide for my family, and
No, like the universal thing, bro.
the universe goal? Oh my goodness.
So why would they lie? Is that the thing, right? Why would they lie? And what is the
Like
end
not
goal?
exactly,
I think
not
he's
exactly.
asking. I think he's asking what is the end of the beginning, because there's a beginning of this whole thing, and well, what is the end of it? What is the last step or the goal? Because when you talk about goal,
You can say that.
but we
You
are
can
we
say
are here
that.
today. We are here today. This is today, and tomorrow is gonna be tomorrow. You want to know what's gonna be the end, the last day. What was gonna be the last step of everything? That
Yeah,
is a very good question that I wouldn't be able to answer. I mean,
no problem, buddy.
there's scriptures about that kind of stuff, but that will have to go, to the religious server. And there's many books. There's the Bible, the Quran, and many books that speak about that kind of stuff. But that there, you know how people say there's nothing new under the sun. I think the end goal might be a new day of something new that never has, and that might be not the end, but maybe the beginning of something new. But who knows? That's just me speculating. It's always a new day.
What I would say about this is read Aldous Huxley's Brave New World and George Orwell's 1984. Put those two together, and that's where they want to take us.
But that wouldn't be the end, bro, right? Like that will still be falling under a fallacy line system that it has to kept alive somehow. But eventually, even that will fail. In my opinion, because if this place has been designed by, let's say, a higher authority, I mean, we can do and play games and do whatever we want down here, but eventually, if there's an actual reset of the whole thing, that will be the end of the games that are being played at the moment, right? I mean, hopefully you get what I'm saying. Man-made stuff and systems and corruption and all that kind of stuff, in a way, it has to eventually come to some type of equilibrium. I don't know. Definitely the books and the stories the plans that they show, and the agendas that they have for the systems that we live under are it's a huge thing. But I don't think they're in control of the whole construct. I don't think that they can control this place forever. They need people to allow them to be controlled. And that's why they put these systems of control in place. But that can last forever, in my opinion. I'm gonna mute myself for the moment.
Black Swan.
What is gravity?
I have no idea. Okay, next question.
I don't know.
Nobody in the entire world knows why that falls.
So what is pushing this?
Why does that fall?
Newton didn't know.
We can describe it pretty accurately, but no one knows why.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it.
I don't need a computer to get a kid interested in that. To spend a week playing with gravity and trying to understand it and come up with reasons why.
Oh, so what is pushing this?
Nobody knows why.
So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull.
Space station is a serious place. We're doing serious research, scientific research and engineering research. We have a regenerative life support system, which is a fancy way of saying that we've got a toilet that you use and then a machine that goes chugga, 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 chug. And then you go to the galley and you make yourself a cup of coffee. And that's exactly what you are thinking it is. And this is the kind of engineering research that we're doing on space station.
solving all the problems.
Here is Pig. And of course, Pig is the arch enemy of Angry Bird. And Angry Bird had some eggs. And Pig stole the eggs. And don't ask me how I got to eggs on Space Station. Something that absorbs water on the back of your head. Hey, let's use a diaper. I thought that's a clever solution to this problem.
Yeah, pretty neat. They also came up with the snorkel idea too, you know.
Unexpected turn. The astronauts doing the spacewalks will now be wearing snorkels after the last astronaut who performed the spacewalk nearly drowned when his helmet filled with water.
Just my gut inside me said, that's my dive buddy, and I should be with my dive buddy. That's my dive buddy, and I should be with my dive buddy.
Snorkel cut from rubber tubing.
The snorkel is now installed inside the suit.
Each of these spacewalks is scheduled for 6.5 hours.
Yeah, man, astronauts drowning in space. Ooh.
Yeah, boy.
Nice.
My name is Joe Biden. I'm Joe Biden's husband. Prescription jugs. Prescription jugs. Prescription jugs. We choose truth over facts. Maybe you could inject some bleach in your arm. That was really a productive segment, wasn't it? And the kids used to come up and reach in the pool and rub my leg down. My mother believed and my father believed that if I wanted to be president of the United States, I could be vice president. My mother and father believed. Judge my physical and mental, my physical as well as my mental fitness. I got to the Senate 180 years ago.
Yes.
Thank you, Dr. Pepper, and thank you, Chancellor, or Dr. Paper, and thank you, Chancellor. Come on, man. And my poor kids are just as bright and just as talented as white kids. 1.2 billion. So you go ahead and you stack spaghetti sauce at a store and in a supermarket. You control the guy or the woman who brings out the carts on a forklift. What happens? You know, the message is simple. Going after Mickey Mouse, for God's sake. We hold these truths to be self-evident. All men and women created by you know the thing. Come on, man. And by the way, you know, I sit on the stand and it get hot. I got hairy legs that turn blonde in the sun. And the kids used to come up and reach in the pool and rub my leg down so it was straight, and then watch the hair come back up again. They'd look at it. So I learned about roaches. I learned about kids jumping on my lap. And I've loved kids jumping on my lap. And come on, man.
We don't have time for a meeting of the Flat Earth Society.
We choose truth over facts.
The Earth is flat.
Thanks, Matthew.
Has anyone in your group, Nathan Oakley's group, when has anyone measured to that horizon? Because the Black Swan states that every measured horizon must be 1.22 meters times this whatever, right? When have you measured it? And when was the Black Swan put through the scientific method? You can't destroy 2,500 years of science with logic.
What? 25,000 years of science?
Like, what the hell did I just hear?
Oh my God, these people. No, you can't just destroy a story we've built just by measuring the shit.
It's like, so there's no distance measurement of the horizon. Well, that's great.
It's like they, for instance, they thought that bloodletting was a good medical practice, and then somebody came around and no, it's not, and then you just can't destroy all this science, right?
Emotional damage.
What do you mean? Bloodletting is a good medical practice.
You know what I mean. Lobotomies, I don't know. Whatever. It's just like
asbestos, scientifically proven.
Right.
Your doctor smokes Camel.
Press?
Yeah, I don't want to make
Associated
it
Press?
Sorry?
No, nothing.
Yeah. I don't want to make it a medical discussion, but it's just... So if you measure something and it isn't the thing you thought it was, then you're destroying... Yeah, you're destroying that what you thought it was. You just can't destroy 25,000 years of science. Okay, so 25,000 years, wasn't it like man is only 25,000 years old? Wasn't it like that? And even then, they thought that they were on a flat, non-rotating Earth. So,
Just remember, you can't destroy science with logic. That's what the Global says. You can't use logic to destroy my science. At Associated Press.
March at NAP. What was going through your mind? How amazed were you to see your roadster up there with Starman just cruising along with the Blue Planet? And how long will we be getting live views, do you think, from the car?
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly.
Yeah, boy.
yeah, that's just the globe, right? Looks so ridiculous and fake that it has to be real.
The Globis can only be as logical as Matthew.
Yes, that's right. Water forms into a mountain.
Water forms into a mountain.
Yes, that's right. Water forms into a mountain. Yes, that's right. Water forms into a mountain.
Oh, Matthew.
The Earth is flat.
Yeah, that is what QE always says. Just let the Globus talk, and you can fill a whole like what you just did. You can fill your whole machine with all those quotes.
Right.
It is photoshopped, but it's has to be.
The Earth is flat. The Earth is flat. Yes, that's right. Water. Yes. Yes.
It is photoshopped, but it's has to be.
Did you know that the Earth is flat? Did you know that the Earth is flat? Did you know that the Earth is? Yes, that's right. Yes, that's right. The Earth is flat.
Okay, I'll stop now. Am I the only one who always smiles when I don't know why, but Matthew's profile picture makes me smile. That's the only thing that makes me smile, not the things he said most of the time, unfortunately. I mean, I gotta give him that he's a friendly guy, you know, at least that.
Aren't the most friendly guys the ones that you have to be careful for, right?
That's true. Yeah. Yesterday I really was a bit annoyed because I really felt like as if he was thinking he's smarter than most or everyone actually here. You know, when he talked to Witzit. You know, when he also always goes back to education. What Globers most of the time do. You know, we are the uneducated, right? Even though we have NASA employees on our side, but okay.
It's really funny because like it's easy to see that education is, you know, rewarding you for repeating information. That's it.
Exactly.
It was like, well, good job. You're a good parrot. Congratulations. You get a gold star.
Exactly. Man, I can't wait to be at the sea again this week. Gonna send in some flat of pictures into the Discord of the Mediterranean Sea. But hey, I don't know if I'm the only one, but every time when I'm on vacation and I swim in the sea, my skin gets really healthy.
Where are you going? Italy? Malta?
Italy.
Cool.
Liguria or whatever it's in English.
Lampedusa.
Hey, I will send you a pic of
The small island off the coast of Italy?
No, it's Ligurian.
Okay.
It's the coast. It's like on top of Italy. Yeah, I sent you a where it is. Right there. It's actually where my mom is from. Ooh. All right, I gotta do some stuff. See you later, guys.
Later.
NC72, NC72. NC72, you've been unmuted. You can open your mic. NC72. It might be the accent. Want to speak to me, right? Right? Anyways, I like donuts too. You have a donut icon. Chutney, remember Chutney? He's kind of sus to me because there is this moderator in the server that he's Indian and he joins the server with other accounts and start asking questions. Like it's a global. I forgot his name as a moderator, but
Chili.
what?
Whatever it's called here.
Not much is going on in here. What's going on with you?
Oh shit, sorry. I'm playing game.
Get him, get him. What game are you playing?
Oh, Counter-Strike, man.
Oh, NC72, you're in the lobby. Texting, bruh.
You won't be able to access the voice text here.
You saying he won't be able to?
No, because he has no roles, right? Needs to get PC verified, I think.
Well, he won't be able to text in the live stream voice text, but if we
that's what I meant.
unmute him, he can speak, and then we can give him VC verified if he speaks. But if he doesn't speak, no VC verified because reasons. Because VC verified means you spoke. What do you think? NC72. Come on, bro. Don't ignore me. Oh, I got you. You don't have a mic.
You got a phone?
Hey, do you have a smartphone? NC72, do you have like a cell phone or no?
Yeah, you could buy one as well. Why will we hate you, bro? I mean, you say you could buy a mic. Those USB 2.0 mics work decently on any computer, and they work, and they're pretty cheap. Could get one for. Could probably find one in a garage sale for $1.
He doesn't want Discord to have his phone number.
Why? Because of China?
No, because he still thinks there's privacy online.
Privacy? What's that?
It's where you imagine that you're doing things and nobody's watching.
Is there actually privacy these days? Hey, I recognize your privacy, bro. You don't have to tell me your name, your address of any of that. But in these apps and cell phones and computers that you're using, won't you agree that privacy is out of the window? I mean, maybe privacy between you and I, that's a possibility because I don't know where you're standing or your name or any of that. But if you're in the internets and the Googles and the Windows, is there privacy there? I mean, unless you have like, I don't know, 25 firewalls and VPNs and I don't know, how would you be private, completely private in the internet? There's someone out there that knows where you're standing, or some computer or some registry that knows who you're typing under this username NC72, especially your the virtual you, the strawman that is built for you on the internet and the data centers. They most definitely know you're using NC72 in Discord, and it's added to your strawman virtual you.
That's not even really denied, right? I mean, like every device on the internet needs to have its own unique identification tag, or otherwise problem. So, I mean,
from my understanding, there is a real virtual you somewhere out there in the clouds, and following the tracks, following everything back to back. If someone really wanted to, they probably can figure your emails, your accounts, your discords, your
right.
everything's in digital
Well, I mean, I
space.
think this is a point that I think a lot of people don't get. Like, it's not about that you have to track. Like, I want to track everything that a million people are doing, and worry myself about what they're doing day to day. That's not the point. I just want to collect all that information so that when I need to know what is this, I can just access it all, right?
Yeah, you can just go and find a map of an individual, and that map probably has more information that the man or the woman themselves can tell you about themselves.
Right. Especially with things like Facebook, because they've been like they save a lot of data. But one of the things that was happening a couple of years ago, I don't know if they're still doing it, but it wouldn't surprise me. It's like when you type in text, right? There's one thing that people usually do that you can't do in voice, which is unsay something that you said, right? Like I'm preparing to type a message and then something else. Oh no, I'll delete this message. So I never said that. You did say that, right? And they also saved that. So like everything you didn't say but wanted to say, that's also say, which I think is more valuable than things that you actually did say usually. If you're like talking about how to get at the, how do people work subconsciously.
Oh yeah, if you typed it in the keyboard and then you press delete, delete from where? Delete from pressing enter and send, but it's been typed in the keyboard. Some type of it went through some type of program for you to be able to see the letters on the screen. So it went somewhere besides your mind.
Right, which makes it only even worse because they're not just collecting information that you voluntarily share, they're also collecting information that you're not voluntarily sharing. Like, what privacy is left at that point? I mean,
I think they use it mostly in the commercial sense because even though they have all that information, whatever, in the past of anybody, you're not that digital version of yourself. That's not you, anyways. They probably could use it against people, but I'm not that digital guy. So whatever it's under, whatever comments or whatever it is in the Facebooks or YouTubes, that's not me.
yeah.
Why is it so quiet in here?
Advocate. Devil's advocate. How are you? You have been unmuted. You can open your mic.
Yeah.
Devil's Thad. Thadvocate. What's that about? My name. What's my name, Fresh Grown?
Oh, Flatty McFlatface?
No, not mine. That devil. Oh, he's gone. He's
Oh,
gone.
Devil's Advocate? Is that Proto Thad with a different profile?
Probably. So, Dr. Professor Gemsy, what are you working on today in your lab?
I'm working on conquering the world. Still trying to figure it out, how to get it done.
Same thing we do every day, Pinky.
I'm gonna have to go watch Pinky and the Brain again.
You know what's weird is their very first episode. This came out in like the late 90s, I think, or early 90s, maybe 92 or 3. I can't remember off the top of my head. Well before the iPhone came out, and there's an episode where Brain uses these little devices, and everyone across the world has them, and there's little hearts on the pictures. It looks just like Instagram's algorithm set up, and everybody was liking this little video, and Brain was hypnotizing the entire world with this little device through his videos that everybody was liking and sharing. This is way before Facebook, way before Instagrams, before the iPhone, before any of that crap.
Oh, that's a Simpsons level prediction, that thing, then.
Pinky and the Brain. I gotta watch that episode.
I'm pretty sure it's their first episode.
Pinky and the Brain. Pinky and
Brain.
This is part of the plan. Super active magnetic infundibulator. Fast assembly. I'm watching. Funny how they show the globe in the plan to conquering the world. Does that mean that the globe is part of the plan of conquering the world? Huh. There you go.
Yeah, season 1, episode 1. I just looked it up.
Yeah, I'm sharing. I shared the link in YouTube, and you see the plan. It has a globe on it.
Animaniacs wasn't a kids' cartoon, was it? It was there's so much adult content in there, truth bombs and shit. What up?
One man, one world.
What's up, everyone? It's Jaronism again, back with another video, short one for you. And first thing I want to say, thanks to everyone for spreading the truth out there. Just keep doing it. Don't let the science preachers change your mind. Use your brain and your eyes and decide for yourselves. So I did want to tell NASA and SpaceX and ESA that it's time to give us our $1 trillion back. And I think Alex Jones sums it up best, my feelings about NASA.
I mean, it's just like scum, Nazi filth, trash, garbage, maggots.
So first things first is I had a lot of questions about GPS. What about GPS? How does GPS work if we're not on a globe? And I need to explain to them that GPS means Global Positioning System. It does not mean Reality Positioning System. It means your Global Positioning System. Where are you if you were on a globe? So that's how it works. If it were a reality positioning system, it would say flat. You're on the flat Earth. So the second thing is, again, I always want to bring this up because I think it's one of the best evidences for you to think about. Water will always find its flatness. It is always flat. It can't be curved. It can't have a hump in it. Scientists and these science preachers will tell you that it can because of gravity. But all you need to think about is that from California to Hawaii is almost 2,500 miles. And if you believe in that, which I do, then you must believe that there is a 770-mile high hump of water if you believe in the globe. And if you believe in that, then you believe in make-believe and pretend. And I think you should start believing in reality. Joseph Jastrow, in 1935, said, "Create a belief in the theory, and the facts will create themselves." So if you think about that, you can start to see the deception that they're playing on us. Take a look at gravity and just think to yourself that all it is a construction of mathematical equations that don't jive with reality. And there's a lot of these equations. They're all over the place, and they don't make any sense. Another example of no sense-making science is relativity. And tell me how smart you have to be to get this one. The theory of relativity says in its equation form that r to the little pw minus half of r to the g pw plus lambda times g to the pw equals, of course, 8 times pi to the g n to the t pw. That makes sense, doesn't it?
Right. Who is this really? What's going on? How come you want me to do all these weird things?
The person who wants you to do all these weird things is people like Neil Tyson deGrasse, who's quoted here as saying, "The good thing about science is that it's true whether or not you believe in it." So that's fantastic advice, Neil. Thanks very much. I don't believe in it, so if you want to say it's true, that's up to you. Basically, guys, they have every base covered. They have done the work they need to do to make sure that all their math works, and the only tool we have to combat them is our brain and our eyes. So I suggest you try it out. Next, we've got 1984. If you have never read it, if you were like me, which was supposed to read it in high school, and I think I probably got an A on whatever test I was supposed to take, but I never actually read the book until just this week. And if you read it, I think you'll be very, very shocked at some of the info that you'll get out of it. The book was written by George Orwell. It was written in the late 40s. He died about a year or two after he wrote it, and you'll probably see why here in a second. I took about 8 or 10 different parts of the book to read to you right now, just so you can get an idea of why it's important for you to read it. Don't watch the movies. The movies are different. They take out the parts that I'm going to tell you about. The slogan of the Big Brother, or the political party, the party in the book, is "War is peace, freedom is slavery, ignorance is strength." So here's some quotes from the book. "It isn't very important about the top hats," said Winston patiently. "The point is, these capitalists, they and a few lawyers and priests and so forth who lived on them, were the lords of the earth. Everything existed for their benefit. You, the ordinary people, the workers, were their slaves. They could do what they liked with you. They could ship you off to Canada like cattle. They could sleep with your daughters if they chose. The heresy of heresies was common sense, and what was terrifying was not that they would kill you for thinking otherwise, but that they might be right. For, after all, how do we know that 2 plus 2 make 4? Or that the force of gravity works? Or that the past is unchangeable? If both the past and the external world exist only in the mind, and if the mind itself is controllable, what then? By making him suffer, obedience is not enough. Unless he is suffering, how can you be sure that he is obeying your will and not his own? Power is in inflicting pain and humiliation. Power is in tearing human minds to pieces and putting them together again in new shapes of your own choosing. Do you begin to see, then, what kind of world we are creating? It is the exact opposite of the stupid hedonistic utopias that the old reformers imagined. A world of fear and treachery and torment, a world of trampling and being trampled upon, a world which will not grow less but more merciless as it refines itself. Progress in our world will be progress towards more pain. Alone, free, the human being is always defeated. It must be so, because every human being is doomed to die, which is the greatest of all failures. But if he can make complete, utter submission, if he can escape from his identity, if he can merge himself into the party, so that he is the party, then he is all-powerful and immortal. The second thing for you to realize is that power is power over human beings, over the body, but above all over the mind. Power over matter, external reality, as you would call it, is not important. Already our control over matter is absolute. The next few portions are in the book a conversation, so I'll try and change my voice a little bit so you can follow along, but very interesting and telling information here. But how can you control matter? He burst out. You don't even control the climate or the law of gravity, and there is disease, pain, and death. O'Brien silenced him with a movement of his hand. We control matter because we control the mind. Reality is inside the skull. You will learn by degrees, Winston. There is nothing that we could not do. Invisibility, levitation, anything. I could float off this floor like a soap bubble if I wish to. I do not wish to because the party does not wish to. You must get rid of those 19th century ideas about the laws of nature. We make the laws of nature. But you do not. You're not even masters of this planet. What about Eurasia and East Asia? You have not conquered them yet. Unimportant. We shall conquer them when it suits us. And if we did not, what difference would it make? We can shut them out by existence. Oceania is the world. But the world itself is only a speck of dust, and man is tiny, helpless. How long has he been in existence? For millions of years, the earth was uninhabited. Nonsense! The earth is as old as we are, no older. How could it be any older? Nothing exists except through human consciousness. But the rocks are full of bones of extinct animals, mammoths and mastodons and enormous reptiles which lived here long before man was ever even heard of. Have you seen those bones, Winston? Of course not. 19th century biologists invented them. Before man there was nothing. After man, if he could come to an end, there would be nothing. Outside of man's existence, there is nothing. But the whole universe is outside of us. Look at the stars. Some of them are 1,000,000 light years away. They are out of reach forever. What are the stars? Said O'Brien indifferently. They are bits of fire a few kilometers away. We could reach them if we wanted to, or we could blot them out. The earth is the center of the universe. The sun and the stars go around it. For certain purposes, of course, that is not true. When we navigate the ocean or when we predict an eclipse, we often find it convenient to assume that the earth goes round the sun and that the stars are millions upon millions of kilometers away. But what of it? Do you suppose it is beyond us to produce a dual system of astronomy? The stars can be near or distant, according as we need them. Do you suppose our mathematicians are unequal to that? Have you forgotten doublethink? The old civilizations claim that they were founded on love or justice. Ours is founded upon hatred. In our world there will be no emotions except fear, rage, triumph, and self-abasement. Everything else we shall destroy. Everything. Already we are breaking down the habits of thought which have survived from before the revolution. We have cut the links between child and parent, and between man, and between man and woman. No one dares trust a wife or a child or a friend any longer. But in the future, there will be no wives and no friends. Children will be taken from their mothers at birth, as one takes eggs from a hen. The earthly paradise had been discredited at exactly the moment when it became realizable. Every new political theory, by whatever name it's called itself, led back to the hierarchy and regimentation, and in the general hardening of outlook that set in round about 1930, practices which had been long abandoned, in some cases for hundreds of years, imprisonment without trial, the use of war prisoners as slaves, public executions, torture to extract confessions, the use of hostages, and the deportation of whole populations not only become common again, but were tolerated and even defended by people who considered themselves enlightened and progressive. And remember that this is forever. The face will always be there to be stamped on. The heretic, the enemy of society, will always be there so that he can be defeated and humiliated over and over again. Everything that you have undergone since you have been in our hands, all of this will continue, and worse. The espionage, the betrayals, the arrests, tortures, the executions, the disappearances will never cease. It will be a world of terror as much as a world of triumph. The more the party is powerful, the less it will be tolerant. The weaker the opposition, the tighter the despotism. Those are very few of the amazing quotes in this book. I recommend you read it today, tomorrow, this week. You can go online and just search for it. It is in the public domain, so Project Gutenberg and other places like that. You can get the free ebook. Check it out. I think that George Orwell knew a lot, knew more than a lot of people at that time, and he paid for it with his life. He only lived to be 47 years old. He also wrote Animal Farm, which is another great book. If you have never read that, I recommend it. Basically, the book teaches us that exactly what's going on now, exactly what the government's doing, exactly what the Masons are doing, they have taken us over from the inside, meaning they have gotten in our heads. They have taught us all in schools exactly the world that they want us to live in, a world with a million planets and a million stars, and we were created from stardust, and we will all live and die, and our existence is unimportant. And if you're following along with my channel and others like it, you'll realize now that that is the biggest lie in the history of the world.
Hey, what's going on, everyone? I've got some footage that I'm excited to share with you. The footage is of retired University of Wisconsin Emeritus Professor Michael J. Smith. Those of us who have taken the time to peel back one of truth's protective layers have surely come across this image here. The story goes that 7 of the astronauts who died in the 1986 Challenger explosion are alive and well. And the pilot, Michael J. Smith, is a professor emeritus at UW-Madison. Because I live in the Madison area, looking up Michael Smith had been on my to-do list for a while. Of course, you can't just call up and leave a voice message asking him if he's part of an evil scheme to deceive the sleeping masses. A better way would be to find him in person and ask him. So that's what I did. Is Challenger pilot Michael J. Smith alive and well? Take a look at the footage and let me know what you think. Hey there. Hey, sorry to bother you. I was pulling out and I saw you. I just came by to... Are you Michael Smith?
Yeah.
Professor at university?
Retired.
Retired?
Yeah.
Yeah. Yeah, I just stopped by because there's this room. Are you aware of that there's a rumor on the internet
It's not me.
that people are saying...
Yeah, it's not me, obviously. I mean, anybody that looks at my background, looks where I was born, it's not me. I mean, it's interesting that the Michael J. Smith that was the astronaut looks something like me when we were younger, but really not if you really look at facial recognition.
You never been a pilot, never been in the military?
Nothing like that.
Huh.
No.
Okay.
Yeah.
That's all.
And I don't respond to the emails I get. I get probably an email, maybe 2 a month.
Really?
Yeah, and I got one guy that's been really hounding me, and I turned it over to the FBI.
Really?
You know, yeah, I mean, it's bullshit.
Okay.
You know, another crazy theory.
Okay.
But that's, you know, not me.
All right.
I'm glad I wasn't him, but he was quite a guy.
Yeah.
You know, but if you look at my career, you look at my CV that's online, all the stuff I've published, all that I've done, it's not even close to what that guy was.
Okay. Yeah, you just sure look a lot. It's the same name.
I know the facial thing, but that's what we looked like. What, 40 years ago?
Mm-hmm.
Yeah.
Okay.
Yeah.
Well, thank you.
Yeah. Okay. It's interesting you came all out here.
I did. I drove an hour. It's I mean.
No kidding.
Yeah.
Yeah. Well.
Well, take care.
Yes.
Now I don't want to fool you here. Last month, for the first time since 1972, NASA released a blue marble, a single snapshot of the Earth taken from outer space. And so much has changed in the decades between that first picture and the second. Borders have shifted, generations have come and gone. Our global population has nearly doubled. But one thing hasn't changed. Our planet is as beautiful as ever. It still looks blue.
In 2002, Blue Marble 2.0, NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it's a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be.
It is photoshopped, but it has to be. It is photoshopped, but it has to be. It is photoshopped, but it has to be.
What you're seeing here is a mirage.
A lie is a lie, and it don't matter how many dumb sheeple believe it. And the truth is the truth, hiding right out in plain sight, and still people don't see it. Man, this shit got me heated, and I won't stop till the elite are being defeated. They keep us deceived about everything that we think, and they keep it a secret. What we're taught is not conducive with reality. Big bang, evolution, and there's gravity. I tell the truth, and then these motherfuckers laugh at me, telling me the earth is photoshopped because it has to be. Most people accept the deception happily, but what they're doing to us all is a tragedy. God created the heavens and the earth in a verse, but we're living in a Freemasonic galaxy. They say we're monkeys on a ball flying through outer space, but there's no proof. It seems to have vanished without a trace. NASA and other agencies falling down from grace. You can take that bullshit pseudoscience and get out my face. I'm the antisocial type. You're a government prototype. That's why you make it a point to tell me that I'm crazy every time you're angry, cause you know I'm right. I'm standing outside the house of cards about to watch it fall. No more living on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl. We follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Nassholes got us all living life on a cartoon ball.
It is Photoshopped, but it has to be. What you're seeing here is a mirage.
They say that we went to the moon 6 times, but pure BS is the way that smelled. Now they're telling us that we can't even leave the planet because of the Van Allen radiation belt. Yeah, okay, sure. NASA, what you lying for? You lying now, you lied before. I can't take this anymore. The only thing they took to space was your imagination. Fake aliens are coming, now they have you waiting. We need to do something about it, no procrastination. Trying to cause the masses to awaken, that's the path I've taken. But you can see if you check all the percentages. So many people having cognitive dissonance. But that's what happens at the loss of your innocence. Then you get involved with all of this wickedness. They try to do all the humans this way. So are they just idiots? Who is to say? Conditioned by the television, it makes your decisions, opinions, and you just obey. Stop in the material domain of Satan, where everything in each and every day is pagan. Mandela effect, cause the game is changing. People waking up and now the cage is shaking. The earth is flat, and that is a universal fact. If it isn't that, then tell me where the fuck the curve is at. They tell us that we can't see it because we're all too small. And now we're spinning on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl. We follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Nassholes got us all living life on a cartoon ball.
It is the world that has been pulled over your eyes to blind you from truth. Like everyone else, you were born into bondage, born into a prison for your mind.
It is Photoshopped, but it has to be. It is Photoshopped, but it has to be. It is Photoshopped, but it has to be. What you're seeing here is a mirage.
We accept the reality of the world with which we're presented. It's as simple as that.
Does anyone know how we can get a mod into VC check-in?
Welcome. Flat Earth Debate live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to Welcome. Flat Earth Debate live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, crypto and thanks button in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. Now, we are joined by Refracted Curvature, 10th Man, Arwin, Neil, and a whole bunch of people in Discord, so welcome one and all.
Good morning, good morning.
Hey! Hey, good morning.
Good afternoon. It's good to have you all. Today we're going to do something a little bit different. So instead of focusing on housekeeping as we do typically at the beginning of the show, we're going to pick a housekeeping question between us. So I'm going to only give you a couple of choices to keep this fairly brief, this part of the show. And then we're going to cover a particular housekeeping question in terms of the fallacy use around that housekeeping question. This was a suggestion that came from our Discord server from the guy whose name changes quite frequently. Who was it that said this in Discord? Just so I can see your name flashing.
Cuddles.
Who was it?
Cuddles. Cuddles.
Cuddles. Oh, is it Cuddles? Okay. You go by lots of different names, Cuddles. Fair enough. So Cuddles came up with this idea that we just cover a fallacy in a little bit more depth, mainly because they're used in daily life, not just in debate about the nature of Earth, although obviously we're a dab hand at talking about them in that context, so we may as well, so that hopefully the audience can take the information away and use it in their general day-to-day life when people are using these fallacies and they may not have appreciated it until we've gone through them. So we're either going to cover axial rotation or Earth curve. So is there any preference particularly which one we're going to cover? Any evidence of Earth curve or any evidence of axial rotation? That would be Earth spinning.
Let's do Earth curve.
Okay, so the fallacy we're going to cover is going to be the affirming the consequent, which is a formal logical fallacy, meaning it has form. And the form is if P, then Q, Q, therefore P. Now, we may expand on this at the end of the description to include the begging the question fallacy that typically is the P statement. However, we won't. We'll just cover the fallacy itself, which is if P, then Q, Q, therefore P. Now, the if P statement is the thing that you're trying to prove, and you're going to be affirming this by showing something not necessarily related to it occurring, and then saying that that occurrence is as a result of the P statement being true. So in the case of a sphere Earth, if the Earth is a sphere, then we will see Earth curve, is the P statement. Or, to make it more accurate, if the Earth is a sphere, we will see Earth curve at the horizon. So the Q statement is we see Earth curve at the horizon. So if Earth curve at the horizon. And then the Q statement again,
Well, we see Earth curve at the horizon, therefore Earth's a sphere. So if P, Earth a sphere, then Earth curve at the horizon's Q, Q, Earth curve at the horizon, therefore Earth's a sphere. So obviously we're going to, as I said before, whistle past the fact that assuming Earth's a sphere in the first instance is a begging the question fallacy, and just focus on the fact that they're claiming the proof of a sphere Earth is had by looking at the horizon. And then when you look at the horizon, you know Earth's a sphere. So it's an affirming the consequent fallacy. Anybody want to add anything to this before we maybe expand on it a little bit more? No? So the logic, the fallacy is that the one doesn't necessarily follow the other, which is to say that if Earth's a sphere, we'll have a physical geometric view times the square root of the observer's height in feet. And what do you know? There's a physical geometric limitation to our view at 1.2 times the square root of the observer's height in feet. Therefore, Earth's a sphere. Well, the Q statement, i.e. physical limitation of an Earth curve, I'm assuming at 1.2 times the square root of the observer's height in feet, aka the curve maths, isn't indicative of a sphere Earth being the cause of that horizon. There's no other options explored. It's just affirming the consequent, affirming that your presumption of a sphere Earth being a cause for a horizon to block things in the distance is a reason to reassert that when you see it blocking things in the distance, by assumption, it's caused by Earth being a sphere. Right, let's discuss this. Unless there's something I've missed in that. I don't think there is.
Yeah, I mean, you hear it all the time. They've already in their mind accepted that they're on the sphere, so they're already starting it without proving it first. I think it's the main point, right?
Well, I thought we'd move on to that at the end before we cover a bit more in discussion about affirming the consequent. But yes, we will get to that. Begging the question is the overall aspect that we're going to mainly focus on throughout all of these fallacy discussions.
So what we're saying is, if the Earth is curved, we will see examples of the horizon blocking things at a certain distance using the Earth curve calculator. Is that that's what we're saying? Is it?
Yeah, that's if P then Q. And in most discussions, the person formulating this fallacy won't necessarily formulate the conclusion. They'll leave that to you. I'm glad you've mentioned this. So what Wandek's just done is given half of the form. He said, if Earth's curving, then we'll see a blockage at the horizon based on the curve maths. End statement. Well, the conclusion that they want you to make for them is filling in the blanks of the rest of the fallacy, which is your opponent, i.e. me in this example, by example, me saying, so we do see a blockage at the horizon at the numbers in the curve maths, therefore Earth's a sphere. Oh, well, then I've lost the argument, therefore Earth's a sphere, right? Not recognising that the one doesn't necessarily follow the other. Earth being a sphere, and there being a limitation to your visual acuity at a certain distance, just to rephrase it, to hopefully jog-start some people's memories about what we're talking about here. Anyway, the one doesn't necessarily follow the other, so to just make it as a statement and then affirm the consequent and say, because of the statement, my pre-assumption in the P is true, is the fallacy itself. Any more for any more? If not, we'll go on to begging the question itself.
Well, when affirming consequent fails... Oh, sorry.
Go ahead.
I was going to say, when the affirming consequent fails, though, you do get a modus tollens out of it.
Yeah, okay. Do you want to cover that? Not
yeah,
Q? Do you want to formulate the actual fallacy first, and then we'll cover that, because it is, yeah, definitely related.
If it's if P, then Q, therefore P is affirming the consequent. Modus tollens is if P, then Q, not Q, therefore not P.
Correct. So in modus tollens, which this is precisely where this should have gone if I'd have given this a bit more thought. Thank you, John, for being here. Very important that we cover this. So in my example, and in one deck's example, we'll use one deck's example without the full form, and then we'll add the form after. So if Earth is curving, then we'll see an obstruction effect at the horizon, a la the curve maths claim of it. No need for the affirming the consequent bit, which is the curve maths, therefore Earth a sphere. But if you take that logic and say, if Earth's curving and we look at the curve maths, that's the same as saying if Earth's a sphere radius 3959, then every distance to horizon can be no more than 1.2 times the square root of the observer's height in feet. That's if P then Q. Just in a much less concise but much more detailed manner. But then when that fails, if the horizon isn't in line with that statement, you've got not Q. So if Earth a sphere, then you'll have this horizon at 1.2 times the square root of the observer's height in feet, as claimed to be blocking boats and buildings in the curve maths. But it isn't blocking boats and buildings as per the distances set out for the physical geometry in the curve maths. Therefore, not P. Not Earth a sphere, radius 3959. So the failure of a fallacy to come to will turn into a modus tollens, which is also a form of logic as opposed to logical fallacy. Anything else on this?
Well, I like to say from an explanatory way, it's obviously by using what John said and you just repeated, then what is causing the limitation? Well, it's our eyes, and they're using that to prove something else, but it doesn't prove something else. And so once the horizon is identified as Earth curve, and yet it's not where it's supposed to be, then what it was blocking? So it's going to go into, well, why is the thing?
No, it won't. And I'm glad you've said that. Very valid point in terms of a general discussion point. But as we're talking specifically about debate and fallacy, wrong. Not in what you said, that was correct, but the reasoning behind it was wrong, and I'll explain why. Once you have disproven somebody's basis of good logic, i.e. shown that it's fallacious, and formulated it as we have done with potentially an opponent's argument, so Earth a sphere, we'll see Earth curve at the horizon, we do see Earth curve at the horizon, therefore Earth a sphere. Once you take that apart and show its fallacious reasoning, it is not up to you to then explain what causes obstruction, in quotes, at the horizon, or show that it isn't obstruction, because that would be a positive claim you're trying to prove. It isn't something. You disprove their assertion based on its fallacious logic. Once you have shown that their logic is flawed, their argument is void. Now, upon voiding someone else's argument, it is not your responsibility to provide proof positive for their assertion. Unless you are, in this instance, 10th has just done this, making a claim of your own. If you take it upon yourself to suddenly make an assertion about what the horizon is, regardless of if you know or not, then you're falling victim to them having reversed the burden of proof without even trying. Now, we may or may not get into reversing the burden of proof, but my point is that it's not up to you to provide anything after a claim fails. And if you're the one showing why and how it fails, it's still not up to you when they turn around and say, well, what does cause things to go over the... I don't care. It wasn't my claim. You claimed it was Earth curve, and it isn't. So beyond it not being Earth curve, based on the example you gave and the logic you gave, give me another example of it being Earth curve, as that's your claim. Now it's down to you to give a better example, one that isn't fallacious, one that is sound in logic and does prove we're on a sphere with a curve Earth for a horizon. Not for me to show how it's formed, because I'm not making any claims about that. Fascinating though it would be to discuss perspective.
Well, yes, but maybe I wasn't clear in what I was trying to do. Let's assume that they agree with you. Okay, so you've proven to me it's not Earth curve. Okay, so we're settled on that? Yeah, okay, it's not Earth curve. Do you know what is causing that obstruction? Any idea? Any guess? Because we just figured out it wasn't Earth curve, so that's out of the question.
So why?
So,
how will it benefit my life? Now I know it's not the prevalent Western worldview that the horizon is a physical obstruction, geometric in nature, blocking boats and buildings with a calculable value for how much they'll be blocked by it. Once we figure out that that is not the case, will it somehow benefit my life in any way, shape or form beyond the total revelation that the entire worldview I held for the majority of my life is a total lie? Beyond that, you think I should concern myself with what it actually is? I mean, that really doesn't concern me.
Well, in real life, it does, because in real life, the guy's saying, man, you just proved to me the Earth isn't curved. Man, thanks a lot. But now, what is that phenomenon that things disappear bottom up at sea? Have you done any research on that? Because it's obviously not Earth curve.
Obviously not Earth curve being the main point here, not the fascinating folly that may follow if you choose to pursue that vague special interest in horizons that aren't Earth curve.
Well, I wasn't going to go.
Can I say something?
Let me finish, if I may. No, I was going to say it's obviously a limitation of your eyes and the deck and the compression of light. It's obviously optical.
Right, so now you're open to me challenging you to demonstrate and prove that for no perceivable benefit. There's no positive claim of a flat Earth attached to you saying that there's a limitation to your view at the horizon caused by aperture size or angular limitations, diffraction, refraction, whatever it is that you, in your experience and knowledge, which may be vast, claim at this point. All you've done is open yourself up for me to challenge you to prove that, when it's not attached to a claim of a flat Earth at this point.
That's what I was going to say. You're still arguing about Earth curves or the horizon at that point.
It all depends if I sense the person's already admitted that it's not Earth curve and we don't live on the ball. That depends highly on that before you go on to anything else.
Okay, but hopefully the point's been laboured enough. Let's move on, unless anybody else wants to talk about affirming the consequent, the formal logical fallacy. If P, then Q, Q therefore P. If not, we'll move on to begging the question. I suppose there's a choice. Would you prefer to move on to begging the question as a whole, or use if P, then Q, Q, therefore P, in a different housekeeping question, i.e. axial rotation with the same form of logical fallacy? So what do you want to do? Talk about begging the question, or talk about affirming the consequent with axial rotation?
I want to hear begging the question.
I'd say do the axial rotation to get one more run at P then Q, then go to begging the question and do, because everything is begging the question at the end of the day.
I'll go with that. That was the most expansive we've got in the last 20 seconds. Okay, so the same example. So we're talking about affirming the consequent, the logical fallacy that is if P then Q, Q therefore P. In this example, we're going to have Earth turning as the example. So if Earth is turning is the P statement, and axial rotation at 15 degrees an hour drift in the stars will be the Q statement, just to keep it nice and simple. So if Earth is a sphere rotating, then I will observe a deviation known as Coriolis effect in the stars at 15 degrees an hour. We do observe 15 degrees an hour of drift Coriolis effect because we're on an inertial turning reference frame beneath them. Therefore, Earth's a turning sphere. So that's if P, then Q, Q, therefore P. If P, Earth's sphere, then Q, stars moving, Coriolis effect. Coriolis effect in the stars, therefore Earth a sphere turning. Okie dokie. Does it logically follow that the assumption of us turning beneath a motion we observe in the stars proves that the motion in the stars is an example of us turning beneath them? No.
Surely you'd have to have another example of that, wouldn't you? Do you not have to have a couple of examples of
Well, that is their example. That's the point of this. So the point is, my example, right. Let's just, rather than put it in the third person, my example is that because we are on a turning platform that's sphere-shaped, we observe Coriolis deflection in the stars at 15 degrees an hour. That's Earth turning P, Coriolis deflection at 15 degrees in stars, Q. Do we observe 15 degrees an hour of deflection in the stars because we're on a turning reference frame? Yeah, we do. That's my example. It's fallacious because the one doesn't necessarily follow the other. So the Q statement is Coriolis effect. So the effect being described with the 15 degrees an hour deviation is only applicable if you're turning beneath things. So it only follows that you will observe that effect if your statement you're affirming, which is if Earth a turning reference frame, then we'll see an effect that's only applicable if we're turning. And we do see an effect that's only applicable if we're turning, therefore we're turning. Again, no other option explored, no other possible option other than Earth being a turning reference frame to cause that star movement to occur is a possibility in this form of logical fallacy. It's the only option, and when you see the second point being made, it proves the first. That's the way this form works. So to break it down beyond any example, you make a statement, true or otherwise, and then use something that you know you can demonstrate as proof of that statement. Then you show that you can show it happening and claim that that's proof of your original statement. So, for an example, if unicorns exist, then we will observe the stars moving because of them dancing through the skies at night. Do we see the stars moving in a circular fashion? Yeah, we definitely do, don't we? Yeah, you're all nodding. I can see you all nodding. Therefore, unicorns dancing in the sky at night. My P statement, unicorns, dancing unicorns. My observable fact that I can show happening, and will show happening when I affirm the consequent, is stars moving. So I show you stars moving, and therefore unicorns, right?
Right, the unicorn is dragging a giant chariot behind it, and the stars are its wheel.
Exactly. And do we see the stars moving in a fashion because they're dragged by the chariot with unicorns on harnesses? Yes, we do. Therefore, unicorns are pulling the stars around in a circular fashion. Right, affirming the consequent. If P, then Q, Q therefore P. Now, unlike the Earth curve example, I can't say I can stop the stars to disprove the if P then Q statement. Farcical though it is to make unicorns my example, likewise Earth turning as a non-inertial turning reference frame is farcical. I can't then say, well, if unicorns, therefore star rotation. But look, check it out. This is an example of no star rotation, therefore definitely not unicorns. Whereas with Earth curve, you can do that. You can show where it doesn't actually line up with an obstruction they're claiming and the geometry that they're claiming. When they say that we'll see Earth curve at a particular fixed geometry in the maths at radius 3959. Stars won't be stopped, unlike horizons moving, which do with the weather. The stars will always do what they do. Horizons tend to move around quite a lot and have no fixed location. But they need to have a fixed location when they're claimed to be a hill in the way of stuff. Horizons, that is. So it's not transposable into the modus tollens example that was given by John very eloquently earlier. But it is still another example of if P then Q, Q therefore P, with if Earth sphere turning as a non-inertial reference frame, then star rotation, Coriolis effect of 15 degrees an hour, and Coriolis effect of 15 degrees an hour, check out that star rotation, therefore Earth a non-inertial turning reference frame.
Wow, and this is what the Western world have been told the reason why the Earth is a globe, and it seems like most of the people haven't even challenged this weak statement.
By the way, I have an expansion on the unicorn star wheel theory, right? The stars are not the wheel, they're actually the nails on the wheel that are reflecting light to us, right? So we're seeing like glimmers of nails, and they are on the wheel. They're holding the wheel of the heavens together, and the unicorn is pulling it.
And the light's the wheel, right?
Well, the stars are the nails on the wheel.
Right.
They're reflecting light.
Right, that's what I mean. Okay. Therefore, do we see those nails of a wheel in the sky moving? Yeah, we definitely do, don't we, Arwin?
Indeed.
Therefore, chariots and unicorns. Obviously.
I mean, it's not that far off Egyptian cosmology. So.
There would be a way to falsify that claim, right? I mean, the stars are supposedly turning because we're on a spinning platform.
Well, there's one way to prove it.
Simply,
you have to get up there and remove one of the nails.
Hold on, Chocolate's halfway there to a modus tollens. Go ahead, Chocolate.
Yeah, well, if the stars are moving because we're on a spinning platform, simply remove yourself from the platform, and stars should stop spinning. Does that happen?
No.
Good one, mate. Yeah.
Funny that.
Now let's just see. I think you've almost got this. So if we are rotating P, then we will see star rotation, Q. Not Q. We don't stop the star rotation. That's not quite not Q, is it? But it's almost there. This just needs a tiny bit of spit and polish chocolate, and it's a modus tollens. I was wrong.
Yeah,
and
I know what you mean.
It's enough for me to...
mean.
Hold on, I'm just going to concede and give you credit. It's enough for me to say I was wrong. When I said this couldn't be formulated into it, I hadn't considered how you could rephrase the Q slightly to get it to match up with the statement being disproven by just simply leaving the claim to be rotating reference frame. Then it can be turned into a modus tollens. Kudos.
Come on, John.
Hold on. What if when you leave it, you're still rotating, even though you left the surface?
But that doesn't fall in line with if P then Q in the first instance, which is the claim that we're going to observe Coriolis because Earth's turning. So if you then say, well,
no, you're sorry, but you're even though you're not on it, you're still rotating with it.
God.
Well, are you okay? Did you have a bad breakfast?
No. I'm trying to figure out how he's trying to get around to the formulation of if it got put into a modus tollens, how your typical anti-flat Earth response is that you're still turning, but you're still seeing the deviation, which means that you're still a part of the non-inertial turning reference frame. Now, in that example, and specifically when you've focused on getting it into a form of logic, i.e. modus tollens, you can't have any rough edges because it fails on its arse the moment somebody inserts a get out that hasn't got me in the modus tollens saying, yeah, but Neil deGrasse Tyson says we're turning underneath footballs, and snipers say we're turning under bullets, right? Once that's inserted into the debate, it all makes sense and their arguments overcome. But you don't need that. What you want is a self-contained logical consistency, yeah, that doesn't have that possible. Well, the way that's done is by phrasing the Q statement in such a manner that it has the ability to remove yourself from the platform and still be the same statement when you show that not turning on the rotating claim to be platform of Earth as a sphere at 15 degrees an hour doesn't induce the effect you would expect by leaving the platform, i.e. you don't stop the stars. So the not Q statement works, you don't stop the stars, but how do you have the Q statement work without that point that the guy's just made, undoing the modus tollens on its arse pretty quickly? Like I say, it needs some spit and polish, but it's pretty damn good, and it's enough for me to concede that there's definitely a modus tollens in there.
No, I mean,
well, logically, if you're getting off the platform or the non-inertial reference frame, the spinning Earth, and supposedly you're still spinning with it, and that's still causing the stars to move, then why make the claim that they're moving because you're on the spinning platform?
Because you're still on it. If you're still
just wasting
part of
time.
This is Earth and atmosphere moving together. Now, in this case of the stars, that's the only example that it works with. It's only because I've got local examples that I can take it away from them. So you can still have a Coriolis deflection with a mixture of globiolis effect and first law of thermodynamics violations and Earth and atmosphere moving as one. Because Earth and atmosphere moving as one doesn't affect the fixed inertial reference frame that the stars are in. So that guy is right in that example. It's not a great argument point for the Globers if they have their ass ripped through their throats regularly on that point, but it is when you're trying to formulate a modus tollens out of it. It's critical that those sorts of rough edges are polished out. Anyway,
Yeah, but
kind of...
I have a modus tollens thing.
Go on, John.
I was just going to say, if Earth is a non-inertial turning reference frame, then it will have a radial value. Earth does not have a radial value. Therefore, it's not a non-inertial turning reference frame.
Perfect segue to begging the question. Okay, so most of these fallacies, when used in debate about a globe, start with the presupposition of a globe being in existence in the first instance. Like, comparatively, me just assuming that we do have unicorns. I mean, in my example, I've got unicorns, and Arwen's example's got unicorns. We're talking about them. We all know what the word means, so we must have unicorns. We're all on the same page here, right? We all start this next stint of discussion with us all understanding and knowing that unicorns do exist. We are all in agreement, are we not?
We are starting a new convention. That's correct.
Yep.
So we all agree unicorns are real. For when I next give an example of if unicorns are real, I'll show an example that proves they're real. Because we're already starting with the assumption that they are, aren't we?
Yep.
That's correct.
So if we are on a sphere, Earth, with a curved surface and a radius of 3959, we're all cool with just starting this next discussion with us being on a sphere in the example, right? If Earth's a sphere, then we'll see Earth curve at the horizon, for example. So we're all cool. We're just going to start assuming we're on a sphere to make the example of being on a sphere. Is that okay? Let's change tact. That's not okay. So it's not okay for me to start an example of unicorns being real by telling you that unicorns are real and getting you to accept that unicorns are real for me to example how the unicorns that are real are moving the stars. Or assuming that Earth is a sphere to then give you an example how if Earth is a sphere, then we'll see Earth curve, sphere, horizon. Because we've already assumed we're on a sphere. So this is called begging the question. That's pretty concise. I don't think I can make it any more concise than that. Anybody feel free to open that up because that's as concise as I can make it.
I just want to say it's essential because you hear that term begging a question everywhere, but it's not begging the question.
Okay, I'll cover that first. So colloquially, people misuse the term because they don't understand English. So I'll give you an example. A guy called Vehicle Virgins does car reviews, and he misuses this wording all the time when he's talking about a particular car. So if they've left out a switch, for example, let's say they've left out a bonnet release catch in favour of screwing the damn thing down. When he points that out to his audience, he'll say, well, that begs the question, how do you get in if you're on the side of the road? That's not begging the question. That raises the question. It doesn't beg the question. Begging the question is the fallacy I just detailed where you assume your outcome, as opposed to raising a question of how you're going to get into your bonnet if you haven't got a release catch.
I heard Owen Schroyer say exactly the same thing yesterday. He likes to say that now too. Oh, it definitely begs the question. No, it doesn't. That's not what that means.
Yeah,
Afternoon, guys.
Adam.
How can you beg the question? I've not even asked a question.
Okay.
I knew you were coming up with that.
Calm down, Jim.
Let's just cover that. So the question that's being asked is the assumption of the thing you're trying to prove. That should be a question. Is Earth sphere-shaped? Is the question. Well, in not answering the question and making sure that everybody agrees with me before we even discuss this subject of if Earth is a sphere or not, that is the question. I'll make my statement that Earth is a sphere, radius 3959, and because Earth's a sphere, radius 3959, the horizon blocks boats and buildings. So it starts with the very premise that you should be asking a question about rather than stating as an implicit fact assumed in the first instance. That's why it's called begging the question. Because rather than actually querying whether or not Earth's a sphere, we're just going to assume it. We're going to beg that's true. It's the begging of the question, hence the terminology. We're going to be assuming it rather than asking it. We just beg that question.
Right, so this colloquial use of begging the question is a malformation. What they should be saying, what they're probably implying is it begs to be questioned. Not the question.
Yes, that's
right?
that's an equally good phraseology rather than raises the question. Say that again, Alan.
It begs to be questioned would be a better way to say it.
It begs
not
to
as
be
eloquent as
questioned. Maybe. It's too close in terminology, but yes, it's equally correct English-wise, I suspect, although I haven't checked. But yeah, that sounds right grammatically. Okay,
right, because they're saying it because they are like about something that is said like we need to question that, like that seems blatantly wrong, so it begs to be questioned. It's not begging the question.
Yeah, it leaves us with a question.
It requires inquiry.
Yeah, it requires inquiry. It leaves us with a question of X, Y, and Z. So, yeah, it's just not the fallacy of begging the question. Either way, the question being begged in this instance is a sphere Earth, and whether or not we have one, assumed in the first instance, to say, if Earth is a sphere, then we're going to see horizon blocking stuff. Well, if Earth's a sphere is your positive assertion that Earth's a sphere that I've got to accept before we move forward in this discussion. AKA begging the question. Any more for
I
any
agree.
more?
All ballers are beggars.
All examples of a sphere Earth will always start with begging the question without exception.
Right. Begging the question is effectively assuming the outcome within the premise.
Correct.
That's what it is.
Go on, John.
Are we going to go into how they use a false dichotomy with kind of a begging the question, but both of the models they use in the false dichotomy are flat Earth models?
Sure.
We're going to go into that one.
Okay, so dichotomy is... Who wants to explain what a dichotomy is first?
A dichotomy is something either is or isn't.
A two-choice solution.
Also known as a false dilemma.
False dilemma, yeah.
It's presented that there are only two possible solutions, so it's a false. There could either be incorrect solutions or there could be more than two.
Yeah. So I think, thank you, Adam. What John's driving at is to say that to mask the assumption of the outcome of the thing that's being debated, i.e. Earth being a sphere, you can hide that fallacy under another fallacy. So a second layer, which is offering up two alternatives. One is the assumption of a sphere Earth, the question being begged thereof, and an alternative that you, their opponent, may or may not have actually claimed, which is a second model. So they position you on a pizza pie flying up through a sky vacuum with a boat falling over the edge of a circular disc, and they with their if Earth's a sphere radius 3959. Those are the two positions they'll present. Question you on your adherence to their second position they've voiced upon you, whilst declaring that the outcome of the proposition put to you for a model you haven't necessarily claimed has only one alternative, and if their example is shown to be correct, their alternative is the winner. In this example, the sphere Earth is the winner when offered up in false dichotomy. If Earth a sphere radius 3959 versus if Earth a pizza pie in a sky vacuum with boats falling off a disc.
That's the least important one of all.
The least?
The least important,
the least important
one.
one. Very good.
Well, the reason I bring that one up is because their false dichotomy is of two flat Earth models.
I knew that's where you were going. Can you expand on that, please?
Well, they'll say stellarium. They'll use stellarium as their model, which is a flat Earth model. It's just got the celestial sphere around you, but that's a flat Earth model. And then they'll hold that up against, say, that equidistant projection, azimuthal equidistant projection, and say, well, this one matches observation. The stellarium matches what I see better than yours, therefore mine's true. And then nobody's ever questioned why are they both flat Earth models?
Correct. So they'll hold up the azimuthal equidistant projection, which is North Pole centric, and say this is your flat Earth model. Now, true, if you were standing at the North Pole, that would be your perspective representation of the stars above you, and when translated into stellarium from your actual location, it's essentially doing the same thing, but projecting out the azimuthal equidistant projection with the stars above your location. So both are flat Earth models, but they'll say stellarium's a globe model. Well, this has come from the globe. And they'll say that your flat Earth model that you haven't necessarily claimed, azimuthal equidistant, North Pole centric projection, they'll tell you that that's your model. And if you even squeeze a minor win out of that model for whatever reason that you might do so, because you've claimed it, they'll say that it's a globe projection also. They'll tell you that both models have come from a globe. That when you describe the azimuthal equidistant North Pole centric projection, that projection is a projection of a globe. That's what they'll tell you. Now, in reality,
that would be
both are used for navigation with elevation angle measurements off a flat plane. Both require a flat plane to function. Both are flat Earth models, but they're being held up in false dichotomy, which is John's point, with just a mere claim by Fiat that it's a globe model when it isn't.
Right. When Globers say that's based off the globe model, that's projection, because that's actually what they base their globe model off. They just don't want to realize it.
Right.
Phil B trick. Phil B does it all the time.
But before
they project the ground up onto the celestial sphere is how they make the globe. But the celestial sphere model is a flat Earth model.
I'll tell you right now, most normies are not ready to hear that their globe came from flat Earth elevation angles. They're not ready for that. I've said it to a couple of them, and they look at me like I have 3 heads.
I wasn't ready for the way that John just phrased that. So up until now, I've described what John's just said, and I'll repeat it in a second, as them taking the ground that you're taking an angle from and saying that you're stood upon the arc of the tool, and therefore you're moving around the rotational basis, the circumference of that tool. When you see the star drop towards the horizon, it's you moving around the tool, therefore taking the flat plane that you've got the angle from, making it the spherical surface of the protractor or the sextant. Okay, that's my rather long-winded way of describing what John's just described as taking the flat plane that you're standing on and projecting it up to the sky. Wow, that was much more concise. And visually, I can picture that far easier than what I described as laying the world up on top of a protractor. That's rubbish. What you've just described, the projection of the flat plane, so let's describe it as a azimuthal equidistant projection from your location in America, and then projecting the ground that you've stood and can get angles from, flat, up onto the ceiling in a curved way. Well, that's what the globe is, isn't it? That was brilliant. I'm slightly taken aback by that, John. That was excellent. Nothing to do with fallacies. It was brilliant all the same.
I thought that my projection conclusion was also pretty dead on. They tell them, oh, that's our model. No, that's what you based your model off. That doesn't mean that it started off like that. It's the other way around. You're projecting, Globy.
Right.
Yeah,
let's not get confused. Let's not... Just got to discern what that meant. When Arwin says projection, he means psychologically putting on your opponent what you are actually guilty of. Sort of Hillary Clinton
Right,
style.
Psychological projection, not the actual map projection.
Yeah,
that
that's why it needs clarity.
Confusing.
Because we're talking about projecting the surface of ground up onto a dome, and then you're talking about globers psychologically projecting their ill will onto you. And what they're doing in this instance, they're projecting the fact that they take a flat plane and project it up onto the sky in the curve of your perspective view and call that the sphere surface, the globe Earth. And you're saying when they do that, they project, psychologically, they're using a flat plane on a curved sky and tell you that you've taken your flat map from a curved surface. So they project the very thing they've done, which is hijack the flat plane and call it a curve, and tell you you've done it. That's what Arwin means by projection, and he's right.
They're psychologically projecting their map projecting scenario onto the flat earthers.
Yes.
Nathan, I put a slide in Master B. We covered this a week or two ago. And John, you can jump in and comment on this if this is what you're saying.
Yeah, it's a quite complex way of showing it, but yes.
So here you've got the equatorial plane, and you get your angle from a flat baseline. Then it's projected up to the celestial sphere, and then from there it's re-projected back to the supposed sphere of the Earth, as you can see there.
Right. So you've got the elevation angle measurement from your position at the centre of this circle, which is a flat baseline. The only way to get these angles up to these stars. And that's how it's depicted in the first instance. That's the origins of all of these models. They're all taken from a flat plane. Your globe's a flat Earth. In case you hadn't picked up on that and you're a sphere believer watching right now. I think a lot of them are probably tuned out just through twitching. Anyway, so what Tent's describing is how it's then projected up into the curve of the tool. So what you've got here, going over the top of this flat plane, is essentially the arc of the projector that you're measuring the angle with. So if you take this star on the left, that's the angle. There's the flat baseline. There's you. That's your measurement of an angle, right? Well, the tool that you'd measure those angles through could be described as this dome shape over the top of you. You could put the degrees over the top of it, right, from 0 to 180. So this would be your tool. But then you project up the ground onto what was just an arc of the tool that you were measuring, giving you a perspective view of the stars over here, right? And then you say, that's the ground. And now we've got these new angles that don't work anymore off a curved surface that can't give you an angle. But that's the switcheroo. And where Arwin's saying, when they tell you that an azimuthal equidistant projection's actually a globe projection, it's like, no, it bloody isn't. Your globe was projected up from this flat surface. It's the only way you got angles to the stars. You couldn't do it off a curve. It doesn't give you an angle. But the tool and its curve has become your surface.
Yeah, can you go to the next slide?
Yep.
Okay, astronomical triangle. Combining the celestial sphere concept and the horizon system of coordinates. We derive a triangle on the surface of the celestial sphere known as the astronomical triangle. This triangle projected back to the Earth's surface is the navigational triangle. In practice, the terms astronomical and navigational as applied to triangles are synonymous. So basically, the picture is being described here. They take an angle off a flat horizontal coordinate system because it's flat, and then they project it to a celestial sphere, and then from there throw it back and create a fake sphere for the Earth.
It's like, it's like everybody's heard the terminology as above, so below, and they've hijacked that terminology because that's exactly what they've done. They've took the perspective angle of a dome above, and brought it below and turned that into a globe Earth. So they've hijacked the terminology as above, so below.
Right. What do you think the
not quite.
Symbol for masonry is? It's the square and the compass.
Yep.
They've hijacked the fact that we see a dome.
We see in a dome perspective, we have an arc, which let's just bring it back up on screen. Adam's absolutely correct. This dome represents your field of view, which is measurable with the arc of the tool. So that's not a dome over your head. That's the tool measurement. So you could put the end, like I said, 180, 0. That's what we're talking about when he says dome. We know what you mean, one deck, and Adam's just clarifying he's not having a dig. But carry on, Adam, sorry.
Okay.
No, that was it. It was just to say, just to recognize, it's important to recognize that even though that's how we're seeing it, or imagining it, remember, yeah, we're creating that dome in our mind, in our vision. Yeah, it's not there. It's just that same drone at a different distance, so it looks like it's doming. But we just got to remember that the angle means distance.
Next slide, please. Adam, comment on this next slide because this is how the eye works.
Oh, where did you get this? This is great.
I showed it 2 weeks ago.
I don't remember seeing this.
Go on, Adam. I think you're more knowledgeable on this, but this is the way we see.
I've got nothing on screen.
Master B.
While the audience can see it, this is the dome that we've just described. So when I said you could draw the digits of the degrees, 90, 180, 0, well, this is exactly the same, but on a much smaller scale than I'd ever tried to describe it visually, but just as good. That's this. Not a dome over your heaven. That's what it is. It's just the arc of your vision. from horizon to horizon. Doesn't mean there's a dome over you, and it's why the azimuthal equidistant projection is projected from wherever location you're at when you make these measurements. It's only relevant to your specific position. I mean, it's a feat of feat of genius how the azimuthal equidistant projection actually functions. Amazing. Anyway, this eye shows exactly that. There's your protractor, your compass, or whatever you want to call it. Effectively, the sextant in your eye.
I think the word you were looking for is cartography. It's an amazing feat of cartography.
That's the one I was looking for. It's an amazing feat of cartography. Map making.
When we're looking at the eye there, I just want to distinguish that when we talk about angles being distance, that is only in relation to celestial navigation. If we're dealing with terrestrial objects, other things come into play. But when we are dealing with celestial navigation, then an angle is a distance.
Well, I think it's interesting that we take the measurements off a flat plane. We then model it as a flat plane. And then you take each of the zenith points or GP positions from the ground and apply it to that model of a flat plane, but in the sky instead of on the ground. And you got yourself a globe.
Amazing. Isn't it amazing? I never ever anticipated getting to this stage in Flat Earth where I believe I've now got a comprehensive understanding of how the Earth was measured, how it was then turned into a sphere, and how that was then perpetrated upon the Western world. I can talk about it from start to finish with examples of how it's done and examples of how it's still in current use as a flat plane in modern day life. Earth is flat. There was one last fallacy that didn't quite get covered with one of the examples that John for refracted curvature brought up, which is the stereotyping fallacy. So the stereotyping fallacy is where an assumption is made based on your group affiliation. So in this instance, as a flat earther, in quotes, it would be automatically assumed in the example given earlier with a false dichotomy that you do obviously automatically believe in pizza pie Earth flying up through a sky vacuum at 9.8 meters per second, with a boat falling off the edge and water falling off the edge. You think that, don't you, flat earther? Well, that's because that's a stereotyping fallacy, i.e. the automatic assumption that you abide by whatever that is claimed to be the viewpoints of the group. Now, there's a rude awakening to stereotyping fallacies if you come here and debate us as a globe earther, and if you're a regular watcher of the show, you'll know that's the case. Well, where's the dome? Sorry, what dome? The dome over a flat earth. Do you claim there's a dome over a flat earth? No, you do. Do I? When did I claim that? Etc, etc. So stereotyping fallacy is the door that needs to be opened, or kicked opened for us, to get you into the false dichotomy of having two models, one that you definitely believe in as a flat earther and their model that is only being offered up in false dichotomy to mask the begging the question fallacy. Now there's all sorts of complex layers that fallacies can be presented in, and just diluting them down to this simplistic form with affirming the consequent, it isn't really applicable in real world scenarios. And I'll tell you why. Because while we've touched on this masking of a begging the question fallacy with a false dichotomy, yeah, which had to be employing a stereotyping fallacy in order for it to take place, the person that's doing this, number one, they don't necessarily know that they're committing multiple levels of fallacy, but they will. And they don't necessarily believe you when you pull apart their logical fallacy with reasoning. They'll normally just talk through you, so it's more difficult than just explaining to somebody how their reasoning is flawed when it's layered up so much, and half the time the fallacy hasn't been given its full form. So you've got to know the fallacy, you've got to know how it would be formed if it was to be formed, but they haven't. They've only given you half of it and kind of made you give the other half to make the conclusion for them. All of these different layers isn't something that we're going to expect any member of the audience just immediately pick up on. But I do feel we've had a success in terms of really breaking down affirming the consequent today, and the various aspects of other fallacies that go along with it, i.e. stereotyping, begging the question, false dichotomy, And I don't think that was it. I think that was it. Was that? And the actual logic of modus tollens once you rip apart a claim that's proved to be incorrect, even though it's made with logic that's flawed. Any other summaries?
Listening. They're not listening in chat. They're losing their mind.
Everything that the Globers do, is a proto-fallacy, because they've introduced the globe after they've taken the flat Earth angle measurements, after they've used the flat Earth model to project those up onto the sky. Then they introduce the proto-fallacy, where it must be a sphere, even though nothing has given you the idea that it is a sphere from those things. That's when they interject that, and that's what corrupts their logic from then on out.
Yeah, and if anybody was to postulate that there's a shill amongst us because this very fallacy was heavily promoted by a character known as Proto-Thad. He literally was the sort of main person to come here at the very least to push that fallacy. So if someone was to say, that's no coincidence, I go, yeah, you're probably right. Shill.
Well, a thad is, in the Urban Dictionary, is a musical creature that leads one astray.
So a guy employing the proto-fallacy and leading people astray was called Proto-Thad. Just like rumpus being called the rumpus. A disturbance. That's what a rumpus is. Yeah. Like I say, total conspiratard way to end a very good show on fallacy. I didn't mean it. You don't have to take that too seriously. But it is just a funny coincidence that the proto-fallacy was employed by Proto-Thad, the screen name. Yes, we all agree. Amazing coincidence.
You may have to go over necessary antecedent with what I'm reading in YouTube chat. Oh my God, these people are lost.
Concerned yourself with the YouTube chat, have you? That's
I just jumped in for a second.
Nathan, you're just
barometers and put your hand in front of a fan. I told them go back to 2014. This is too advanced. See you later.
Nathan, you're just hung up on the angle still, aren't huh?
You're just getting hung up on that flat Earth elevation angle we need to employ this proto-fallacy of using the opponent's point to then move on to the assertion that we are using a sphere when we've already used a flat Earth and proved it. Yeah. Maybe I just need to stop getting hung up on that angle.
By the way, let me just say something real quick. Yesterday, I'm doing a job, and this guy built a big, table. It's more like a stage, so you could work on carpet. And he had these little holes going throughout it, like an air hockey table. So you flick the switch, and it throws air up, and you're able to move the carpet around. So he said to me, there's a science behind this. And I said, well, it's not science, maybe technology. And he agreed. So I think most people agree that when they say science, they don't mean science. They've just been so indoctrinated by the word that they'll just say science when they mean technology.
Well, I was going to moan that was a terrible way to end the show, but it wasn't actually bad. You rounded it out okay, Neil. But yeah, with that, I'll say if you are watching this on either Nathan Oakley 1980 or Nathan Oakley Premiering streams, then stay tuned as there will be an after show to follow. Unfortunately, though, if you are watching this live, this is where we bid you farewell. So a huge, massive, enormous thank you to all of you smashed the super chat, liked, commented, shared, subscribed, hit the thanks button, the PayPal link, and all that good stuff. Once again, stay tuned if you're watching on either Premiering stream. I've been Nathan Oakley. Another massive thank you to today's Discord and G+ panels, and I'll see you all in the next video.
What a lovely day!
If the Earth was a ball, as claimed, it should display measurable curvature. It does not. It's not our fault. Greetings, everybody.
Hello? Hello? Testing, testing, testing. Yeah, you know me in Livestream, so you know me, so but like I like that troll and nothing, so and make a agreement, so hey, Black Flows and Effie Batman will be flat. So it's all you guys, so. Wake up, my bad. Sorry. Okay.
All right. Hey, Brenda, did you bring with you any brand new globe proofs that you think are globe proofs with us?
All the old ones work perfectly good.
Oh, I see. Since they don't, do you have a new favorite?
Foucault's pendulum.
That's not new. I guess we could maybe talk about how that doesn't prove the Earth is moving because you have to start it yourself, but sure.
Let's talk about how you were hypnotized by the pendulum, right? Because that's a device that the hypnosis guy uses to hypnotize. Brenda, are you still in a state of hypnosis because of that pendulum?
I am not hypnotized.
Dude said he's a
hypnotized.
What the hell?
See, I would just like to go over how do you know that it isn't caused by a rabbit's tail, right? How do you know what's causing it? Because I know you got observations. We all see it doing what it does, right? The pendulum swings this way, right? And we all know that it changes degree, right? But how do we know what's causing that? How have you ruled out all the other possible, I hate to say the word, but variables?
Basically, if the Earth is rotating, if the Earth is stationary, the pendulum will not diverge. The pendulum does diverge. Therefore, it cannot be stationary.
All right, so let me give you an example of affirming the consequence. Affirming the consequence. So the lamp isn't working, therefore it has to be the bulb. The lamp isn't working, so it must be the bulb.
Yeah, that's
what if it's unplugged?
That's not what I said.
I know that's not what you said. That's what I said. Right.
Yeah.
So what if the cat unplugged? What if the cat unplugged the lamp, or what if the dog chewed it and claimed? Right? Is it possible that you're not aware of the Earth being stationary? So how would you know what it would do when it would be stationary in your worldview?
I just know that it can't be stationary because if it was stationary, the pendulum would not diverge.
What pendulum?
Foucault's pendulum.
Where is that? Where is this pendulum that's moving? Where is it?
And wait, I have a question though. Before that, do you have an example of an Earth that is stationary where a pendulum does something different?
No, it's just that if it was stationary, the pendulum would not diverge. But it does diverge, but can't be stationary.
Wait, hold on. Let me break this down in a different way. So in order to know that what you're saying makes any sense, wouldn't you have to have two Earths, one that's stationary and one that's not, with two pendulums doing different things?
That is correct.
Why would I need two Earths?
Because then you would know that's the difference. You'd have one Earth to look at that's moving and the pendulum's doing this thing, and then one Earth that's stationary and the pendulum's doing that thing. And then you can see, oh yeah, so this pendulum doing this is an indicator that the Earth is moving and it's not stationary.
No, I don't think I need two Earths. I think I just need the modus tollens, which is that if the Earth is stationary, it will not diverge, and it does diverge. Therefore, it can't be stationary.
How do you know it doesn't diverge on a stationary Earth? What if there is some magnetic phenomena that we are not aware of, or we don't know? I mean, literally ask the illiterate people, because the literate people, they do know. What if there is some magnetic phenomena which actually makes that pendulum deflect? I think you mean deflection, not divergence.
Divergent
They are
deflect.
driven by motors and magnets.
Diverge and deflect are the same thing. They're synonyms. And plus, the pendulum isn't made out of a magnetic material.
Yeah, it is. Read the
No,
manual.
it isn't.
It's driven by magnets.
Diverge means to spread.
Yeah.
It's synonym with spreading.
Yeah.
But deflection means to change direction.
Yeah.
It's not a synonym.
As I am using them, they're the same.
Well, as you are using, but
yeah,
you're using it wrong. Anyway.
No, I'm not.
You guys are desperate for a Glover.
Yeah.
Right.
So
it diverges or deflects from a straight line.
So is there anything else that the Earth rotates under, or just this one pendulum that's driven by magnets?
The pendulum isn't driven by magnets.
Yeah, it is.
You don't
If
know
you-
it very
hold on,
well.
hold on.
Some are. Some
You
might
don't know
be.
the globe proofsy very well,
Guys,
do you?
guys, hold on. Brenda, would you please look into the live stream voice text if you're
Yeah,
able?
I see it.
I
I see
just
it.
posted a link from the Smithsonian Institution about the Foucault pendulum they have there. They say there's an electronic device, an electromagnet in it, and you're saying there's not. So who's wrong?
I'm not talking about that one.
Which one are you talking about?
Yeah, can you tell me the name of the pendulum you're talking about?
Any pendulum.
Where is it? Okay, well, I tried to make a pendulum, and what happened was it ended up diverging in different directions when I.
Therefore, the Earth isn't spinning. Then,
But
I mean,
he's
the
changing
Earth
the
is stationary.
Brenda,
If it diverged, then it's.
You know, the Earth has a electromagnetic field that could also be the reason why a pendulum works.
Well, not if the pendulum is non-magnetic. It can't be.
So do these pendulums start themselves, or do they have to be started, Brenda?
They eventually just come to rest, right?
That's not an answer to the question.
That is an answer. He said. He asked
No,
if
he
they.
asked,
I
he
said
asked,
they
do you
do.
have to start them? And you said, well, they eventually come to rest.
No, he asked
do you
if
have to
they
start
stop.
it?
No, he asked if they stop.
No. You
How
might have
do they
misheard the
start?
Scottish accent.
Yeah, I did
Yeah.
misunderstand him.
Okay, so how do these start? Do they start themselves?
No, you have to start them.
Right. So, and then if you
So-
look at what's been posted, you'll see magnets and more energy is needed to continue them
I'm talking.
on their swing. Or
I'm
they
talking about.
come to stop.
I'm talking about pendulums that don't have magnets.
No,
Okay,
you're
so
talking about
saying,
Foucault's
hold on,
pendulum. That's
wait.
what you said
Can I
to
ask him
start with.
can I genuinely ask him something, please? You're saying that whether it's the
Well, he's
rotation,
lying.
what are you saying is happening causing the pendulum to swing back and forth?
Well, there is a Coriolis force applied to the pendulum, which causes it to
Coriolis.
diverge from a straight line.
Coriolis is a
Right?
force. When did
Coriolis
it
effect,
become a
yes.
force?
Coriolis is a force, right?
No, it's an
not.
effect.
It's an
an
apparent
effect.
deflection.
Yeah, it's a pseudo force.
It's not a
Yes, you're right, but it's still a force. It's a pseudo force, but it still counts as a force.
Pseudo
No,
force
it's an
is.
effect.
How can you say
So wait, is
a
Coriolis
pseudo
is
force
this
as a force?
gravity? Is Coriolis
People are-
density, gravity, magnetization?
No.
What is it?
Coriolis is conservation of momentum.
But so then you have to initiate the movement for it to keep going. You're talking about perpetual motion.
I'm not talking about perpetual motion. I'm talking about the motion of the bob on the pendulum,
Well,
right?
It should be. Surely, if it's affected by the Earth, then surely it should be perpetual. We should be able to harness this
Why would it be
energy
perpetual?
because the Earth's constantly moving. In your model,
According
Welcome to
to
Globe Earth.
you cut out there. Sorry.
according to the Coriolis force, wow. Okay, I just don't believe that at all, honestly.
Coriolis is
So,
Coriolis. It's a pseudo force.
Brenda,
Well,
rotation, orbit around.
You're roboting. You're roboting.
yeah, you're
I'm
roboting
saying,
hard, Sasha.
Can you hear me now? Can you hear me now?
Yeah. Yeah.
As always, as soon as you ask, "Can you hear me now?" people stop roboting. That happens every single time.
Listen to this. This is what Google says. If you don't like Google, I'm sorry, but it says in physics, the Coriolis force is an inertial or fictitious force that acts on objects in motion.
Yeah, that's
within a
correct.
frame.
Yeah.
So does that means this is a theory, right? Because this is literally using the word fictitious.
Yeah. Yes, it's a pseudo force or a fictitious force. Yeah. That doesn't mean it isn't real.
But is this are you subscribing to this? Are you willing to look beyond this?
No,
You should
they
look
say
beyond it.
I will raise my hand. I will raise my hand. My hand is upraised. I don't have a Bible with me. I will swear
no, you're
that
swearing
was
on
an
a Bible, Science? Why?
it's an accurate. The Google definition that the guy just read is an accurate.
You can swear on the globe.
Definition of a Coriolis force that I subscribe
Okay.
to.
Can I tell you something, man?
You can
You
swear
don't
on
have to swear on
Karl
anything.
Marx
This is just like we're just exploring stuff. Like
I'm just being a
quick question for the audience.
When you hear it,
Dude,
because Google says it.
I'm just being a little lighthearted to sort of cut the tension. That's all.
That's great, and that's fine, and that's fun.
I like
just have a
Google,
quick
but I wanna
question. I'll go
say-
away. Listen, I'll have a quick question, and I'll go away. Brenda, what's the opposite of fact?
A fiction.
Thank you.
Boom.
Right.
As you were.
I don't
Yes.
even like using Google, but you know, the fact that they put the word fictitious in the definition of it is crazy to me.
It started out here that your proof was Foucault's pendulum. You found out that they're driven by magnets, and then you shifted the goalposts to, I'm not talking about that pendulum. So which pendulum are you talking about?
I'm talking about all of the pendulums that don't have a magnetic device attached
so not
to them.
Foucault's pendulum. What you started with. So not that.
Those are Foucault pendulums. They're just ones with.
Okay.
Okay.
One moment.
So-
One moment, please. Brenda, you said you're talking about all the pendulums which do not have a magnetic device attached to them. Now, I personally debunked the Foucault's pendulum, and I can teach you how to do it very easily.
Sure.
You make a pendulum, and
When are you picking
instead.
up your Nobel Prize? When are you picking up your Nobel Prize in physics?
No, I'm not interested in
Oh,
Nobel
you'll
Prizes.
do that if somebody can prove
Well, because you
gravity.
refuted Foucault.
What?
And
When
you
are you going to get yours?
If you want to get one, you do so. You try to
You
do so.
refuted a major conservation
I'm
law
not
in
going.
physics.
Look. Listen.
Why don't you measure some
I tell
Earth
you what
curvature
to
and go
do.
get your Nobel Prize?
Can I finish at least?
Sorry.
Yeah, I've got a question
Yeah.
after you. Go for it, bro. Go for it.
Now, when you change the pendulum's weight, yeah, if you use like iron balls, lead balls, yeah, you will observe that pendulum deflection. But
Pendulum,
if
what?
you put,
I didn't hear you. I didn't hear you. Could you repeat that?
when you use a pendulum which has a iron weight or lead weight metal, yeah, which you are swinging, you will observe that deflection. And the funny thing is, iron, gold, and lead, they don't deflect at the same rate. They show different deflection ratios. Now, the thing is, when you change the weight with two opposing magnets, yeah, you glue together two opposing magnets and you use those as the pendulum weight, you will see that you swing them from left to right and they will swing in that way and they will not deflect. How do you explain that?
Yeah,
How do you explain this?
Yeah, I would not use magnets because they could be affected by any magnets or metal that's around it. And I wouldn't
You would not use the proof that
you are not
cited
around
Foucault's pendulum.
metals.
Well, suppose I don't know that. I could be.
Magnets can be affected if you have some metals close enough to them.
Or they could be
or
affected
strong magnets close enough. But if they are not close enough, yeah, they are just magnets.
Could they be affected by the Earth's magnetic field?
aren't
Wouldn't they? Wouldn't they
aren't
be?
all magnets in the world in direct?
So I wouldn't use magnets because they would be affected
They
by the
are
Earth's magnetic
present
field.
in. Listen.
So then you wouldn't use
When
Foucault's
you hold the
pendulum, which is the
magnet
thing
in
that you
your
cited.
hand, when you hold the magnet in your hand, that magnet is being present in the world's gigantic magnetic field. So it's already present in the magnetic field.
Right. So I want to eliminate that variable, so I wouldn't use magnets.
You can't. You
Well, that eliminates your
you
proof.
don't have a place. There is no such place in the world where you do not have
I would just use like
the
a
world's magnetic field.
I would just use a material that isn't affected by magnetism, like say concrete.
Yeah, but then you wouldn't use
Okay.
Foucault's
In
pendulum.
a concrete chamber, a room, a concrete room.
Concrete plumb, the concrete, the ball at the end.
And you make this pendulum. You make this pendulum with you glue together two magnets. Yeah, and you hang them on that wire, and you swing them, and you will see that they are not deflecting.
I would not use magnets because they would be affected by the Earth's
I ask
magnetic
you
field.
why the magnets do not deflect.
Probably because they're affected by the Earth's magnetic field.
Well, I'm not asking about probably.
You did.
I'm not
You
asking
did
about.
ask me.
No, I ask you if you know.
I would say that that's
How do you
most
explain
likely.
if you know?
I'm saying that's most likely the explanation.
Well, obviously, you are not an expert in Foucault's pendulum to know that it's actually a scam. Yeah.
How is it a scam?
Yeah. Official scientists, they explain how Foucault's pendulum is a scam.
Who?
The scientists.
Which
Physicists.
scientists?
You
Quantum
just agreed
physicists.
that.
No, they
you
don't.
just agreed that it's
Yeah,
not
they
proof
do.
anyway.
No,
He
they
just
don't.
agreed that it's not proof anyway, though, because he says that he wouldn't use a magnetic pendulum, which is what Foucault's pendulum is. So next.
Foucault's pendulum is not magnetic.
It is, buddy. Read the
No, it
manual and
isn't.
check the live stream voice text.
No,
it is
that isn't.
driven by magnets.
It is.
Yes, it is. You're
isn't.
just wrong. You don't understand your own proof.
And
Brenda, it is.
Brenda,
Read the
Pendulum
manual for it.
doesn't. That's just for their pendulum. That's not for.
Brenda, you
No,
said
that's
Brenda.
what Foucault's pendulum. That's how that works. That was your
No,
proof.
that's not how
You didn't
things
know it was
work.
magnetic. You've now admitted that you wouldn't use a magnetic pendulum, which is what your proof is. So you got to
No,
move on now.
proof isn't that
Brenda,
it's a
Brenda,
magnetic pendulum.
Brenda. One
Yeah,
more.
it
You
is driven
said
by magnets. Check the
Brenda.
live
You
stream
said
voice.
And more.
Brenda, you said in the beginning that you're not talking about the Smithsonian pendulum, and then you said you are talking about all other pendulums except that one. Yeah,
Right.
the
Those.
Smithsonian.
I said
And
not.
now, when I presented you,
Just a minute. Just a minute.
when I presented you a pendulum, which does not use magnetic devices, it uses two simple magnets. That's all it uses.
I would not use that one because in science.
Well, you will not, but you have to explain what's happening.
Because
why? And listen, when you put two magnets, listen, Brenda, when you put two magnets which attract each other, and you swing them, those magnets will deflect like any other metals, like all other pendulums. But only when you put them the way they repel each other, that's when you do not observe that deflection anymore.
I would not use magnets, period, because
you will not use magnets.
Okay.
Yeah,
because
it debunks
because I want to do a proper scientific experiment where I eliminate all possible confounding variables.
Okay,
Brenda, you haven't eliminated the magnetic field and the electric field, The
I've
ground is
eliminated
negative.
things that are affected.
Listen, we live
fields.
We live between two Gaussian planes, The ground negative and the sky positive.
You haven't got. That's not what I'm testing for. And we don't live between two planes.
Listen, you exist inside a magnetic and electric field.
That's your claim.
No, it's not my claim.
That's
This is
measurable.
scientifically explained.
That's why I wouldn't
It's
use
scientific
magnets.
fact.
That's why
It's
I wouldn't
scientific
use.
fact, Brenda. No, thunder
So Brenda,
strikes from the
That's
cloud
why
to
I
the
wouldn't
ground.
use magnets.
Brenda, basically you're saying that if you don't use magnets, then you're not using Foucault's pendulum as one of your proofs. You're using what, John Smith's pendulum, or
That's not what I'm
Steve Wright,
saying.
or like who?
That's not
Well,
what I'm saying.
You're saying, well, the basically the information for the Foucault's pendulum is in the live stream voice text. You could take a look at it and see that magnets and motors are used, and it has to be
That's just the
started itself.
Smithsonian. That's just the
Then,
Smithsonian one.
then,
No, I just posted
then
another
you've
one. Hold
got.
on, hold on. I just posted
Then,
something. The
then
original
what about?
Foucault pendulum was a lead bulb with brass. And then I posted a link from an educational site saying
of
lead
those
can
are
be affected by magnetic field. So the original, hold on, the original Foucault pendulum used a material susceptible to being influenced by magnetic fields. The end.
So did he have
Yeah, but all those metals, all those metals, lead and brass, they are both very good electroconductors.
Yeah, but they are not affected by
They conduct
magnetism.
electricity. Well, they are affected by electricity, by the electric
affected
field
by
that they are
magnetism?
present in.
Okay, let's move forward.
Magnetism.
Let's move forward because now we
Agreed.
realize that one device one device can, how to say, we can with focus pendulum we can realize that it's earth rotating. Let's go out and find out is that true.
Well, Brenda,
I'd like to point out a logical fallacy.
How do you explain? Sorry.
Brenda used
Brenda
the
reduced
logical
his own
fallacy
argument to a
begin
lie.
with. She tried to use the modus tollens, as in she actually used an inverse fallacy. If not P, then not
That's
Q.
not a. It's not the. I didn't make a fallacious argument.
Yes, because
I
you
said,
did say
if P then Q, not Q, therefore not P. That's
yes,
Modus
you did
Tollens.
that.
Hold
You
on,
did that.
hold on, time out.
You inversed
Time out,
it.
just
No,
give me a
but
second, guys.
just let me finish for a moment, please. She inversed it because she was trying to
Modus
escape
Tollens.
the assuming the consequent fallacy.
Modus Tollens is not fallacious.
You inversed it. It's an inverse
If
fallacy.
P then Q, not Q, therefore not P. That's Modus Tollens. That's the argument I presented.
You are saying it as in, if not P, then not
That's not what I
Q.
said.
Great.
I said,
Yes, it
if
is.
P then
Brenda,
Q, not
So,
Q,
Brenda,
therefore
Thank
not P.
thank you, Brenda.
Yeah,
Because of this, that is the problem.
electric. Okay, he told you. Maybe he misspoke. Yeah, so
What'd I
it's been
say?
clarified. Get over it.
Brenda, hold it. But
What
can
did I
you
say?
explain, Brenda? Can you explain the Elias effect with these pendulums during
I
eclipses?
don't know what that is. I don't know what that is.
That's where during eclipses, supposedly these pendulums alter their swing and possibly.
Has anybody been able to reproduce that?
Well, I mean, Google's
No,
usually
have they?
a global
Nobody's
cause.
been able. Nobody has been able to reproduce. I understand. I'm familiar. I'm familiar.
You never knew about it. I thought you never knew anything about it.
Nobody has been able to reproduce it, have they?
Apart from who?
Elias.
So just one person.
Right.
Then
So it
you
hasn't
know
been.
you know every person in the world has done this.
It's been tried. Nobody's been able to reproduce it.
But so why is it even a thing? Why is there people arguing it?
Well, people aren't. Not real physicists aren't. Nobody's arguing it.
What's a real physicist?
Yeah, nobody's arguing that.
No, but what's a real physicist? Like, as long as they believe in gravity that can't be proven experimentally,
right?
That these pendulums swing by themselves, and like all these things that you have to have faith in.
So the definition of science is repeatable, right?
No, it's a method.
Repeatable.
It's a
No, the
method.
scientific. Yes, that's right. Repeatable, falsifiable, verifiable. That's what science is. Repeatable, falsifiable, verifiable.
Brenda, if that's the case, then where's the experiment for
if
gravity.
What? Oh, people do that every day at Cavendish.
That's not an experiment.
Yeah, it
Doesn't
is.
follow the scientific
Brenda.
method.
Yes, it does.
What's the independent variable for Cavendish?
The distance.
The distance.
Yeah, the distance
so
between.
Your distance is your cause. That's what you're saying.
Yeah, you vary the distance,
your
and you
cause was gravity. You may be proving gravity, no distance.
Gravity varies with distance between the centers of the two masses. So you vary the distance, and you vary the strength of gravity.
Oh, did you prove
Can
gravity
you show me
before
a
you claim it?
Cavendish?
See, before you actually do claim gravity does things, you can't just say, "Well, gravity does this, so I'll do this experiment because gravity does this." You can't just
It's a formally valid experiment, right?
Okay, how did you isolate gravity from the electromagnetic forces?
Yeah, the independent variable is the cause. If you're proving gravity, then that's your cause, obviously. No, your distance.
Well, the IV doesn't have to be the direct cause. It could be an indirect cause. So indirectly, by varying the distance between the two masses, you'll vary the effect of gravity.
But you never proved gravity in the first place. You can't claim
gravity is defined. Gravity is defined as proportional to the distance between the centers of the two masses.
And was it defined?
Defining the thing you're trying to prove.
That it was defined before it was even backed up by experiment.
Right, because Newton was a genius, so he came up with. Yes, Newton.
Fuck Newton. It might not have even fucking existed.
So we let
Newton defined gravity as a force that varies with inverse proportion to the distance between the two masses.
But it's not a force. It's not a force. According to Einstein, you've not got a force anymore. It was supplanted by Einstein, over a century ago, man.
It's a inertial force. Yes, you're correct.
So it's not a force, but it's a force.
It's a pseudo force. Gravity is a pseudo force.
Again,
so Brenda, what's the difference between a force and a pseudo force then? I mean, this language is very confusing and very hard to follow. What's the difference?
I can explain it to you. It means that it's not fun. This means that it's not fundamental. That it is caused by other underlying physical properties going on.
Okay, so what's the underlying thing for gravity? What's the real force underneath the pseudo force of gravity, or whatever you're
the bending of space-time.
Whoa, concept. You're giving concept.
To me, it sounds like there's a ton of questions, and for every question, you have another explanation, and that needs an explanation, and that needs an explanation. It's like it's just never ending with the fucking.
That's true. Well, it does end. It does end at a certain. There is an ending.
Brenda. Where did space and time do concepts? Where did they get physical properties and be able to stretch a conceptual medium?
Space-time is not a concept.
Space is a concept. Time is a concept.
Yeah, but
the two
space-time
of them together. Who proved this?
Space-time is different from space and from time.
Who proved it with experiment? Following the scientific method. Tell me.
Eddington.
By
observing the bending of a distant star past the sun at the prescribed amount.
Does that include the photographic slides from the second telescope where it didn't bend around the sun?
No.
So right. So
there were two telescopes,
he showed
right?
it doesn't matter, right? So they showed.
Yeah, it does matter because they had a bunch of photographic slides, and they selected the ones where the light was bending according to their theory, and they threw out the ones that didn't match. That's called cherry picking. It's bullshit.
No, that they were thrown out for other reasons because they were just not good. They were just not good slides.
What reason?
Come on,
that space-time is
a moment to Google. How about that?
I mean, like,
I do not have Windows open,
dude. Like,
so we have space-time being a real
information.
I can't hear when everybody talks at once. I can't hear.
I'm just trying to say one thing. You're being presented a ton of information that doesn't align with like the basic model of the globe Earth. Like, you have to try to look past the ship for a second, bro.
Gravity doesn't have anything to do with the globe Earth or the geometric shape of the Earth.
Reasons, by the way.
course
What
it
reasons
does.
did they have for throwing away the slides? You said they had reasons. Can you specify?
No, I can't.
So why did you say they have reasons?
Because I just assumed that they did.
All right, fair enough.
And because they did subsequent
Brenda.
observations afterwards. There have been other observations.
But can you remember when I asked you for experimental evidence for space-time bending and you gave me an observation? That would just be an observation. It's not an experiment. You cannot manipulate what's up in the sky, trillions of light years or whatever away. An observation's not an experiment, Brenda. Come on.
Sure,
it's part of the process, but you can't just say, oh, I saw something and I assume this and it backs up what I already believe, so fuck it.
Well, there have been plenty of other observations, and observations are used.
Bro, so sorry, Brenda, I'm asking you specifically for an experiment following the scientific method that proves the existence of this space-time.
Right, so observations are perfectly good for
You're still not giving me
contradictory.
Can you give me an experiment rather than waffling about
observations are perfectly acceptable for giving confirmation evidence, confirmatory or disconfirmatory evidence to support or otherwise refute or disconfirm a theory.
Brenda, come on now. I asked you for an experiment.
I don't have to give you an experiment. I can give you observation.
You don't have one at all for either gravity. You literally have nothing apart from
That's not true. No, that's not true.
Dependent, independent variable and a viable hypothesis. No,
I already gave it to you.
Distance is the independent variable. Come on.
I already gave it to you. It's the Cavendish.
The IV is the cause.
Yes.
When the distance is not the cause, you're trying to prove gravity, not distance.
If the force varies with inverse if the force varies in inverse proportion to the distance, then varying the distance would be varying the cause.
What force?
The force of gravity. It's a pseudo. It's a pseudo force. It's a pseudo force.
Exactly. So
I'm a pseudo doctor, Brenda.
It's a different sense of the word.
Right, but the problem is what he's basically doing is saying there are invisible pixies pulling things down. If there are, then my lighter's gonna drop. Here, look, it dropped. So there must be pixies. This is literally the argument he's making.
That would be affirming the consequent, which I've not done.
Which is what you've done.
I used modus tollens. I used modus tollens, not affirming the consequent.
You're affirming the consequent if you're saying that the distance
I'm not.
If you're saying the distance is the IV, and you're claiming that distance
not affirming the consequent. That's the IV.
Your IV is your cause. You're trying to prove gravity, not distance. I never asked you for an experiment to prove distance, did I?
Well, we know that the distance.
You don't know. You've not proven anything. You can't claim shit before you've proved it.
That's the hypothesis. The hypothesis is that the strength of the force varies in inverse proportion to the distance between the masses.
And the hypothesis is not been proved until the experiment is finished.
So then, if you vary the distance between the objects, you are varying the IV.
Wait, hold on. That's not true. Isn't it? I thought it had to do with like wind and air pressure. That's what the amount of density in the object doesn't change how fast it's going to fall to the earth. It's supposed to be like the amount of wind or something. Am I incorrect?
I'm not talking about things falling. I'm talking about gravity.
Oh, I'm sorry.
Why do
gravity is the property that makes things fall?
Gravity is the property of two objects having mass being.
Gravity is a theory, by the way.
Just,
so
please, it's a scientific theory. It's a scientific theory. It's not just something.
No, it's not. It's not scientific whatsoever. There's no scientific experiment. You've not got science in either gravity. Neither of them are a theory.
I told you.
Just real fast. hold on, Brenda, just real fast. I want to put something in there. So, flat earthers are the ones that claim that things fall down, right? What the globe earthers are claiming is that balls circle each other in the sky like a perpetual motion machine without ever like falling away from each other.
No, that's not
And they fall
perpetual.
like, oh, really? When's it going to end?
Eventually,
Millions of years. Is it like 5 million years or some shit like
yeah,
that?
some shit like that. Yeah, something like that. Yeah.
I'll put that on my calendar, man, just to make sure.
Yeah, it takes a very long time, but eventually orbits decay, right? And the object will fall to the heavier object.
When did anyone ever prove anything of the sort when you're talking on time
With the
scales?
Cavendish experiment. With the Cavendish.
Okay, how does Cavendish isolate gravity?
Doesn't
How does Cavendish isolate gravity from electrostatic forces?
Nah, he thinks
by using non-magnetic materials. That's how.
You know the laws of
What
natural
was
density
the
explains
observed natural
everything.
phenomena?
Like you don't need all this like explanations of gravitational pull and buoyancy. Like you don't need all that to explain it when you have natural density.
And
density is not a force.
Forces are present in all intermolecular interactions.
Yeah, but no, that doesn't matter.
What did you do to isolate? Yeah, what did you do to isolate your Cavendish from that?
From matter?
Buoyancy is a force.
Buoyancy literally contains gravity in one of the terms of the formula.
Yeah, even though you've not proved gravity.
Prove it.
It's literally in the formula. Another word for buoyancy is another word for
made up formulas.
It's not made up. It's based on observations and experiments.
Observations.
Who made the formula?
You've not got
I
experiments.
don't know who came up with the formula for buoyancy.
Man wrote it. Isn't that the same reason why you don't believe in historical books, right? Like the Bible.
Well, humans do science. That's what humans do. Yeah.
Globers don't seem to want to do any science.
So
we do.
What
are you
gravity,
talking about,
Brenda?
Yeah, well,
can we
gravity?
You're trying
Cavendish is scientific. I could not be interrupted for once. Gravity is an apparent. Gravity is an apparent force of attraction between objects having mass.
Would that be Newton's version of gravity?
Yeah.
So what about Einstein? He supplanted Newton.
It's more or less the same thing, except
more
that
or less.
We got 3 space and then 4 space. Is Newton got a 4 space continuum space time? You said it's the same thing, right?
I said it was.
Is Newton got 4 space? So
no.
Here's the deal.
So you ask me questions and then you keep talking. Could you let me answer
Make
you?
Him answer that. What? Make him answer
Go
that.
ahead.
Mike.
Right. So I don't think Newton had the idea that space and time were separate. Einstein unified them into a new thing that's separate from both, called space-time. It's neither space nor time. It's neither space nor time.
Okay, so it's a fabric, right?
Like a super concept.
It's a fabric. What is this fabric made out of? The space-time continuum.
Well, there are people that think that space-time itself could be the result of underlying physics properties going on, but that hasn't been confirmed yet. There are people working on theories that would explain space-time as an emergent property.
You're willing to accept all these changes to these scientific theories?
Yes, because that's how science advances.
So what exactly? What your like stream of information? Who do you trust? Like you're just trusting whoever is just giving you heliocentrism?
I will trust official sources, and I will trust physics books and
official sources.
Okay.
Yes.
So appeals to authority.
So what about
No.
reality?
Nothing empirical.
Brenda,
I appeal to
reality. Do you trust the fact that you experience a flat stationary Earth, that you've never seen any curve and no one experienced motion? Do you not trust your senses?
I don't experience a flat stationary Earth.
Well, you do. You've never seen curve.
No.
Apart from on
Yes,
TV
I have.
and on
Yes,
images.
I have.
Okay.
Where? When?
You've
At
seen
what
curves.
height?
Yeah, let's get those measurements.
Boats go over the horizon. Boats go over the horizon. That's curve.
the apparent optical horizon that is not geometric, that we can zoom the boat back in after it goes over?
You
by
can
increasing
never.
the resolution
You can
power of
never
the observer?
zoom. You can
Okay,
never zoom
somebody,
the boat
somebody,
back in.
yeah, you
Brenda,
can.
seriously,
Check the live stream voice
Brenda,
text
see
right
if a
now.
boat disappears at 3 miles, how small do you seriously think the Earth must be for it to go over the horizon? That is insane.
I mean, that's
You're
a
going to
All you have
roll.
is incredulity.
I'm going to give you a new rule.
He just said that.
Radio,
He just said that you
radio
can never.
frequencies, they shoot beams perfectly straight and
He said
level.
that you can
When they're
never zoom a boat
communicating
back
with
in.
other boats, whether they're 50 miles out, 100 miles out, these radio signals do not try to follow any curvature of the planet. So, like,
Actually, they will bounce. They will bounce back and forth between the ionosphere and the surface of the Earth.
that would have to happen on a flat plane for a radio signal to hit an object and actually come back. It would have to be on a flat plane.
That's not
Okay,
true.
but now he's.
Yes, it is.
Ionosphere
You can look up the
zone.
science of radio signals and all that. It'll tell you that. It's fine.
They bounce. Radio signals will bounce from the ionosphere to the land
not
and
the
back.
atmosphere. I'm talking about objects.
Show us your dome. Show us your dome, Brenda. What dome? You call it the ionosphere? What's it made out of?
Electric, can I ask a question?
No.
I want to know what
I
the
don't know.
ionosphere is made of.
I don't know what's going. I don't know what's
invoking
going
some
on.
Sort of dome. Brenda's invoking some sort of barrier that these radio waves are bouncing off of.
Yeah, the ionosphere. The ionosphere.
Is that like a dome? Is that like a dome?
No, it's not a dome.
But the radio waves bounce off of it.
It's a layer in the
What
atmosphere.
shape is it?
It's a layer in the.
Sphere, huh?
It's a
Sphere?
sphere.
Do I get to answer your question? Do I get to answer your question? Or are
Yes, you
you
can. I
done
just
yet?
wanna
Just
know.
let me know. Let me know when I can talk. Just let me know.
If the atmosphere is circular, spherical. Sorry, I apologize. If the atmosphere is circular, wouldn't that be like a dome?
No, it would be like a shell.
It'd be like a sphere, but wherever you're looking up,
Yeah, it would be like a sphere.
Semi-spherical dome.
Brenda.
Yeah, over your head.
It would be a shell. So when do I get to answer his question? Can I answer his question?
You just said
The
sentence.
ionosphere.
I'm sure you could
He
have
asked
said
me.
the question.
He asked me a question.
Well,
So-
answer it instead of asking if you can.
Well, if you could be quiet, please.
What do you mean? I just piped in because you're like whining that you're not getting to speak while speaking. But the point you made about boats going over the curve of the Earth, multiple images, zooms have been put into the live stream for you to take a look at if you want to go back to that, where these boats are brought right back into view again, and there's no obstruction whatsoever.
I'd like to answer the other guy's question first, please.
I know you'd love to just avoid the boats and images.
No, I'd just like to answer it first.
Go for it, man.
Man. Maybe I'll run into you.
So can I do that? Can I do that now?
Stop talking about
Have a
it.
go
Just
on,
do it.
Well, just let me know when I can talk.
You just could have said it there just now, but you're still whining. Why not just ask or answer whatever you want, mate?
Okay, so the ionosphere is a layer of charged atmosphere.
Particles.
It has a charge, right, in the atmosphere, and it reflects radio waves.
And it's a positive charge, yeah? Is that right?
Ions are positive.
And then down on ground, the ground's the earth, like the ground part of the
Negative.
circuit.
Thanks for proving the dome, Brenda.
That's not a dome. A layer of charged particles isn't a dome.
Have you been up there?
You can fly. You can fly a plane through it.
What is the speed of ionosphere?
I don't know. What the fuck do I know about it?
Well, it's keeping up with the Earth, so it must.
Is it ionosphere something around the Earth?
I guess so. Yeah. I don't know if it goes all the way around the Earth, but I guess so.
Okay, great. Because it's ionosphere. That means it's spherical. That ionosphere.
Yeah, just like the Earth.
Okay. What is the speed of ionosphere?
I don't know.
Well,
the radius.
For all I know, maybe it doesn't move at all. The air in it probably moves.
But it's got to be keeping up with the spin of the Earth, surely. And if the higher it goes, it must be going even faster the higher up there you go.
Can I try again? If ionosphere doesn't move, that means that air will go out from ionosphere.
Why?
Because there is something else, or everything is ionosphere after atmosphere.
I don't know what you're talking about, but the air.
Let's go back. Is it ionosphere something around Earth's sphere?
It's a layer in the Earth's atmosphere. The Earth's atmosphere is held to the Earth by the force of gravity.
That's not a force.
It's a pseudo force. Yes.
That's not a force. A pseudo force.
Yeah, but it's still a pseudo force.
So it's not a
I'm a
force.
pseudo pharmacist.
Doesn't mean it. It doesn't mean it.
It's a pseudo
It's
force
not.
that
It's a
you haven't
different sense.
demonstrated still.
That doesn't mean that I
It
got
means
a
that
license.
it means that it's not foundational.
So it's not a force.
Yeah, it means that I'm really not a doctor.
No, it means
I'm not
that
claiming
it's
I'm an
not.
actual doctor.
It means that it's not a fundamental force.
It means that it's not a force.
No, it's still
Literally.
a force. It's a force. It's just not a fundamental force.
Oh,
It's the cool story. That's why you weren't able to demonstrate it.
No, it is demonstrated with the Cavendish.
No, it's
You
not. You
demonstrated
didn't isolate
distance.
from confounding variables.
You're
I
independent
did. We did. That's why the balls.
Distance. Brenda,
Okay.
you do blatant, but you can rewind it on the live stream if you want. You said your IV was the fucking distance.
Yes,
So
you varied the distance. You varied the distance between the two weights.
So that's
What's
not
the
the
natural
cause, is
observed
it?
phenomenon?
The cause is the distance.
The force is inversely proportional to the distance. So yes, you're varying the force.
No, you're not
What is the
varying
observed
gravity from
natural
exponentially
phenomenon?
stronger forces.
If the strength of the force depends on the distance and you vary the distance, you've varied the strength of the force.
But
It has
it's
to be
not a
gravity.
force.
It can't be anything else.
Cause is an angle.
Where's the hidden camera?
Not
Is this
distance.
a hidden camera show, Brenda? Because what you're saying is like absolutely outrageous. I don't know how you can think.
Well, it's
these
just
things.
your incredulity. That's just
What was
incredulity.
that? Mine. You're telling me
Brenda.
your IV in a scientific experiment is the fucking distance. So you're not
Yes.
proving gravity. All you're doing is
Well,
proving distance. You're
the
claiming
force-
distance is related to gravity that you've not even fucking proved in the first place. You can't claim something
Right.
does something till it's been proven, surely.
The force
Begging
the
the
force
question.
varies with inverse proportion to the distance. Therefore, if you vary the distance, you're varying the force.
And how did you
What's the
prove
observed
this?
natural phenomenon?
What is the unit? for
That's the
that?
hypothesis. That's part of the
What's the
hypothesis.
observed natural phenomenon then? What's the observed natural phenomenon?
The observed natural phenomenon is an apparent attraction between objects having mass.
Where do you...
I didn't understand that.
So you're assuming that
No,
that's
it's-
what you're observing.
No, gravity is an observed phenomenon.
Can I ask a question? Can you give me an example of an observation where two things are pulling each other? As an
Well,
observation
what we
of a phenomenon
observed,
in nature.
right?
Well, this
so,
is what you said. You said the apparent attraction of two things. Where's
yes, yes. So Galileo conducted experiments with rolling objects down an inclined plane, and he discovered that objects fall down the inclined plane at the same speed regardless of their composition. Therefore, he hypothesized, or at least Newton did, that there is a force or an apparent force of attraction that attracts all objects with mass equally.
Oh my God.
So,
because that's what the gravity is. All objects, you can have a basketball and a cannonball. If you have a basketball and a cannonball, they will fall. They will fall at the same speed. A basketball and a cannonball will fall at the same speed.
The same.
And
Why do things fall at different rates at all?
They don't fall at different rates. They all fall at the same rate.
Like,
That's
I
not
can give you
true.
an example right now.
No, you can't.
Yeah, I can. I can drop a feather and a bowling ball. They're not going to fall at the same
You
rate.
have to eliminate confounding
Well, you have
variables.
to
So you eliminate.
Hold
Yes, you have to eliminate air
resistance.
resistance. You have to
Also, you have to
eliminate.
pretend that the air doesn't exist.
That's just doing a proper experiment. You eliminate confounding variables.
Wait a minute. Now Brenda understands. Hold on. Let me finish this out. Everybody be quiet. Everybody be quiet just for a second. Just for a second. Just for a second.
All right,
Yeah.
that's the end of that, Holmes.
Just wanted to say that now Brenda demonstrates that Brenda completely understands how the variables work in a scientific method.
But won't use them in our explanation.
I just want to know how you're eliminating the air. If the air can affect how things fall, then how would you ever demonstrate that things fall at the same rate?
Well, you would eliminate the air by putting the objects in a vacuum chamber.
That's not eliminating the air. That's minimizing the air.
Yeah.
Right.
Below the
Right,
tolerances of the instruments that you're using, that's good enough.
Oh, it's good enough.
That's good enough.
Yeah, it's good
You know
enough.
what, just roll with it anyway. Fuck it.
Yeah, if you
Well,
can't measure, if you can't measure the difference, then you've effectively eliminated it because, right? You can never eliminate anything absolutely.
So, so where is the observation that you've got for Cavendish? The apparatus was built on a naturally observed phenomena, and you've not got one.
So the observed phenomenon is Galileo's experiments on an inclined plane that showed that objects of different compositions fall at the same speed. Therefore, the hypothesis is that there is a force or apparent force of attraction between all objects having mass, and they fall at inverse proportion to the distance between the objects.
But you never proved this in the first place. You can't.
That's the hypothesis. That's the hypothesis.
But that's not been proven. You've never actually given us anything that proves.
The Cavendish confirms the hypothesis. It
Cavendish,
measures.
You claim Cavendish proves this.
Well, it doesn't prove. Science doesn't prove things. Science doesn't prove things.
You just used the word prove, so I just
there's a colloquial. There's a colloquial definition, and there's a proper scientific definition.
I'm surely I'm allowed to use that word if you just used it, and I replied specifically.
No, I can understand by context. So yeah, I can understand. I can understand what people mean, but sometimes people think. Sometimes people think that pedantry is. Sometimes people think that pedantry is what intelligent people sound like, but that's not true.
So. Again, where's the natural phenomena? You're claiming who's Galileo?
Galileo's experiments. Galileo's experiments of dropping balls down of different composition down an inclined plane.
How is that a natural phenomenon?
And what was his independent variable in this non-natural?
Those were observations of the phenomenon.
So just observations, so no experiment.
Yes.
So you've not got an experiment.
It's also an experiment because he dropped multiple objects and down multiple inclined planes and timed using a water clock how long it took them to fall. He used 7 foot long inclined planes, and he rolled objects down it of different composition, and he timed how long it took. And objects of different composition took the same time to roll down the inclined plane.
And how can that possibly be a scientific experiment following the scientific method? It's an observation.
Yes, it's an observation of a natural phenomenon. It suggests that there exists a force or apparent force of a mutual attraction between objects with mass that is independent of what they're made out of, and inversely proportional to the distance.
Are you saying that two objects with the same weight will fall on the same rate? Are you saying that?
Yes, a steel ball and a feather will drop at the same speed if you eliminate air resistance.
So, how come if mass attracts mass and there's more mass in the lead ball, why would it not fall quicker?
Are you saying that Galileo dropped the things in vacuum?
No, he didn't.
Oh, really? Right. Now I'm asking you: does two objects with the same weight will fall down on the same rate?
All objects, regardless of weight, drop at the same speed.
So, okay, listen this now. I have a sheet of paper, and then I have two sheets of paper. They have the same weight. One sheet of paper, I will, how to say, put, how you say when you push,
You have to eliminate air resistance. You know that, so don't even start that down there. You have to eliminate air resistance.
Galileo did that. Did Galileo did that?
He never eliminated it. You
Did
just admitted
Galileo
that he
did
never
that?
did this.
Is
So
eliminating air resistance a natural phenomenon?
Does Galileo, yeah, eliminate resistance of the air?
Yeah, you eliminate air resistance by dropping the objects.
Does Galileo did that?
Yeah, he didn't. He didn't.
He never had a vacuum chamber.
Why?
So
But
that's
he
not-
used because he used objects that were affected the same by the air resistance, right? He used small objects that would roll down. He didn't use a feather because a feather would not roll down the inclined plane.
Listen this, I will take the two sheets of paper and I will stay in my room without wind, without anything. This is only
Air resistance will still
okay,
cause them to.
Great,
great. Finish, Brenda.
Great, but the sheets of paper has the same weight. Now one paper I will push in my hand and I will make garbage, and I will drop it. That thing has the same weight like a sheet of paper, but we fall down before that sheet of paper. Do you know that?
Because of air resistance. I've told you this already.
No,
Stop wasting my time.
No,
Stop wasting my time. I've already told you that it's air resistance. Don't waste my time with this.
The shape of the
object.
Don't waste my time with this. You have to eliminate air resistance.
Okay, does Galileo did that?
Who cares?
I already said no. He used.
Why are you walking?
I already told you. I already said this. Stop wasting my time.
Why are you
Go away then, Brenda. We're having a discussion. Just chill.
But I already told. I'm tired of getting answered. I'm tired of getting dogpiled. Stop dogpiling.
Can I do one-on-one with Brenda just for a few seconds, please, guys, if you don't mind? So I've been pretty quiet so far. Brenda, thank you. I just posted something, right? This is from the drop tower. So this was done in a vacuum. And what you're going to see is they got different elements. They all weigh the same. And even though they weigh the same, they're falling at different speeds in this drop tower in Germany. Now, if you want to, I could find the original source, but for now, you're just going to take my word because I'm driving, that this is done in a vacuum, and they don't actually fall at the same speed.
Oh, okay. What's their explanation for that?
I don't think it needs an explanation. It's just a fact.
Yeah, I think it does need an explanation. Obviously, they were the people experimenting. They must have seen that as an anomaly and tried to figure out why that happened. What did they say happened?
Does it actually need an
You
explanation?
don't know. You just saw a video on YouTube. What can you show me a scientific paper?
A paper.
Okay, so does it need a paper?
Yes, I don't take videos on YouTube as being authoritative science.
But papers are not science.
Yes, it is.
Academia.
That's what science is these days.
No, science is a method to establish cause and effect relationships, and you need to follow it, or you're doing pseudoscience.
Published scientific papers are not pseudoscience. YouTube is not science.
So, where do you get your observation of the?
Of what? You cut out. He said something, and I didn't catch the end of it.
Saying where do you get the observation that the Earth is this?
You cut out again. I don't know what's going on. You're maybe lifting up on your push to talk. Where do I get the observation that the Earth is a globe? From pictures in space. Pictures in space from the ISS, right? From the Gemini, from Apollo, from satellites, right? We get pictures from space.
The ISS. What does the ISS show?
The Earth.
If you seriously
Does
think
the ISS
NASA
show the whole Earth?
The ISS orbits the Earth every, what is it, 94 minutes or something?
You said pictures. I was just asking you.
Yeah, live video and photographs
Of what?
from space
Of what?
of the
Of
Earth.
what, though?
Of
the
the
whole
Earth.
Earth or a portion of the Earth?
Some of them are the whole
Wait a
Earth,
minute,
some
you
are a
just said
portion.
you don't accept. You
What?
just said you don't accept videos.
Exactly.
How can we verify it's live?
Don't accept YouTube.
How
Holy
can we
crap.
verify it's live?
NASA's on YouTube. NASA's got a YouTube channel and it's on a. It's not even live. It's on a loop.
Guys. 1 second. 1 second. Let AI come through because we can barely hear him. So let him please come through. Thank you.
I mean, it sounded like we just heard you say that the ISS takes pictures of a portion of the Earth and the whole Earth. That's incoherent.
It orbits the Earth every, what is it, something like 94 minutes, and there's a live video feed of the ISS orbiting the entire Earth.
I can give you
Right, so
video.
you take that as a picture of the whole Earth?
Yeah.
No, that's not how that works.
Why not?
Oh my God, dude.
Well,
Because
why not?
pictures are an instance, not a video. You can't confirm.
Video is not an instance.
taking.
Video isn't an instance.
You never see the whole Earth in full frame, correct or incorrect?
You can with some of the photos.
Some of the photos from the ISS, you can see the entire Earth.
Not from the ISS, but some photos
Okay.
from space.
Yeah, try clearing that up.
From the ISS, there is live video of the ISS orbiting the Earth, making a full revolution.
No, there's video of
Yes,
the
there is.
ISS traveling above the Earth. There's no
Yeah.
evidence that that video means it's orbiting.
It's orbiting. Yes, it is. It completes a full
Keep saying
revolution.
it.
Yeah, it completes a full revolution.
Yeah,
around the Earth. There you go.
Yes,
Not
yes, there you
orbiting
go.
the Earth.
Thank you.
Those are
Thank
two
you.
different things.
Brenda,
Bro, you got to reconnect or something.
Yeah, if he's saying something and I can't hear anything. Yeah, he's having problems.
quite a bad signal, folks.
We didn't catch any of that.
No, I was just saying, you said that you didn't accept TV, media, shit like that. That's all you've got to prove that these people are in this tin can.
No, that's not all I've got to prove.
So what else have you got?
As far as the ISS, there's
Yeah.
all kinds of records. There's all kinds of records, right?
Yeah, I'm saying-
there's the building. There's the plans for building it, the actual
I'm
building of it, the launching of it, the launching of.
I'm asking you, how do you verify that what we see on TV, because you don't accept TV, we see these people, like, where is the proof? Plans, no diagrams, no evidence that they had
All
a
of
plan
that-
to waste millions.
all of that is evidence, right? That there is in fact a satellite in low Earth orbit, right? All of the evidence, the plans, the building of it, the multiple launches of material up there. It's assembly
You mean
in
the
low Earth
construction
orbit.
the construction that was going on at 17,000 miles per hour?
That
Yeah.
still doesn't prove. You
That's
say
all
that
evidence. It's evidence that lends support to my belief that it's true. Yes.
but you've still, the only thing you do have is the TV, though, to confirm it.
Hey, thank you for being honest, by the way.
there's
Thank you for being
yes.
honest. Hold on. Let's just take credit.
I'm happy to be honest. I'm happy to be honest. I will admit a good deal more than you probably think I will.
Yeah, fair. So your next moral aptitude test is to not interrupt people. So anyway, thank you for being honest that you do indeed just have a belief that you believe is informed and that it's
Yes.
not knowledge. Thank you.
That's what knowledge is. Knowledge is an informed belief.
No,
that's what
it's a
knowledge is.
justified belief.
Yeah, that's what I used your word. I could have said justified. I have a knowledge of epistemology. So yes, knowledge is a justified true belief,
Way to
or
go.
if you want to say informed.
At least you're admitting that it's a belief.
Yeah, all knowledge is a belief.
No, it's not
Yes.
belief. I don't believe that I'm not moving right now in 4 vectors at millions of miles per
Yes,
hour.
you do. Yes, you do.
No,
Of course you.
No, I
Do you-
don't. That's self.
Do you think it's true? Do you think it's true that you're not moving?
Can you look up the definition of belief?
Is
in
it
the
true?
dictionary?
Is it true that you are not moving?
Well, my vestibular system in my ear, for starters.
Is it
my
true?
inner ear. Well, I accept it. So it's
Yeah, you accept it as true. That is what a belief is. A belief, a belief is a sentence or a proposition that you accept as true.
No.
I got a
Yes.
definition. My definition's kind of funny, right? Because I just made it up. But I think it's a good definition. So you have
Mine
first-hand
is not
knowledge.
made up. This
Hold
is
on.
the standard epistemological
hold on.
definition of beliefs.
Cool. Can I speak? So basically what I'm trying to say is everything that you experience, you have first-hand knowledge. Everything else that doesn't exist within your primary memory and first-hand present experience is belief. Thanks.
No, experiences are not knowledge. Knowledge is constructed from experiences.
So when I got punched in the face when I was walking home from swimming in the pool by a guy that I didn't see coming, do you think I believed he punched me in the face, or do I know he punched me in the face?
You use the evidence of his fist hitting your head as confirming your belief that you had just gotten hit in the head.
That's not a belief.
Yeah, that's a belief. You believe it's true that he hit you in the head.
Brenda, take a look in the live stream voice text at the definition for belief, for God's sake.
I'm using the definition used in epistemology. In epistemology, a belief is a mental content that you accept to be true.
Brenda, does water believe? Does water has beliefs?
I didn't understand. Water has beliefs?
Okay.
Water doesn't have beliefs.
Great. Does you have beliefs about water?
Yes, I have beliefs about water.
Do you think that water curving?
Water conforms to the surface of the earth. It is level.
Perfect.
That's contradictory.
No, that's what level means. Level means conforming to the curvature of the earth.
No.
Cool. Show me a definition older than 10 years old that says that.
Oh, yeah, it's on McToon's. It's on McToon's. Yes, it's on McToon's.
Is it older than 10 years old, or did Globe?
Yeah, it's from the 19th century. It's from the 19th century surveying manual.
Why does it conflict with the definition of horizontal?
Because people are allowed to use words in different ways if they want to.
Oh, just like you done there just now with.
Yes, you just have to be consistent. You can use words in different ways if you want.
Brenda, you move the
I am consistent.
Constantly. You constantly change what you've said. You change your position. You add shit on. You assume stuff. You claim people from fucking centuries ago did shit.
Thank you, Brenda, for double speaking. Thank you, Brenda,
listen,
for double
Sasha, you're on to it, okay?
Yeah.
I'm pretty sure that people from centuries ago did shit. Yes. I have no problem with
That's
that.
great. Let's talk about current technology. All right, Sasha, you said the same thing 4 times in a row. Now, Sasha's onto it, and Brenda admitted that according to the Globe claim, that the level water is conforming to the surface of the ball, allegedly. So, if that's true, all that needs to be done to falsify this proposition is to measure some water and prove it's not curving, and the proposition fails.
Sure.
Now, that setup, whether true or not, would you agree that that would be correct?
Sure. Do you have a measurement of how flat the earth is? You got any measurements?
How come you changed the proposition?
Yeah, I have, Brenda.
Do you have a measurement of the earth being flat?
Brenda's asking me, Sasha.
Okay, sorry, I have it.
Doesn't matter.
Okay, no, I just want you to just say that if the claim that you said is true.
All that matters when it comes down to it, that's all that really matters.
So I will readily admit that level means conforming to the surface of the Earth, of the
Holy
curvature of
crap!
the Earth.
Shut it.
Yeah.
Him interrupting me wasn't your cue to overtalk.
You weren't talking.
Yeah, I was. He interrupted me, and then you went.
Oh, I didn't hear him.
Oh,
Okay,
man, if
legit.
I interrupted, I didn't mean it. Sorry.
Yeah, that's fair. Your connection's horrible. That's why at the moment.
Sorry, folks.
You're coming in, then you're not coming in, so it's kind of hit or miss. But whatever, it's fine.
Go, bro.
That's what we got to deal with in this, 21st century of satellites and internet everywhere, right? But anyway, I just want this proposition to be accepted or unaccepted. It could be a yes or no.
I thought I already said yes. Yes. Level means conforming to the curvature of the Earth.
Okay, that's not the question.
I thought it
The
was.
question is, if that's true, then that means that water must be conforming in that manner. So if you can measure water not to be conforming in that manner, then that disproves the proposition.
No, that would be
affirmed.
that would be affirming the consequent. So
No,
you would need to you would need to do need to do a modus tollens.
Holy crap, dude! Are you serious right now?
So do you have a measurement? Do you have a measurement of how flat the Earth is?
We're not even going to talk about that until you concede the proposition one way or the other. Okay, so check it out. I'll rephrase it a little bit. If it's not curving in that manner, the water, then that means the Earth can't be a globe. Correct or incorrect?
I think that that's affirming the consequence, so I'm not sure that that would be true.
It's not affirming the consequent. If something's not curving anywhere, what is it? Now, this doesn't mean it is or isn't. It's just propositional logic. If something isn't curving anywhere, what is it?
Well, I'm thinking that you want to show me, for instance, water in a glass, in a drinking glass, and say that that's flat, and therefore all water is flat.
Stop thinking ahead. The proposition stands or falls on its own merits. If something isn't curving anywhere, what is it?
It would be flat and even, yeah.
There you go. Perfect. So if you measure water, and now obviously we need a sufficient sample size, not just water in a glass, as you accurately stated. Right? But remember, we set the baseline that in the globe model, water must be curving around the ball. So if we disprove that that curve exists and it's not curving, then that means all the water's not curving. And that means that it's not curving anywhere, which means you've already conceded that it's flat and even. So all we need is a sufficient measurement. Hold on. If we had a sufficient measurement, right, would that prove or disprove the proposition? I'm not saying it exists at this point. I'm just saying if.
We need to see that, yeah.
Okay, perfect. Perfect. So you take a laser over a 25-mile body of water, you set it up 6 feet on one side, you set up a storyboard 6 feet on the other side, you hit the target, and you disprove the curve of the Earth.
Yeah, but they didn't do that, did they?
Yes, they did.
It broke. The collimator broke.
Collimator's irrelevant. Collimator's irrelevant.
It's pretty important, isn't it?
No,
Isn't
it
it?
isn't.
I think it's pretty important.
No, if the
It's
Earth
not
curves in the manner you say.
They weren't able to do it over the curvature of the Earth, and there's no controls over that. They just pointed it at the target. How do I know it was level? That is not. That is relevant.
Hold on. Okay. We're not going to be sidelined. We're not going to be gish galloped. We're not going to be over talking each other. We're not going to be losing the points. Okay. If anybody knows anything about gunnery, if you hit the target, you've hit the target. It's irrelevant whether you have a certain shot group or not. If the target is hit, the target is hit. It's that simple. Now,
yeah, but that doesn't show that the bullet. That doesn't show the bullet traveled in a straight line.
Well, if the Earth
that's correct with a ballistic object. You are correct that that's correct with a ballistic object. Are you claiming that a laser is a ballistic object?
Lasers are subject to refraction, aren't they?
I'm so glad you said that. I'm so glad. So, the common excuse to get away from the fact that they hit the camera and scanned the image on the camera with the Gaussian profile of the beam centroid of the original laser, proving that the original laser beam hit the camera. The camera was only about 6 feet off the ground. Okay, so the variance still stands. Now, this differential in this test is 2 orders of magnitude off the globe prediction. And you are correct, to be fair to you, that refraction is the standard answer given to explain this away. Here's the problem. The United States military contracted a university along with Boeing to conduct a test of lasers for accuracy, for systematic use in military applications. They conducted the test and then they analyzed the results. Here's the thing. They used 3 different color lasers. When they went back and checked the results, they found that all 3 lasers hit the target. 120 kilometers was this test, commissioned by the military, done by a university in cooperation with Boeing. Now, what I just said should be sending shivers through anyone's spine who knows anything about this stuff. Because here's the problem. 3 different colored lasers would refract at different rates because refraction is wavelength dependent, which means they would arrive at the target at different locations. They didn't make this prediction. This was post of the evidence where they analyzed it. They found that the globe model was defeated based on this reasoning. All the lasers hit the target and they should have been separated by 20 feet, and they weren't. This proves categorically that the idea of atmospheric refraction defeating these long distance observations or laser tests is false by experimentation, direct observation and measurement, proving that this type of refraction that you need to save you from this observation or the laser test doesn't exist. So I rest my case. I'm done here for tonight. You guys enjoy dealing with this defeated glober all you want.
Can you send me the study? Can you send me the study?
Absolutely.
Great.
Yeah, while you're looking
be
over, I
rather
want to
quick,
say something.
Well, before you go on, so we have it posted a bunch of times in here. I'm going to try to remember the title, and then I'll be able to search it. 1 second.
Thank you. Yeah, I just want to point out one thing. So when they so-called they said that they proved Einstein correct, and that they could see the telescope that was pointed at the mirror, that was pointed at the sun. They could see the stars that were allegedly behind the sun. So if you do believe this kind of refraction is possible, then do you not believe in the heliosphere? Not to take that off the topic of what just was said, right? I think it's really important what AI just said, because either you believe in the refraction theory, right? Which, if that's true, the heliosphere could cause the light to bend around the refracted, I can't say atmosphere of the sun, but that's what it is basically, right? In layman's terms, the heliosphere is the atmosphere of the sun, right? And the different layers of density will cause it to refract. If you believe that, then there goes your space-time. Bye-bye gravity. If you don't believe that, and you believe the turbulence, right, then you believe in the flat Earth. So either way, it's double whammy.
Yeah, I don't think the amount that was predicted by Einstein is the amount that was observed in the Eddington experiment. It was not due to refraction. It was greater than the amount predicted by refraction.
And how did you remove the heliosphere variable out of that to prove that that's true? Or did you
the amount predicted because we know the refractive index, right? So the amount predicted by refraction is different than what was observed. Yes, you can figure these things out because you know what gases are made out of. You know the refractive index of gases. The sun is the ball. The sun is a ball of gas, a plasma, right?
Vacuum.
And gases have a refractive index.
Can you have gas pressure in a vacuum without separation?
Of course, it's gravity. It's the gravity. Yeah,
You never
we've been
demonstrated
through
it.
that. We've been
No,
through
you
that.
didn't. You didn't isolate your pseudo force from
We
the
did.
exponentially stronger forces of electromagnetism and electrostatics that are
did.
present in all intermolecular
by
interactions.
using materials that are not affected by magnetism.
That's not what your wooden rods and balls do. There's still electrostatics and electromagnetism present, and you admit yourself that the direct variable that you're manipulating isn't even gravity, and still there's this exponentially stronger force.
There's no
still present.
static charge. There's no static charge.
It's present in
on
everything.
the weights. So then it's a wash, then, isn't it? If it's present everywhere, then it's the same everywhere. Then it doesn't affect anything.
Can I ask a quick question?
Go for it, bro.
Does a gas produce a gravitational field?
Yeah, because it's matter. It has weight.
Where can this be demonstrated?
Gases have weight.
Where can it be demonstrated that gas produces gravitational field?
Well, that they are affected by gravity?
No, I asked you whether gases produce gravitational fields because you said a ball of gas is existing in a vacuum because of gravity. So I asked you if gravitational force can be generated by gas itself without solid matter.
Yes.
Is there an example of that?
Gas is matter. It has weight.
But it's not solid matter, right?
It doesn't matter. It just has to have mass.
Does a particle have mass?
Yes.
Okay, then why don't particles generate gravitational force?
They do.
That's not what the standard model of particle physics says.
Yes, it does.
No, it doesn't.
Yeah, it does.
No, I can post it right now if you want.
The standard model of quantum mechanics, right, doesn't include gravity.
Particle physics is the theory describing.
Yes, it doesn't include gravity because because general relativity and quantum mechanics.
That's why they exclude it from particles.
No, that's not why they exclude it.
Affect particles.
That's not why they exclude it.
Why
they
do
exclude
it then?
Because there's no unified field theory.
Well, that doesn't really help your relativity then, does it? Or your gravity?
Gravity, all objects with mass, including particles, including atoms, are affected by the gravitational force, right? And so there are stellar nurseries out in space. They're clouds of gas and dust from which stars are born. It's observed. You can see it.
You can see what?
You can see the stars born in these clouds of gas and dust.
No, you can see these light above you, whatever they are, and you believe the story you've been told, Brenda.
That's what the pillars of creation are. It's a very famous photograph. No, you can see it. It's dust. It's dust and gas. You can see it. And in that dust and gas are stars being born. There are stars being born in the pillars of creation photograph.
Brenda, that's not a photograph. They are not photographs. Those images, they're taking multiple different wavelengths of light, and it's all put together by probably supercomputers, I would imagine. Right,
so what?
Claimed it was a photograph. They're artistic renditions of the data.
No, they're not artistic. They're technological.
They are. They're done by data visualizers. I think Mr. Blue Marble, Mr. Simmons.
Are they different? Are they different from the insides of your camera? Your camera takes photos in red, blue, and green and combines them with the computer that's embedded in the camera. Are you saying that your camera's photograph? That's not different. It's the same. It's not different. It's the same.
Cameras. Oh, what about cameras that are not digital?
What?
What about cameras that are not digital and that don't
what cameras? What the cameras in your
like the earliest cameras?
What are you talking about? Cameras today are digital.
Today, not all of them.
My child has a Polaroid camera.
The point.
My child has one.
It's ancient technology.
The point
I
is,
bought it brand new for a
Hubble
birthday.
does not take photographs.
So cameras work by exposure, right? And they have you can use different filters and photograph in the red, blue, and green, and then combine it to produce a final photograph. You can do that.
But what you see in these Hubble images is not what the data shows.
It's literally based on the data. It's literally based on the data. You're right. You're right that it's all data. It's data coming from an instrument. No, it's not artistic. It's data from an instrument.
What kind of instrument? What kind of instrument is making pictures? What out of data?
It has a sensor.
Okay, so there's clouds in outer space now?
Yes.
So explain that one to me, please. I'd love to hear.
There are clouds. It's called the Pillars of Creation. It's a famous image.
What are they made of? What are they made of? What are the gases
Dust,
made of?
dust and gases.
Dust and gas. Gas exists in a vacuum.
Yes.
Can you demonstrate that on Earth?
I can show you the image of the clouds of creation.
Can you demonstrate gas in a vacuum on Earth? Can you do that?
It would expand to fill the vacuum chamber. It definitely would.
How? If in order to create a vacuum, what has to happen?
It's very, very big. The pillars of creation are light years across.
Because we're talking about from our observations here on Earth. When you create a vacuum in a chamber on Earth, what happens to what's inside?
If it's a block of wood, nothing happens to it. But if it's gas, it'll expand.
Where's it going to go? Is it going to stay in the vacuum or is it going to go somewhere else?
It will stay in the vacuum.
Hey, Brenda.
I'm listening.
What happens to the gas in the chamber? Hold on.
I told him. Did you? Didn't you hear my answer? I thought maybe you didn't.
It's wrong. It's wrong. First off.
What do you mean it's wrong?
Do you know what the NIF is? You know what the NIF is?
Well, do you think that gas doesn't fill the vacuum chamber?
I'm asking
you a question. Kind of what
do you
think.
know? Do you know?
No,
what
I don't.
NIF, okay, the NIF.
I don't know what NIF is. I don't know what that is.
It's the National Ignition Facility that's in California. Now, what they do here is they conduct high-powered laser experiments in a vacuum. So, in order for the experiment to not be contaminated, they have to remove everything out of the vacuum, right? All that's gases. There's no gases in there in a vacuum.
That's what a vacuum is.
All right. So, how are clouds existing in a vacuum, dude?
Because its space is really, really big.
Come on.
Those
can I just quickly
get posted an image of the pillars of creation. Those pillars are light years across.
Can I just
created by visual artists.
No, it's an image.
Listen. I'm on space.com right now, and one of the visual artists says some of the most striking views in astronomy have come from the Hubble Space Telescope, but the data collected by the spacecraft comes in the form of spectrums of light, and they create them. It says it's a fantastic telescope, but it can't observe everything. Visual artist Louis Calder said that he's a graphic designer for ESA, and he works making artistic renditions from Hubble data.
Yeah, that's fine.
You just fucking said
that's a funny way of saying cartoons.
Guys,
he isn't inventing. He isn't inventing data. He isn't inventing data. He's adjusting levels in Photoshop.
No, they're making animation. They literally claim on space.com that they're creating animations.
Yes, of course they do. So does NASA.
Yeah, we know that, bro. We know that.
So what's wrong with that? What's wrong with that?
What's wrong
with creating cartoons and passing them off as reality? That's what you're asking?
They label them as an animation. They label them.
And that doesn't.
It's not a photo. Brenda, my honest to God, like it's like outrageous the things that you say and you accept.
Let me ask him a
Yes,
question.
all I do is give you high school level science. That's all I do.
Yeah, high school level. You said it yourself.
Brenda, can I ask you a question real quick about what you were saying about a vacuum? Did I hear you say that a vacuum is somewhere where there's no gas?
No, he's saying
that
that gas
correct?
can exist in a vacuum. That's what he's saying.
In the vacuum of space, there are regions where there are clouds of dust and gas. Yes.
Okay, so, but what is a vacuum? Can you define that really quick?
There's regions in space where
No, I'm
there
not talking
is
about space. What is the definition of a vacuum?
low pressure.
Low pressure. All right, let's go.
Right. So it's an area of low pressure. There are areas of low pressure, and there are other areas where there are clouds of gas and dust in a low pressure environment, and they gradually coalesce. They gradually.
Where have you seen this? Where have you seen
The pillars of creation. The pillars of creation.
That doesn't count, dude.
And
Yes, it does.
Brenda,
It does count.
You keep saying this over and over. How would you verify
Because you keep
that,
asking me the same questions over and over.
No, it's not the answer. How would you verify that?
How would I verify what?
The dust of clouds in a vacuum. The
image provided by NASA is verification.
That's enough for you. That's enough for you.
Yes, yes.
Cartoons are verification. Wrong.
It's not a cartoon. It's not a cartoon.
It is a cartoon.
No, it's not.
Yes,
it's an animation.
No, it isn't.
You agreed it was
it's
animation.
It's a compilation.
The Pillars of Creation is not an animation.
It's made by artists.
No, it's based on raw data.
No, it isn't. You wouldn't know raw data if it jumped on your face and spun around and whistled Dixie.
It's manipulated.
Even if you saw it, you wouldn't know what data was. Please.
So crazy, bro. That you guys, do you understand how asinine this whole subject sounds? The how you guys just hand wave it. They say it so it's true. That's all you do. They say it so it's true.
And at the crux of it all, at the crux of it all, you got no globe for any of this. That's kind of the base of your whole paradigm. You're going to need the globe.
We've known the Earth is a globe for 2,600 years.
You don't know that because we falsified that.
It's a religion. You have to accept it, blindly accept it, listen to their books.
Don't blindly accept
what they say. Yes, that's what astronomy is.
No, that's not what astronomy is.
You don't. Your physical body.
That's not how science works. That's not how science works.
Numbers are using to measure outer space. Okay, so you don't have the actual ability to experiment within astrophysics with your own mind.
Of course you can.
Okay? So when they tell you something like the size of this shit, bro, you're just believing them blindly. It's a fact.
And
I'm not believing them blindly. I accept them as the relevant
paradigm on.
I accept them as relevant field experts.
Okay, well, let's see the surface measurements of curvature you've still never provided then. Because that would be the basis of everything you're talking about.
Ships go over the horizon.
Okay, we already dealt with that. Did you look at the live stream voice text when they showed you ships going over the horizon and then getting zoomed back in? Something you said never happens. Did you look at that?
Those were ships that horizon.
So they disappeared. They went over the optical horizon, which is all the horizon is.
That's
then we zoomed them back in.
That's not the optical horizon.
Them again. This is exactly what you said can never happen.
Just because
it did happen, and now you're adjusting your claim. So you're just a liar.
Just because you can't see a boat doesn't mean it's gone over the horizon.
Okay, but that's what the horizon is.
No, that's not what the horizon is. The horizon is a geometric limit that obstructs your view.
So what is it?
Okay. So it's at 1.2 miles at a 1 foot height. Then is that where it is? That's where it would have to be if your radius is true.
Yeah, that is about 1.2. Yes, that would be about right.
I'm a person who's seen the black swan before, so again, I think you're just lying.
No, I understand the the black swan. It's a fallacious argument.
Black swan shows that your horizon is not geometric; that it is apparent.
The proper way to put it is to say that the apparent horizon would be no less than 1.2 miles, not no more than.
Okay, so it's not geometric.
No less than.
The horizon does not obey the constraints.
No
the horizon
less
does
than.
not obey the geometric constraints of the globe that you just claimed that it did. So it is just an apparent phenomenon.
It follows the model of the Earth, including which includes
black swan if it did that.
Which it includes reaction. It includes refraction. It includes refraction.
No,
where's your refraction model?
This guy's crazy.
Where's the refraction model? Show us the model.
Refraction? Refraction? That's Snell's law. That's just basic.
That's based on media.
You're done with, media, bro. You're totally done with now because you're reflecting. Snell's has to be hitting reflective surface angled away from you at almost 70 feet below your line of sight. Overdone. Match. Game. Set. Is over.
That's not what Snell's law says.
Is air two different?
Yeah, it would make your image going up above your head.
No, it does. That's not what it says.
You don't have.
A plane of incidence. What is a plane of incidence?
The angle of incidence. You mean? Not plane.
No, it's called a plane.
No, it's called the angle of incidence.
No, it isn't. No, it
yes,
isn't.
it is.
The
yes,
angle is what the light does after it
sine of theta.
The surface. You don't know anything about it.
Snell's law is sine of theta 1 over sine of theta 2.
Plane of incidence.
Sine of theta 1.
Okay.
That's an angle. Theta is used in trigonometry. Theta is an angle.
It's there in the live stream. Plane of incidence.
Religious chanting.
Just saying.
Well, yeah, what does that surface look like that it's bouncing off of? Is that a curve?
That's plane of incidence. That's not Snell's law.
This guy.
That's not Snell's law. That's a law of reflection.
Yeah, Snell's law requires two different isotropic media, doesn't it?
Yes, like hot air and cold air.
How is that isotropic?
Because they have different density.
What does isotropic mean?
It means that they're different.
I thought ISO was same and ANISO was different, but we don't need to.
Kidding? ISO's the same.
Over the semantics. As far as I remember, ISO is same and ANISO, or with an "an" in front of it, are different. But I'll have to double check that. Anyway, as far as we can tell,
all right.
deals with going from medium to medium. As long as we consider air one isotropic, same continuous medium, it doesn't go from like water to air.
You don't get.
So there's a problem there.
You're correct. You're correct. I was wrong. Isotropic means the same, right? So you won't get refraction in an isotropic medium.
And that's why we're a little confused, because air is looked at as one medium. Usually if you're dealing with Snell's law, it would be like from air to water or something like that.
No, if the air has different density, like it's cold or it's hot, then it will have different density. It will refract.
And as far as I can tell, with the way that they put refraction over a ball, they just basically go with at least terrestrial refraction by acting as if it's a bigger ball to flatten it out. Which for the
terrestrial refraction is just refraction. There's nothing special about the refraction of objects on the Earth.
Because that's assuming what was first be proved. If you're working or baking into your model refraction, that already assumes a ball or a bigger
refraction.
ball.
Refraction is just refraction. That's all it is. It's just refraction.
How do you interpret refraction? Are you going to interpret it toward a ball or towards something flat, like, a flat surface? What are you going to do?
I don't know what you mean by how you interpret refraction. Refraction is just refraction.
Well, we can reapply refraction. I mean, over a flat Earth, eventually the sky and the ground would meet because of compressed viewing angle. And refraction could be reinterpreted as making things balloon or pop out of this diffraction limited zone, or, compress into this zone sooner or later. So
I don't think you know what diffraction limit means.
I think I know enough to challenge the theory. You're a smart person. You're a smart woman. We're smart people. We can figure this stuff out without the experts, with or without them. And so we need to see how we're applying refraction and whether or not it's, consistent with evidence, facts, real life, other theories or not.
Right. So the black
If I can just
swan
quickly
image.
interject. Do you remember AI talking to you about the laser test that the Air Force and Boeing did? I think he just posted it in the live stream. You said you wanted the
I
data.
don't see it.
It's right there. He just
Brenda,
posted it
can I
like a
just
minute ago.
ask?
I see
Brenda,
it.
you know how you claim that boats go over the horizon? Do you mean optically, just with your eyes, or do you mean they go over the horizon when they get to the limit of the instrument you're using?
I mean that they are physically obstructed by the curvature of the Earth.
No, they're not, because we can zoom them back in after they go over the horizon just by
If you can
increasing the
zoom it
resolution
back
power of the
in,
observer.
if you can zoom it back in, it hasn't been physically obstructed.
There is no physical obstruction. That's the entire point.
That phenomenon of obstruction is observed.
No, it's not, because it would be at
Yeah, it is.
1.2 miles times square root of observer height in feet every single time if it were being observed, but it's not, even by your own admission, and you use an ad hoc excuse for why that is. So you don't have a geometric physical horizon that obstructs anything.
The black swan strawmans the model that we're using.
It
strawmans it because the proper way to formulate it is no less than, not no more
So
than.
what's happening in the Black Swan video then? So what's happening? Tell us, please. What's going on?
Magic.
There is high degrees of refraction that is lifting up parts of the.
Okay, how did you know that? And can you quantify it? How much exactly? How much? Put it into numbers for us.
We don't have the
just
measurements.
How much you need to make that work.
We don't have measurements.
Then it's just an ad hoc cop out, like I said it was, because you just by your own admission right now you don't have the measurements. You don't even know how much is going on. It's just however much you need to make that work on your globe fantasy. Well, you need to inflate your radius by 2 orders of magnitude to make that happen, and your standard refraction model doesn't even come close to claiming that's even possible. So no.
You people are the only people on Earth that are saying these things you're saying. It is so retarded. It's beyond belief.
I'm not the only person on Earth. This is majority. You're a tiny group of people, maybe a few hundred people.
Wishful thinking.
Yeah, that your anti-flat earthers are the smallest percentage of anybody on the internet. You're the only one saying this stuff.
No, I just meant not the internet, but globally, all around the world.
Right. I mean, you're exactly right. I mean, there are lots of people who just look at the screen and believe what they see on the screen and don't really question it, and that's fine. We have a perfect right, right?
I'm going to agree with him, so you should let me talk. I'm going to agree with him. I'm going to say that yes, a lot of people just blindly accept what they're taught in schools. You're correct.
Yourself.
Yeah,
like yourself.
No.
You believe
You're Exhibit A, Brenda.
The difference
you
between
believe in
us
Galileo done experiments. You believe the shit you see in the sky are clouds. You believe literally that. See, for to be a globe Earth believer, you've got to accept a hell of a lot of contradictory shit.
And the difference between you and us is if we're proven wrong, we will happily go back to believing what you guys believe. You shut us up, we will shut the fuck up. We wouldn't care. We'd love to go back to believing in Star Trek and shit like that. We'd love it.
I don't believe in Star Trek. I don't believe in Star Trek. That's TV. That's fiction.
I'm just saying. Listen, I'm just
you know
saying,
what he meant, for fuck's sake.
We would happily go back to that. You guys can't even say that. You guys
what
can't
can't
even
we say?
You can't even say, well, if we're wrong, I'll happily believe what you guys believe. But you won't even do that because you guys just hand wave everything and say we're wrong without even giving the opportunity to believe it.
If you could show me evidence. Do you have measurements? Do you have measurements of the flat Earth?
You do. You hand wave them and you ad hoc. Yeah, that's what you do. You make ad hoc excuses from. We just talked about one. The Black Swan measures the horizon to be
it doesn't.
2 orders of magnitude beyond what your Earth radius allows, and you just ad hoc hand wave it away.
I told you it's a fallacious argument.